In this lecture, we will have a quick overview on what GitHub Actions are and how they work and what we can use them for. And then in the upcoming lectures, we will get more into the details. So what are GitHub Actions? GitHub Actions is a tool that lets you automate your software development workflows. You can write individual tasks, which are called actions, and combine them to create a custom workflow. So what's a workflow? A workflow is a custom automated process that you can set up in your repository in order to build, test, package, release, or deploy a project that has its code hosted on a GitHub repository. So this might sound a bit vague, so let's take a look at a diagram that will help us understand this process more clearly. So let's say you have a GitHub repository, and on this repository things can happen. Things like someone pushed something, or a pull request was opened, or an issue was created or closed, and so on. And these things are referred to as events. And we would like to perform some workflow when these events happen. So a workflow, as we mentioned earlier, is a bunch of actions that you run where each action performs a certain task. So a workflow, for example, can be testing and deploying your code when someone pushes to master, or run some tests when someone opens a pull request, or maybe send a Slack message when an issue is created, and so on. We might also need a workflow to run on a regular schedule, like for instance, every 6 p.m. Every day. Or they can even happen when an external event happens. So something that happens outside of GitHub can trigger a workflow to run on GitHub. Alright, so where do these workflows run when some event happens? They run on a virtual machine on some GitHub server. A workflow can contain one or more jobs, and each job runs on its own virtual machine. So let's assume an event happened on our repository, and that we have configured some workflow to run when that event happens. A virtual machine will be booted up for each job that we have in our workflow, and this virtual machine can be a Windows virtual machine or a Linux or a Mac OS, and we can even run Docker containers. For each job, we define a bunch of steps, and each step should either perform an action. So as we mentioned before, an action can be something like deploy the code to some service, like Heroku for instance. So we can have a step that performs some action, another step that performs another action, and we can also have steps that will just run some shell command. So something like echo some string or npm install or anything like that. And as we mentioned, a workflow can have more than one job, and each one will run on its own virtual machine. And they can run in parallel, or they can depend on each other. And this can be very useful, especially if you need to perform actions that require different operating systems and that can be run in parallel. So let's say, for example, you need to write a workflow where you have to build an iOS and an Android versions of an application. So what you can do is you can have two virtual machines running in parallel. One with a Windows or Linux operating system for building an Android application, and another one with a Mac OS operating system for building the iOS version of the application. And both of these jobs can run in parallel, and they can also wait for another job to finish first. So let's say, for example, we have a job that will run some tests for our code, and of course we need to make sure the tests were successful first before building our Android and iOS applications. So with GitHub Actions, this is also possible. We can wait for a job to finish first, and then run some other jobs either in parallel, or also we can run them one after another. So that's a general idea on how workflows and actions work. And as we go deeper in the course, things will become more clear. Let's just briefly take a look at some other terms that may be a bit less important, but you should also know about them. So we have a runner, and a runner is any machine with the GitHub Actions runner application installed. The runner is responsible for running your jobs whenever an event happens, and also displaying back the results. A runner can be hosted by GitHub, or you can host your own runner. So a GitHub hosted runner, as we mentioned, when we run a workflow, this workflow will run on a virtual environment on a GitHub server. So this is a GitHub hosted runner. It can be a Linux, Windows, or Mac OS. And also in these virtual environments, we have some pre-installed software that is commonly used. And we'll take a look at this in a moment. GitHub hosted runners are maintained by GitHub, so that's a good thing. However, we cannot customize the hardware configuration of these machines. So if we ever needed to have our own hardware, this is also possible using self-hosted runners. So self-hosted runners are machines that you manage and maintain, and they must have the runner application installed. Of course, you have more control of hardware, operating system, and software tools. In GitHub hosted runners, you get what GitHub offers you, but here you can control everything as you like. And this is ideal if you need to control hardware, for example, adding more memory for larger jobs, or choose an operating system that is not offered by GitHub hosted runners. In this course, we will use GitHub hosted runners, as it is, of course, very easy to use. And I think in most cases you will not have to have a self-hosted runner, but if you ever do, just keep in mind that you can do it. Alright, so when we mentioned GitHub hosted runners, we mentioned that we have some pre-installed softwares included in our virtual environment. So this includes tools like curl, git, npm, yarn, pip, and commonly used command line tools like that. It also includes languages like Python, Ruby, Node.js, and things like Android SDKs and Xcode. I'll leave you a link in the course links with all the softwares that are available for each operating system in GitHub hosted runners. Right, so let's have a quick summary of what we have discussed in this lecture. We have mentioned a lot of terminology, so it could be confusing. So let's just have a quick recap. So we've talked about events, which can be a push or a pull request opened, or an issue opened or closed, or anything really that can happen on a GitHub repository. And when these events happen, they can trigger a workflow to run. Workflows can also run in a regular schedule or by some external event, as we mentioned. And we'll take a look at these in more detail later. So what's a workflow? A workflow contains one job or more, and each job performs some steps. A step can perform some action, like deploying code, testing code, stuff like that. So these are actions, and it can also run some shell commands. This workflow will run in a virtual environment that is provided by GitHub. And finally, we have just discussed runners and GitHub hosted runners and self-hosted runners. Great, so now we need to take a look at writing workflows in action. But in order to write workflows, we need to learn first about the YAML format. So let's take a look at that in the next lecture. GitHub workflows are written in the YAML format. And YAML format is just a data serialization language, which is very similar to what JSON is. So if you know JSON, it's pretty much the same thing, but it's written in a slightly different format. And if you already know about YAML, you can skip this lecture. I'm using VS Code here, and I'm having an empty folder opened. It just has some VS Code configuration and Prettier configuration. So Prettier, just in case you don't know, it allows you to format your code, and you can set it to also format your code instantly as you save. So let's say I messed up this indentation here and save, it will auto format. And this is just the configuration for Prettier. But in order to use it, you also have to have the Prettier extension, VS Code extension installed. So I'm going to go to extensions. I'm hiding the activity bar, but I'm going to show it for now. Go to extensions and Prettier, and I have it installed. Also, I have a YAML extension installed, and this will autocomplete and also validate your YAML files and show errors and stuff like that. And I also have a YAML to JSON extension that will convert YAML to JSON, and we don't need that. I will just use it in this lecture just to compare between YAML and JSON. So let's go back to our folder. I'm going to hide this bar again, and I'm going to create a new file, and I'm going to call it maybe test.yaml, and it could be YAML or it could be YML. Alright. So similar to JSON, YAML is just key value pairs. YAML is just a bit more readable. So I can have a key here and a value, and it could be a string, and it doesn't have to have quotations around it. It could just be a string, and it could be a number, and in some cases you must have quotations around your strings. So let's say you have some string that has a colon in it. This is not allowed. You have to have quotations, and we can also have a boolean true false. So let's convert this to JSON now, just to see what it would look like in JSON. So I'm going to hit Command Shift P and search for YAML, and we have the YAML to JSON extension installed, so I can click on that and this will convert it to JSON. And as you can see, as expected, it's just a very simple JSON object. So let's undo that, and what if we have a key that has an object as a value, right? So in JSON we can have another key, and this can have another object with other keys and values, right? So in YAML we can do that. So let's say we have a key, and inside this key we have an object with other keys. So what we can do is we can just hit enter and do an indentation with either 2 or 4 spaces. I'm going to do it with 4 spaces. I think it's more clear this way, but you can do it with 2 spaces. So inside this key we can have other key value pairs, right? So let's try and convert this to JSON, and as you can see we have a key and an object with key value pairs inside this key, right? Also make sure that you are indenting using spaces and not tabs. Tabs are not allowed in YAML. And using the extension that we installed, the YAML one, if we have some error like that, it should inform us that this is not a valid YAML file, right? And we can also have an object inside this object. So let's say we have another key, and this key can also be an object. So 4 spaces and another key and another key. And if we take a look at the JSON representation, and as you can see we have an object, inside it some keys, and one of the keys is also an object. right? We also can write our objects in a JSON style format. So let's have a key and call it JSON object. And let's write this object again, but now using the JSON style format. So we can just have an object using curly brackets like JSON, and then we can just have keys. So key value, and key 2, can copy it from here, and key 3, which can be another object, just like JSON, but we don't need to have double quotes around keys. So key value and key 2 value. And if we turn this into JSON, they should be exactly the same. This, however, is not very readable, so usually we will use this format, right? We can also have arrays. So let's say you have a key, which should be an array. What we can do is hit enter and 4 spaces, and each item in the array should start with a dash. So item 1 and item 2, and the item can also be another object, right? So key value, and if we take a look at the JSON representation, it should be an array with our items, right? And similarly, we can also write arrays in JSON format. So we can just have square brackets and item 1, item 2, etc. Let's do this again, and we have an array. We can also have an array of objects, objects array, and 4 spaces. And as we've seen here, we can have it like that. But as we discussed, this is not very readable, especially for long objects. So the other way to do it is to just have key value pairs inside the array items. So let's take a look at this in JSON. And we have an array of objects. Each object in the array will have the key and the value. So what if we want to have some other keys and values in each object? We can just hit enter and then 2 spaces to align the other key with this key, and then add our other keys. And same way here. And let's take a look at the JSON, and we have an array of objects where each object has 2 keys, right? So indentation here is important. These 2 keys that belongs to this array item should be aligned in the same line, right? One final thing that we should know about YAML. Let's say we have some long text here. So let's say we have a long paragraph, and let's say because the text is too long, we need to divide it into new lines, like so. But just for presentation, in reality it shouldn't have any new lines. It should be just a long text, right? So let's undo that, and what we can do is we can add the greater than character, and then enter, and then indent with 4 spaces. And now we can add new lines, like so. So this looks much better in the YAML file, but in reality it shouldn't have any actual new lines. So if we take a look at the JSON, we will have just the long text paragraph. We don't have any new lines here, right? So what if we want to preserve the new lines? We can, instead of this, we can add the pipe character, and let's save and see the JSON. And now we should have new lines. Alright, so I guess that's all what we need to know about YAML in order to write GitHub workflows. So let's in the next lecture get started and write our first workflow. So now that we know about the YAML format, let's now create our first GitHub workflow. So in my GitHub account, I'm going to create a new repository, and you can call it whatever you like. I'm going to call it GitHub Actions Test. And I'm going to keep it as public. If you choose private, you might have to pay to use GitHub Actions. For private repositories, GitHub Actions is not free. You have a certain limit and then you have to pay. So in order to try as much as we want, I'm going to keep it as public. And I'm going to copy this SSH link. And if you use HTTPS, you can copy the HTTPS link. And then in our folder, I'm going to initialize a repository, so git init. And then I'm going to link this folder to our repository that we just created on GitHub. So git remote add origin, and then paste the URL. Great, so now if you type git remote -v, I typed remove. So git remote -v, you should see the URLs for your repository, and now we can push from this folder to our repository on GitHub. Alright, so in order to write a workflow, we have to create our YAML file inside a folder called workflows, inside another folder called .github. So I'm going to create a new file, and this file will be inside .github, and make sure you don't have any typos here. This is important. And workflows. And the file name could be anything. So I'm going to call it simple.yml. Great, so now we have our .github, workflows, and simple.yml. And we can start writing our workflow. Great, so the first key that our workflow can have is a name. So this is the name of our entire workflow. So in this first workflow that we will create, we will just use shell commands in our steps. So I'm going to call this shell commands. And then we can define the events that will trigger this workflow. So remember this diagram. We mentioned that workflows can run whenever any of these, or not just these are just some examples, but they can happen when a push, a pull request is opened, issue, and so on. So we can define these here using the key on. So on, and then it can be just one event, so push, for example, or it could be an array of events. For now, we will just use on push, but you can also have here pull request and so on, right? And as you noticed, the YAML extension that I have on VS Code actually auto completes this stuff for you. So that's great. Great, so what else should we have in our workflow? Let's go back here. And as we mentioned in this lecture, for each workflow, we can have one or more jobs, right? So let's define our jobs. And this is, of course, using the jobs key. And this will be an object. And the key for each object will be the name of the job. So I'm going to indent with 2 spaces this time. And let's call this job run shell command. You can only have spaces, dashes or underscores. You cannot have spaces in the name. And this key will also have a value, and the value will be an object. And in this object, we can have a bunch of options for our job, right? So the first one is runs on. So as we mentioned here, each job will run on a virtual machine, and this virtual machine can be Linux, Windows, Mac OS, and so on. So here we can define our operating system. So for this one, let's use Ubuntu. And as you can see, we can specify a specific version that GitHub offers, or we can just use the latest version. So I'm going to use latest. And what else do we have in our job? We have our steps, right? So steps, and this would be an array of objects, and each object represents a step. So how do we make an array in YAML? We use dash, and each object in this array should have a name or can have a name. It's not required, but let's have a name for our steps, and let's call this maybe echo a string. And what we will do for this job, we will just echo a string using a shell command. So remember, we mentioned that a step can perform an action, and we'll talk about this later, or it can just run some shell command. And to run some shell command, we use run, and we can write any bash command. By default, Ubuntu will have a bash shell, and also Mac OS, and Windows will have a PowerShell shell, and we'll talk more about that later. But just make sure when using Ubuntu, you are writing a bash command here. So I'm going to echo some string. And let's add one more step. And this step, we will do something very similar. Let's call it multi-line script. And this time we won't only run just one command. We want to run multiple commands. So how can we do that? In the previous lecture, we learned about this pipe thing. So this can be used with GitHub Actions to run multiple commands. So I'm doing my 2 spaces indentation here, and I'm going to run, let's for example check our node version and our npm version. So now we are running 2 commands here and not just one, and that is by using this pipe thing in YAML. Great. So I think that's enough for now. Let's now try to push this file to our repository and see what will happen. So I'm going to open my console here, my terminal, and I'm going to git add all, git commit, and type some commit message. So maybe first workflow, and git push. And since this is our first push, we need to set upstream. So I'm going to copy this and this clear so that you can see, and paste. So git push and dash dash set dash upstream origin master. And let's go back to our repository. And now if we go into this actions tab, we should see our action running, our workflow running, sorry. So I clicked on all workflows, and then this is the one that is currently running. And here we have our output. So on the side here we have our workflow, which we called shell commands, and that is here. And then below this workflow, we will have all of our jobs. So only have one job, which is run shell command, and this is the output of its steps. So the first and the last steps are created by GitHub, so you don't have to worry about these. This is just setting up the environment and stuff like that. And then we have our first step, echo string. And here is our string and our multi-line script. And here is our node version and our npm version. Very good. So when a job is done, you can choose to get a notification when the job is successful, or if the job has failed. And this is in your settings, in your GitHub account settings here, and in the notifications tab, and in GitHub Actions. You can choose what kind of notifications, email or web, and you can also choose whether to send the notifications only on failure or also on success. So for me, I have it set for also successful workflows. So I just got an email that my workflow was successful. Let's finally talk more about this interface. As we mentioned, we have our workflow, our jobs, and our steps here. And while the job is running, you can actually cancel it. So this job is done, so we don't have it, but if it was still running, and you might have noticed this, you will have a button here, cancel job. And you can also retry it if it fails. So let's actually make this job fail deliberately by maybe let's add a non-existing command here. So I'm going to add a SE to the echo. And I'm going to git add all and git commit and git push. So just some random commit message and git push. And let's go back here and let's go to the actions tab again. And we should see our new job here. As you can see, it's still running, so we can cancel it. And now it started and it should fail, as you can see. And when a job fails, of course, you'll get an email or a notification if you have your notifications settings set correctly. And you can also rerun your job when it fails. All right. Another great feature here is that you can, of course, view the output of your commands. And not only that, you can also search the logs here. So if you search for 127, we will find that we have one hit here and so on. And this can be very useful, especially if you have a large job with a long output here. Also, we can click on here, and for each job we have something called artifacts. We will talk about artifacts in more detail later, but briefly, an artifact is a file generated by your job. So for example, if you're running some tests, and maybe these tests produce some test results or coverage or stuff like that, you can actually make these test results downloadable here. And we'll see how to do that later. But by default, we have an artifact, which is the log archive. So let's download the log archive. And let's open it. And I'm going to drag it here. And this will be just some information about your workflow and your steps and so on. And this can be helpful if you have some error and you want to do some more debugging. One final thing I would like to mention before ending this lecture. As we saw here, we have a lot of information about our steps in the logs here, but sometimes maybe we'd like to have more information. And in GitHub Actions, we can enable something that will allow us to see more information here. And this is by going to Settings and Secrets. And we will add some new secrets here. And we'll talk about secrets later in more detail. But for now, let's just see how to enable the debugging secrets. And these are called, I'm going to copy it from here, and I'm going to put you a link to this article here. So the first one is called Actions Runner Debug, and we have to set it to true. And add. And the second one is Actions Step Debug. And also true. And let's go to our actions. And let's actually do a rerun using this button here. And as you can see, you have a lot more information here, which is prefixed with debug. And this might be too much, as you can see. So I would recommend that you only enable this debugging thing only if you have a problem and you try to debug it. But otherwise it's actually too much and very noisy. And also you will have some extra information in your artifact as well. So let's download this. And let's open it. And here, so here I have our old folder and the new folder. And as you can see, we have an extra folder here called runner diagnostic logs, and it will contain some more information that can help you debug. Alright, so don't worry about these right now. Hopefully you won't need to use these debugging files, but I just wanted to let you know that you can enable these debugging features. Great, so this was a long lecture, but we have learned a lot about this whole process. So hopefully things are more clear now. Let's in the next lecture see how can we use another shell here instead of bash. So as we mentioned, in Ubuntu by default it's a bash shell, and on Windows it's different. So let's see more about that in the next lecture. In the last lecture we created our first workflow, and we created one job, and this job had a couple of steps. And in these steps we just ran a shell command here, right? And we also mentioned that you can change what shell are you using as well. So here I have a table for all the supported shells in GitHub Actions, and also which platforms they support. So we have bash, which is the default in Linux and Mac OS virtual machines, and it supports all platforms, so it can also be used in Windows. However, in Windows, the default is the PowerShell, and it only works on Windows, so we cannot use it on a Mac or a Linux virtual machine. However, we can use bash on a Windows virtual machine. In addition to that, we also have some other shells, like PW shell and Python. And you can take a look at this table. I will put you a link to this page. But let's now try to use another shell in our Ubuntu job here. So I'm going to use the Python, and I'm going to add another step in our job. And let's call this one Python command. And run. And let's also do a multiple line script, and we will write some Python here. So let's do something very simple here. Import platform, and let's print platform.processor, which will just print the processor of the machine that this workflow will run on, right? Let's also close this for now. Great, so we've written some Python, but we need to inform GitHub Actions that this should run on a Python shell and not bash. So using the shell option, we can choose here Python. Alright, so let's now push our changes and see the output of our workflow. So I'm going to add and commit and push. And let's go back to our Actions tab, and we should have a new action here, a new workflow. And it might take a little while, and after it finishes, we should now see our Python command. And I'm sorry, we still have the error that we created here, so that prevents the rest of the steps from running. So I'm just gonna remove this and do the same steps again, and I will probably skip this in the video and go back to the action tabs. Alright, so I fixed the error and I'm back here, and let's open the latest workflow. It took a little while and now it's finished. So let's take a look at our new step here, which is the Python command. I think we need to turn off this debugging thing. But anyways, here we have our processor, and we successfully wrote some Python using the Python shell here. Right, so let's take a look at one final example, which is using bash on a Windows machine. So I'm going to create this in a new job, just because we need to use a different operating system, which is Windows. So we have to create a new job. And as we learned, each job will run in parallel on its own virtual machine. So here I have my first job. So if I need to add another job, it should have the same indentation as this one, right? So let's call this run Windows commands. And this one will runs on Windows latest. And we can have some steps. And so first let's use, so as I mentioned, the default shell in Windows is PowerShell. So let's say we want to output the current directory, and we need to do it in PowerShell and then in bash. So let's first do it in PowerShell, which is the default. So let's call this step directory PowerShell, and we'll have to run get location. Alright, in bash, however, we run pwd. So what if we are used to bash and we need to use bash on a Windows virtual machine? We can absolutely do that the same way we used Python here. So let's add another job or another step, sorry, and let's call it directory bash, and let's run pwd. But now, of course, if we don't specify a shell, this will throw an error. But now if we specify bash, it should work. Right, so I'm gonna add all files and push, and let's see the output of our workflow. So I'm going to go back here and go to actions and the latest workflow. And as you can see, we now have two jobs and they are both running in parallel. So the first one finished first, and we've seen this before. And our second job will run the PowerShell get location, and here is our path, and then it will run it again using a bash shell. So pwd, and here is the output of pwd. Alright, so that was just a quick lecture on how to use a different shell, just in case you ever needed to do that. Let's do one final thing. This is not related to shells, but since we created another job, and as we saw they both run in parallel, let's quickly take a look on how to run these jobs in series, or one after another. So let's say this run Windows commands job depends on run shell command job. So it needs this job to finish first before running, and not run in parallel. So what we can do is, in this job here, we have a needs key, and needs can be an array of jobs that this job depends on. So it will only run when the jobs in this array finishes successfully. And this will be the ID of the job, or the name, which is the key here. So let's copy this and let's put it here. And let's push one final time and take a look at our output. So let's go back here and go to our final, our latest workflow. And as you can see, this one finished first, and then this one started. Great, so I think we now have a good idea on how to run commands and how to change the shell and all of that stuff. Let's now take a look at the other thing that we can do in our steps. So here we mentioned that a step can perform an action, or it can run a command. We took a look at running a command. Let's now learn more about actions and what they can do for us in the next lecture. In the last couple of lectures, we've seen how to create a workflow and some jobs inside of this workflow, and also we've seen how to create steps inside of each job, right? But we've only seen how to run some shell command in a step, which could be very useful. However, using actions, which is another thing we can do in our step, can do a lot more stuff. So let's go back here, and I'm going to close these files, and I'm going to create a new workflow, just to show you that we can have more than one workflow in our repository. So I'm going to call this actions.yml, and let's give it a name, actions workflow, and let's also trigger this workflow on push, and let's create a job, and let's call this one run GitHub actions. Right, so let's say we are going to use Ubuntu, latest version, and we're going to have some steps. So here I have a very simple GitHub action, which lives in this repository. I'll put you a link to it, and it's called Hello World JavaScript action. So it's a JavaScript action, and we will learn more about JavaScript actions later. But just for now, keep in mind that actions are written in JavaScript. There is also another way to write actions, which we will learn about later. But JavaScript is one of them, and this is a JavaScript action. And what it does, it just echoes some string, just like we did in the shell command. However, this action can take some inputs, so it can log hello, and then a variable name which will be controlled by us. So this also doesn't do a lot, but it will just give you a good idea on what actions are. So how do we use this action in our step? Let's give our first step a name. Let's call it simple JavaScript action. And instead of run that we used in the last lecture, we can use uses, and uses will take a reference to an action. So when we learn how to write actions later in the course, we will know that we can write actions in the same repository somewhere here in a subfolder or something. And then we can reference this action by typing the path to our file, action file. Or we can use an action that is published on a public GitHub repository. And that's what we will do now. So here's our action. And in order to reference it here, we will have to type the username, which is actions in this case, and the repository name, and then a reference to a branch or a version. So I'm going to copy the username and the repository name from here and paste it. And then we type @ and then we can either reference a branch, so maybe master, or we can reference a version. So here in our releases, we have only v1, so we can type v1. If we have other versions, we can reference 1.2 or 2 and so on. Also, we can reference a specific commit. So if you go back here and open our commits, and we can choose any commit and copy its ID using this button and put it here. And this will use this action at this specific commit, right? So what should we use? What are the differences between these methods? Using master or any branch is not really preferred, because when you depend on a branch, some breaking changes might occur on master, and then this might make your workflow fail. So let's say this action decided to update their action from version 1 to version 2, and you are referencing master here. Then you were using version 1 and now you're using version 2 because you are referencing the latest code on master. And if version 2 introduced some breaking changes, then your workflow might fail. So referencing a version might help, or actually it will help mitigate this problem because you're always referencing the same version. You can also reference a minor version or a patch version if you want to be more specific. But referencing version 1 here will pull the latest version of the major version 1. So if it's 1.3, it will pull 1.3. If it's 1.1, it will pull 1.1 and so on. And using the commit ID here, this is the safest way because this will never change and it will never break your code. So of course I'm assuming this is a commit ID. So let's use version 1 here. And as I mentioned, what this action will do, it will log hello and then something that we provide, an input that we provide. So how do we provide an input to an action? It's using the with key here. And by going to the documentation for this action, we can get the inputs that it receives. And in this case, it's who to greet. So we can add who to greet here and then type your name or something. And this will be it. But before we push this and see our output, let's also mention that actions can also produce an output, not only receive an input, but also produce an output. So this action, for example, produces an output, which is the time when this string was logged. So how do we access this output? Let's create another step here. And let's call it log greeting time. And we'll just use run here, not uses. And we will echo, and we need to echo the output of this action. So in order to do that, we need to reference this step, right? And how can we do that? We can use double quotes here and $sign and 2 curly brackets. And inside of here, we can use a variable which GitHub makes available to us, which is called steps. And this will be an object that contains all of our steps. And we will talk more about these variables, which we can use in our workflows later. But for now, let's use steps. And in order to reference a certain step, we have to give it an ID. So let's give an ID here, and let's call it greet. And now we can call steps.greet.outputs. And the output for this action is called time. So usually you will find these names of the outputs in the documentation for the action you are using. Great, so now let's push our code, and I'm going to clear my console and just add all and push, right? Let's go back now to our repository and our actions tab. And now we have 2 workflows running. The first one which we created earlier and our actions workflow. So let's open this one up. And let's open our simple JavaScript action. And the output here is hello John. I think I'm going to disable this debugging thing just to make it more clear. But anyways, we have hello John here. And as you can see here, we have something called set output and then time and then some time here, right? So here when we referenced an output in the outputs, it was called time, which is this one. And it was set by this action to this time here. So if you close this and go to our next step, we should have our time, which was set by the previous action. Right, here it is. Great, so this was a very simple action, but I think it gave you a good idea on what actions are and what they can do. So just to summarize, actions are some code that you written or maybe somebody else written that does some task, some specific task, and that you can use in your steps in your GitHub workflow. This task can be as simple as logging something as we did here, but as we will see in the future, this can also be some complicated task, like maybe deploying a website or something. So by having actions, we can write less code in our workflows, and also we can use code that somebody else shared that does some common task, or we can actually create our own actions and share it with people so that they can use it in their workflows. And of course, we will learn how to do this in a later section. So let's in the next lecture take a look at a more useful action than this simple one that we used here. Alright, so see you in the next lecture. Have you ever wondered, when we run a command like this, where does it run? Like in which directory in the virtual machine that is running on? So when we, for example, type some command locally here in our terminal, we know that we are running this inside of the GitHub Actions folder, right? And we can view the full path by typing pwd. So here it is. And we can also list all of our files in this folder using ls. And you can view also hidden files and folders using ls-a. So here is our files. So when we are running these commands on our virtual machine, where does it run? Let's figure this out by trying to run pwd and ls on our virtual machine. So I'm going to create another step, and let's put it at the very top. And I'm going to call it list files. And we're going to run, and let's do a multi-line script, and let's run pwd and ls, right? And I'm going to push and commit and push. I think I'm going to skip this in the video because we'll do it a lot, but I'm going to do it and get back to you. So I'm done pushing. So I'm going to go back here and view our latest workflow run. So looks like I went into the wrong workflow. This is the one that we would like to see, run GitHub Actions. And let's open up the list files step. And here we have our directory, which is something, and then GitHub Actions test, which is the name of our repository, and then the name of our repository again. So this is a folder that is set up on your virtual machine when you run a workflow. And this is where you can work with your files. But notice when we ran ls here, we don't have any files. So by default, GitHub will not clone your repository into your working directory here. And this is because not all workflows will have to use the files in the repository. So it may be unnecessary to clone it and then not use any of the files. So in order to clone your repository into your virtual machine in this directory, we can use an action to do that. So this is an official action, which means it was created by GitHub. So I'm going to search for actions checkout, and let's see how to use it. So here it is. So the username is actions and the repository name is checkout. So I'm going to copy it and use it the same way we did in the last lecture. So in another step, we will use this action. So let's call it checkout. And this time it will not run, it will use an action. And the action is in actions, username, GitHub username, and the repository name, which is checkout. And I'm going to use version 1. And what this will do, it will just authenticate with your repository and then fetch the code and check out into the commit that triggered this workflow to run. So when we push something into our repository, which is this one, the commit that we will push will trigger the workflow to run. And this commit will have a certain ID. And we need to check out into this specific commit that triggered the workflow and pull our code from there, right? And this is exactly what checkout will do. And we could have done this ourselves. We could have ran git clone or git fetch or so, since we already have git installed on our virtual machine. But this action makes it easier for us. We just have to type one line. And let's also copy this step, and let's list the files again, but this time after checkout, and see what we will have. Let's also do the -a flag to see also hidden files. And I'm going to push this and get back to you. So I'm done pushing, and I'm going to go back to our actions tab and our actions workflow. And let's wait and see what will happen. So we have checkout here, and if we dig into this checkout step, we can see that this action will run, let's see here, it will run git fetch here, as you can see, and it will do some authorization in order to clone our repository. It will also run git config to set some configuration, and it will also check out into the commit that triggered the workflow. So take a look at this ID. It starts with 8A7, and let's take a look at our latest commit ID. So commits, and as you can see, it's 8A7. So we are checking out into the code in this commit, right? Great, so this will clone our repository into our working directory. So if we list our files again after checkout, we will find our files in our repository. And now we can work with them. We can maybe run some tests, build something, do some compilation and stuff like that. And this is probably what you will do when using GitHub Actions. You are probably going to use the files on your repository. So this checkout action is one of the most common actions that you will use in your workflows. I finally want to show you something that we will talk about later in more detail, but let's just take a quick look on some environment variables that are set automatically when you run your workflow. So we mentioned that checkout will run git fetch and git checkout to your latest commit, or the commit that triggered the workflow to run. But what if we wanted to do this ourselves? What if we wanted to run git fetch and run git checkout and then our commit? How do we get the commit ID that triggered the workflow? And how do we also get a token that we can use to authenticate with GitHub in order to fetch or maybe push something to our repository? So I'm going to remove this, and I'm going to echo some environment variables that you can use in your workflows. And these are set automatically, you don't have to do anything. So we have GitHub SHA, and this is the commit ID of the specific commit that triggered this workflow to run. We also have GitHub repository, and this is the username and the repository name. And we also have GitHub workspace, and this is the workspace directory, which we actually have seen using pwd. We have other things that are not environment variables, but that you can access using the same way we did when we needed to reference a step, right? So we have the steps object here that we can use. We also have an object called GitHub that we can use, and it contains a lot of information. So let's take a look at one of them. So GitHub.token, and this is a token that you can use to authenticate with your GitHub repository. So what we could have done is we could have called git maybe clone, and then our URL, which will be git at GitHub, and then this should be our GitHub username, and then our GitHub repository name, which can be found actually in this environment variable. So we don't have to hardcode anything, we can just use these environment variables. And then we can just, after cloning, we can check out into our commit that triggered the workflow, which lives in this environment variable. So something like that. This is not accurate, and also the token can be put somewhere here in the URL. I just don't remember exactly, in order to authenticate while cloning your repository. So this is just an idea of how we could have done things, but it's not very accurate. Let's just push one final time in order to see these environment variables. And let's go back to our Actions tab and open our Actions workflow. And in our list files, we have our commit ID, which we are echoing here. We have our repository name and username. We also have our workspace, and we also have our token, which is hidden here in the logs for security reasons. And these are the stuff that we are echoing here, right? So we talk a lot more about environment variables and things that we can use, like the GitHub object here. But I think now we have a good idea about workflows and jobs and steps and actions and so on, and we can dig a little more deeper in the next sections. One final thing I would like to mention is the Actions marketplace. And this is an official marketplace for GitHub Actions, where you can find actions that other people created, and not only just normal people. You'll find actions created by organizations here, and that you can use in your workflows. So you can take a look at this marketplace and see what kind of stuff actions can do, which is a lot actually. Let's move on now into the next section. In order to trigger workflows on a certain schedule, we can use a cron schedule expression. If you are familiar with cron jobs, you might be familiar with this, but it's actually very simple, so let's take a look. First of all, I'm going to remove the push in both of our workflows in order not to run these workflows every time you push. So I'm going to change this one into a pull request, and I'm going to comment out the push here, right? So for a schedule, we can have another key here, which is called schedule, and this will be an array, and each array should have an object with a key of cron, and then in quotations, a cron schedule expression. So what's a cron schedule expression? It consists of 5 things: minutes and hours and day of a month, and day of the week. All right. And each one of these can be a certain number or a certain symbol. And we'll take a look at different numbers and symbols that we can use. But first of all, an asterisk means any value. So what this means, it means any day of the week, any month, any year, any hour, any minute. So by having this expression, our workflow will run every minute of every hour, of every day, of every month, and so on, which is basically every minute, right? So what if we added a number in the minute field here, like 1? This means our workflow will run at minute 1 of every hour. So it will run, for example, at 12:01, 13:01, 14:01, and so on. Every hour it will run at the minute number 1 of this hour, right? And in order to have a better idea of what this expression means, we have a tool that is called crontab guru. I will put you a link. And using this tool, we can put our expression here, and we will get what it actually means in simple English words, right? So we have our 4 asterisks here, and this means at every minute, as we mentioned. And here we can have an example of the next time in the schedule, right? So my time now is 12:23, so the next run will be 12:24, 12:25, 12:26, and so on. Great, so let's try to put 1 here, as I mentioned. And this will mean at minute 1. So what this means, my time now is 12 and something, so the next run will be 13 at minute 1, 13:01, 14:01, 15:01, and so on. This can also not only be a number, it can be multiple numbers. So what if we want to run at minute 1 and minute 2, for example? We can use comma and have 1, 2. And this will mean at minute 1 and minute 2. So 13:01 and 13:02, 14:01, 14:02, and so on. It can also be a range. So let's say we need to have here 1 and 2 and 3. Instead of writing it like that, we can use a range. So from 1 to 3. So this will run at 13:01, 13:02, 13:03, 14:01, 14:02, and so on. We can also have a step, and this means, let's say we need to run our workflow every 15 minutes, starting from minute 0. So what we can do is we can add 0 and then //15, and this will run starting from minute 0 every 15 minutes. So this means at minute 0 and at minute 15 and 30, 45, and 0 again, and so on. So since my time now is 12:25, my actual time, the next run will be 12:30, and then 12:45, and then 13, 15, and so on. You can of course start from minute 20, for example. So this will run at minute 20 and minute 35, and then 50, and then 20 again, 35, 50, and so on. Right, I hope this is clear. Let's say we need to run this at minute 0, so every hour at minute 0. But now let's say we don't actually need it to run every hour, we need it to run at a certain hour every day. Then we can use the second field here, and we can say we need to run this at 12 every day. So at 20 December, 21st, 22nd, at 12 every day. And these are, by the way, our UTC times, right? So when this runs, it will run at 12 UTC. Also here we can have the same things we had here, the range and the commas and so on. So let's say we need to run it at 12 and maybe at 2. So every day it will run twice now, right? At 2 and 12, 2 and 12, and so on. Could also be a range, so every day 3 times, at 1, 2, 3, 1, 2, 3, and so on. And it could also be a step as well, right? So let's say we have it here at 12. So now it's running at 12 every day, but let's say we need to run it only once a month. So here in this field, we can specify a certain day in the month. So let's say every month at day 1, we need to run this at 12 and minute 0. So this will run next month, which is January for me, and then February, and so on, at day 1 of each month and at time 12. Also steps and ranges and so on applies here, right? Now let's say we need to run this only once a year. We can specify here a certain month to run our workflow just in this month every year. So let's say January, then we have to type 1. So at 12 on day of month 1 in January, right? So every January from each year at day 1, we will run this at 12 and minute 0. What if we, for example, need this to run in January, as we are doing now, but not just one day in January, every day in January? So in the day field here, we can remove 1 and add our asterisk. And this will run in every January from each year, and it will run at 12 every day, because we have asterisks here in the day field, right? Also here we can, instead of numbers, we can have the 3-letter abbreviations for each month. So Jan and Feb and so on. And finally here we can also specify a certain day in the week. So from 0 to 6, where 0 is Sunday and 6 is Saturday. So 0 here means at 12 on Sundays in February. So it will run at 12 on Sunday in February every year. So all Sundays that happen in February or at 12, our workflow will run. And you can see the example here. In 2020, these will be the Sundays at month 2, and then at 2021, and so on. And similarly, you can use here sun and mon and so on. Right, so I hope this is clear. You can play around with this tool to get a better understanding of how it works. And here we also have some examples that might be commonly used. So let's say once a week, click on it and you will get your expression, and you can just copy it into your workflow file. Great, so let's try one of these. So let's say we need to run it, to run our workflow every 5 minutes. So let's put all every minute for now. But now we need to run it every 5 minutes, starting from minute 0, let's say. So this will be 0, and then with a step of 5. And let's copy this and put it in our workflow file. And we can actually have many of these. So let's say we need to run it every 5 minutes and also every 6 minutes. This of course doesn't make sense for now, but we just need to test it. So what this means is it should run twice every, I think, 10 to 12 minutes, right? So let's push and see what will happen. So I'm going to add all and push. And then after pushing, I'm going to go back to our actions tab. And I'm going to wait for 10 to 12 minutes and then get back to you to see what will happen in our workflows. My time now is 12:38, and since it should run every 5 minutes, so it should run at 40 and 45, and for every 6 minutes it should run at 12:42 and 12:48, right? So I'll get back to you in about 12 minutes or so, and we should have 4 runs here, right? I'm back, and as you can see, our actions workflow ran 4 times on schedule here, as you can see. And what I noticed is that it's not always very accurate. Sometimes it runs a bit late, but I think it's not that big of a deal. In real time, you will not have to run it every 5 minutes. And by the way, I forgot to mention, the minimum amount that you can put here is every 5 minutes. You cannot run a workflow every minute or 2 minutes or 4 minutes and so on. Alright, so that was it for schedule. Let's see the final thing that can trigger a workflow, which is an external event. So see you in the next lecture. Let's now take a look at the final way that we can trigger a workflow with. And by the way, don't forget to remove this schedule and push. This will run twice every 5 minutes, as we know. So we don't need to abuse the GitHub servers, right? So as we've seen, we have events like push and pull request and so on. We also have an event called repository dispatch. And this event is not something that happens on GitHub, like push and pull requests and so on, it is something that can be triggered manually. And in order to trigger it, we have to send a post request to some URL, right? So here I have a documentation on how to send this post request to trigger a repository dispatch event. And I also have Postman opened. If you don't know what Postman is, it's just an application that you can use in order to send requests, but using some user interface. You can do exactly the same with a command line tool like curl or something. However, this makes it a lot easier, right? So we are going to send a post request, and I'm going to paste the URL. It's https and api.github.com/repos/your GitHub username/your GitHub repository. I think I have this wrong. Our repository is called GitHub Actions Test. So I'm going to copy it from here. And then /dispatches, all right? And in the headers of this request, we will have to add accept. And this will have to be some value that GitHub provides in this documentation, which is this string here. And also our content type will be application JSON, right? And then in our body, we can send some JSON. So I'm going to choose row here, and here choose JSON, and add some JSON object. And we have to send an event type. So event type, and you can call this whatever you like. So let's say we have an event type called build or something, right? So what this means, this is like equivalent to opened and closed and so on in the pull request event, right? So when we had a pull request event, it had some types which can be closed, assigned, opened, and so on. In a repository dispatch event, we also have to have an event type, which we can specify here when sending this request. So when we send this request, it will trigger this event. So right now, since we don't specify any types, this workflow will run no matter what we send here, right? Because we don't specify any types. But if we specified some types, so let's say build, it will only run if we send build here, right? And as I mentioned, this can be anything. Great. So, and by the way, this error, it's not actually an error. I think this is just a bug within the VS Code's YAML plugin that we're using. But this is valid, right? All right, so let's now try to send this request. And we will get a 404 not found here. And the reason is, of course, if you would like to perform a request like that, you have to have some sort of authorization, right? And in order to do that, you have to generate some GitHub token that can be sent in this request in order to authorize. So in your GitHub settings, so here, settings, I'm going to open it in a new tab. And then in developer settings and personal access tokens, generate new token. And you will have to type your password. And here you can generate a token. So you can write a note just to remind you what this token was made for. So in our case, let's say repo dispatch. And you have to select this repo scope, all right? And then generate, and let's copy it, right? This is a secret, of course. You have to keep it as a secret. I will delete it, of course, after recording this course. But anyways, let's now in Postman go to authorization and then basic, and we can just put our token here in the password. And now let's send. And we get a 204 no content, and that means it was successful. Right, so why don't we now try to push this? We haven't pushed it yet. So I'm going to push. And now I'm done pushing. So what should happen now is we have this file in our workflow. So what should happen is whenever we send this request with build as an event type, this workflow should run, because here we are triggering the workflow to run on repository dispatch when the type is build. Right, so let's go back here in our action tab, and let's send this request. And let's refresh here. And as you can see, the workflow was triggered. Great. So this actually can be very useful if you would like to, for instance, trigger a workflow on one repository, maybe from another workflow in another repository, or maybe trigger a workflow from somewhere else, maybe an application that you made or something like that. And all you have to do is just send a post request. And of course you can have your own event types, and you can trigger your workflow differently based on the type that was sent in this request, right? Let's just make sure by typing any other thing here and sending. And now in our actions, nothing should be triggered, right? Great, so one final thing I would like to mention about repository dispatch is that you can also send some payload. So if you go back here in this page that I will put you a link to, you can send some client payload. And what this means is just extra information that you might need when you run your workflow. Right, so I'm going to copy this client payload just to avoid any typos. And here I'm going to, let's get this back to build and add our client payload. And this can be a JSON object, and it can be anything you like. So maybe environment production. So let's say, for instance, we need to trigger our workflow, and this workflow will build our website or whatever in a production environment. So we send this post request with a type build, and we send some extra information, which is environment production, right? And the question now is, how do we retrieve the client payload in our workflow, right? And the answer is, it will be available in this GitHub object. Remember this GitHub object that we can access? So let's just to show you, I'm going to create a new step, and let's call it payload or something. And let's run echo, and we'll have an expression here, a variable. So we have to use the $ curly brackets or double curly brackets. And then inside the GitHub object, we have an object called event, which will have another object, which is the client payload. So I'm going to copy the client payload, and I'm going to access the env, and I'm going to push this, right? So I'm done pushing, so back to the actions tab, and let's trigger a repository dispatch event by sending this post request. And let's wait for this to run. And let's open it. And let's open this payload step. And here we have production, right? Great, so I think we now know everything that we should know in order to trigger a workflow to run outside of GitHub's events. And this can be very useful if you need to trigger a workflow for some reason outside the GitHub events, which are the push and pull requests and that kind of stuff. Alright, so That's not everything that we can have in this on key. We can also run a workflow for certain branches, avoid a workflow to run for some branches. We can also run a workflow only when certain files change, and a bunch of other stuff that we will see in the next lecture. Let's discuss one final thing that you need to know in order to control how and when your workflows are triggered. So we've seen all the events and schedules and things that will trigger your workflow to run. But in addition to that, we can also filter when the workflow is going to run by branches or tags, and also by paths. And this is actually very useful. You will probably use these filters in your workflow. So imagine you have an app that lives on some repository, and on this repository you have a master branch and you have a develop branch. And in your workflow you need to test and build and deploy your app when you push something to master. So if you write this workflow without any filtering, your app will get deployed even if you pushed into the develop branch. And this is of course not a desired behavior. So let's say we need to only run this workflow when we push to master. We can simply write our push event, and in the push event we can add another key which is called branches, right? And in here we can define some branches like master. We can add more also. This is an array, and by having this this workflow will only run if you push something to master, right? And same applies to pull request. We can also have these filters with the pull request event, and by having this this workflow will only run if the pull request is requesting to merge with master. All right. So let's change this back to pull or push, but just keep in mind that anything that we will do in this lecture can also work with pull request. In addition to that, branches can also be not just simple strings like master, they can also be patterns. So let's say we need to run this workflow for any branch that starts with feature / something, right? And this something is not something hard-coded, it can be anything, right? So what we can do is we can put this in quotations and add an asterisk here. And what this asterisk means, it means that this pattern will match anything that starts with, so let's say matches, anything that starts with feature and then / maybe feature A, and maybe also feature / feature B. However, it will not match feature / feat / A, for example. The asterisk does not match the / sign. It has to be one word like that, right? So let's write here doesn't match. So what if we want to include this? We can use feature, and then double asterisk. And this will match this, and also this. Alright? So asterisk matches any string except the /. Asterisk however matches any string, including /, right? And I'll put you a link to this guide here, which includes all the characters that you can use and what they mean. And then I think after this lecture I may put like a quiz, multiple choice, to test your knowledge about these patterns. Alright? Alright, so now this means that this workflow will run only on these branches and patterns, right? What if we want to run our workflow on all branches except some branches or patterns? We can have, instead of branches, we can have branches ignore, right? So this will run the workflow on all branches except these branches. We cannot, however, have branches and branches ignore at the same time. So let's try having branches ignore here, and we'll get an error, as you can see, because we cannot use them at the same time. So what we should do, we should use branches only if we need to run our workflow on certain branches, and we should use branches ignore only if we would like to run the workflow on all branches and just ignore some branches. We can, however, let's remove this for now. We can, however, in branches, we can exclude some branches. So what I mean by exclude some branches, let's say we would not like to run this workflow when somebody pushes on a branch called feature /feed C, right? So using this configuration, feature /feed C will match these patterns, and therefore this workflow will run. But we can ignore it, however, by adding here feature /feed C and then adding the exclamation mark. And this will ignore this branch even if it is matched in any of these patterns. But you have to put this after the patterns, right? In addition to branches, we also have tags, which works exactly similar to branches. So let's say we want to target the tag v1, we can add v1 here. Let's say we want to target v1 point something, we can also add patterns the same way we did with branches. And we also have pattern ignore, and we also cannot use tags. We have tags ignore, and we cannot use tags and tags ignore at the same time, right? Finally, we can also filter by certain paths. So let's say path, and let's say we would only like to run this workflow when we change maybe only JavaScript files, right? So what we can do is we can add a pattern asterisk and then .js, and this pattern will match any JavaScript file in our repository. So whenever we push a JavaScript file, this workflow will run. If we pushed anything else, this workflow will not run. Okay. We can also have path ignore, and I'm going to comment this because also we cannot use paths and path ignore at the same time. And this is also an array, and we can put here some patterns or paths that we would like to ignore. So maybe if we push anything in a folder called docs, so docs/anything, any file inside docs, we would not like to run this workflow, so we can put it in path ignore. And also similar to branches and tags, I'm going to comment this and get back paths. Let's say we would like to ignore a certain JavaScript file. We can use exclamation and then file name .js. So this workflow will run for all JavaScript files except this file name. Okay. So this was just a quick lecture on branches, tags, and paths. And we've seen some very simple pattern examples here, but actually using these patterns, you can do some very complicated stuff. So take a look at this cheat sheet here, which explains the characters that you can use in your patterns and what they do. And here we have patterns for branches and tags, and also in this table and in the next table, patterns for paths, because they can be a bit different, all right? So take a look at this. They have some really good examples, and I think I'm going to add the quiz to test your understanding of these patterns, all right? So that's it for now. See you in the next section. In the last section, we've had a general idea on workflows and actions and so on. And I think now it's time to get into more details. So up until now, we've only seen how to trigger a workflow using the push event. So let's, in this section, take a look at other ways that we can use to trigger a workflow to run. So as I mentioned before, in addition to push, here we can have any kind of event that can happen on GitHub. Like for instance, a pull request was opened, an issue was opened, and so on. So why don't we try now to add here pull request, like so. And let's push and let's see what will happen in the Actions tab on GitHub. So what we should expect is that both of these workflows will run on push. However, this one, the Actions workflow, will also run when we open a pull request. So a pull request can also be closed or maybe reopened or stuff like that. And we will see how to be more specific in a moment. But let's for now see what will happen if we just put pull request here. So I'm going to our repository in the Actions tab. And as you can see, both workflows ran just a minute ago. And now let's try to create a new pull request. So of course, first I have to create a new branch. So let's go back here and let's git checkout -b and let's create a branch called develop. And in this branch, let's just add any change here, just in order to commit it. And let's git add all and git commit and git push. And we'll have to set upstream. So I'm going to clear and so git push and dash set dash upstream origin develop, right? And now if you go back here and go to our Actions tab, we will see that both of our workflows are running as expected. But now we can create a new pull request. And let's say we need to merge develop into master, right? So let's create a pull request. And what will happen is that all your checks will run here, and you can see it here. And also the Actions workflow will run. So if we refresh this, as you can see, the Actions workflow is running, and this time it's not on push. However, it's on pull request. Great, so pull request is also one of the events that you may use frequently. So maybe when you are working on a project with some other people and somebody creates a pull request, you need to run some tests first before merging. So you can create a workflow that will run some tests, and you can actually see the results of your workflow in the actual pull request. And if a job or a workflow fails, then you will not merge this pull request, and the person responsible for creating it will just have to check the error and fix it and create a new pull request and so on. Great, so this was just an example of another event that we can use. But now let's see what will happen if we, for example, close this pull request. If we close it and then go back to our Actions tab and refresh it, as you can see, the workflow will not run. So even though we have pull request here, by default, it will not run on close. It will only run on open and reopen, and also another thing called synchronized. So how do you know what will happen if you did not specify any certain activities? You can go into this page, which I will put you a link to, and this contains all the events that can trigger a workflow to run. So it's a long article actually, and you can see all the details, but for now let's take a look into the pull request one. So let's go here. Here it is. So pull request can be, as we've seen, opened or closed, reopened, synchronized, and a lot of other things. And as you can see here in this note, by default, the activity type is opened, synchronized, or reopened. So some events have something called activity types. So unlike push, a push doesn't have any activity type. You can just push. But for example, a pull request can have many activity types, like open, closed, and so on, as we discussed. And if we did not specify any activity type, the workflow will run on open, synchronize, or reopen. So let's say we would like to be more specific and run our workflow when, for example, let's say assigned and opened and closed. So how do we do that? Instead of passing this as an array, we can also pass it as an object. So we can have push, and push doesn't have any activity types, so we won't type anything here. And we can have pull request, and here we can specify activity types using the types array, and this will be an array of activities. So closed and assigned and maybe opened. You can also add the reopened here, just to reopen the pull request that we just closed and see what will happen. So I'm going to git checkout and go back into master to push these changes. So git checkout master, and then git add all and commit and push. So I'm done pushing. Let's go back here to our repository. And of course we have our workflows that runs on push running as normal. And now let's go back here and let's reopen this pull request. And if we go back to our actions tab, we will find that our actions workflow was triggered. And that's because here we are specifying that this workflow should run when a pull request is reopened. Let's also try closed and assigned. We already did opened, so let's try closed and assigned. So I'm going to assign myself here. As you can see, I assigned myself into this pull request. And if we refresh this, we can see that our workflow is running. And finally, let's try and close it and refresh, and it's also running. All right. One final thing I would like to mention here. Let's take a look at one of the workflows that triggered on push. So let's open this one, for example. And when we use checkout, as we've seen before, we will check out into the commit that we pushed that triggered this workflow to run. And this could be on any branch because we did not specify any branch here. And we'll see how to specify branches in a later lecture. So this will basically be the commit that triggered the workflow to run on any branch. If we take a look here in the push event section, we will find that in addition to activity types in this table, which is not applicable as we mentioned in case of push, we also have a GitHub SHA environment variable, which we've seen in the last section. And we also have GitHub ref. And GitHub ref is just the branch that we are working with, and GitHub SHA is the commit ID, as we've seen before. So in case of push, the branch will be the updated ref, which means the branch that we pushed into, and the commit ID will be the commit that we pushed that triggered the workflow to run. So that makes sense in case of push. But what about pull request? So let's go back here in pull request section. And as you can see, the GitHub ref will be the pull request merge branch and the GitHub commit ID will be the last merge commit on the pull request merge branch. And that makes sense. So if we, for example, are running some tests when someone opens a pull request, we would like to run these tests when we merge the pull request with the branch that this pull request is requesting to merge into, right? So in our case, for example, we are requesting to merge a pull request into master. So we would like to run our workflow as if we merged our pull request into master, and we are running our workflow in this merged code, right? And this is exactly what is happening here. So if you go back here and take a look at a workflow that triggered on pull request, we can see that in the checkout action, we are checking out into refs remotes pull one merge, which is a merge branch, right? So these things will happen automatically. You don't have to worry about them. But I just wanted to let you know what is happening behind the scenes. And in order to be aware of what will happen on each event, you can just check this page. And all the activity types, the GitHub commit and the GitHub branch will be mentioned in these tables. Alright? So take a look at this page. I will put you a link, and maybe you can try some other events as well. If you found an event that is familiar to you, you can try to use it, maybe the issues one. So in issues, an issue can be opened, edited, deleted, and so on. Maybe you can try this one out and see if it's working as you expected. Alright, so let's move on now. I guess that's mainly what you need to know about events. However, we also mentioned that not only GitHub events that can trigger a workflow, but we can also trigger a workflow on a regular schedule or if an external event happens. So let's take a look at these other two in the next lectures. In this lecture, we will talk about environment variables in GitHub Actions. So in a previous lecture, we have already seen some of the default environment variables that we can use. But let's in this lecture take a look at more environment variables that we can use, and also take a look on how we can set our own environment variables. So in my workflows folder, I'm going to create a new workflow, and I'm going to call this file env.yml, and let's give it a name. So I'm going to call it environment variables, and let's run this on push. And let's first take a look on how to set our own environment variables. So let's say we would like to have an environment variable that will be available in all jobs in our workflow. We can simply use the env key, and this will be an object, and each key will be an environment variable name, and the value will be the value of this variable. So let's call this one workflow or wf env. And I'm going to put a value, a string, available to all jobs. So when we have this env key at the top level of our workflow file, any environment variable in this env key will be available in any job that we will create in this workflow. So let's create some jobs. I'm going to create a job that will log our environment variables. So I'm going to call it log-env. And let's run it on Ubuntu latest, and let's have some steps. So I'm going to call this step log-env variables, and what I'm going to do is just run some echo commands, right? So let's do a multi-line script here, and let's echo our environment variable. So I'm going to echo the environment variable name, which is wf-env, and its value using $, curly brackets, and wf-env, right? So since we have our environment variable here at the top level, it should work in any job, in any step. So this should log available to all jobs. And I think I have a typo here. available, right? But we can also create environment variables that can only be accessed within a specific job. So in our job, which is log_env, we can add another key, which is also env, and similarly, we can have some environment variables, but this time it will only be available to the log_env job, right? So let's call this one job env, and this will be available only to all steps in our log_env job. So here we can also echo, and I'm going to copy this name, and this will work because this environment variable is accessible within this whole job, right? We can also be even more specific and add an environment variable only for one step. So in a step we can have also the same env key, and we can have, let's call this step env, and this will be available to only this step. And let's also try to log it, right? And then to make sure that this step env will not be accessible in any other step except this first one, I'm going to create another step. Let's call it log_env2 or something. And then let's run the same command. So just need to adjust our indentation. And now in this second step, we have access to wf_env because it's here. We have access to job_env because it's available to all steps in this job. However, we don't have access to step_env. This is only available for this step. So when we run this workflow, we should get 2 values here, but we shouldn't get anything here, right? But before running this workflow, let's create another job. And in this other job, I'm going to log most of our default environment variables that are set automatically by GitHub and that we can use. So I'm going to call this job log default env, and make sure it is indented the same way as this other job, so 2 spaces here. And let's also run it on Ubuntu latest. Oh, we have a T missing here. And let's have some steps. And I'm going to copy some step instead of typing all of this. So I'm just gonna adjust the indentation, and this should be fine. Right, so what I copied is just some environment variables that are automatically available when we use GitHub Actions. So for example, home, which will be the path to the home directory on our virtual machine. Workflow, the name of our workflow, and some other stuff that we will take a look at now. But also I'm logging here workflow env and job env and step env. And we need to see if we will get any values when we log these. So what should happen is that we should only get a value for wf_env because it's available for all jobs. However, these other 2 should not have any value, right? And sorry, I just noticed I have this env.yml file in the wrong folder. It's in .github and it should be in workflows. So I'm going to move it. And I'm going to commit and push. So I'm done pushing now. So I'm going to go back to our actions tab. And now we have our workflow running. So let's first take a look at our first job, which is log_env. And what we need to check here is that in this first step, all environment variables are available. And in this second one, this will be available, this will be available. However, this will not be available, right? So let's open up this first step, and all of them are available. And here, the last one is an empty string, right? And then let's take a look at our default environment variables. So let's make sure, as we mentioned, we should only have wf-env available. The other two are not available, which is the case. And now let's take a look at these other default ones. So we have home, which is our home directory in our virtual machine. And this is created by GitHub Actions. We cannot change it, and it's home/runner. We have our GitHub workflow, which is the name of the workflow. And in this case, we called it env variables. We have GitHub action, which is a unique identifier for the current step running. So since we only have one step running in this job, it's called run. If we have other steps, this will be run 1 and run 2 and so on. We also have a boolean GitHub actions, which will always be true if you are running a GitHub workflow. This can be useful if you are running some tests in your code and you need to check if you are running these tests on CI, on GitHub Actions, or locally on your machine. You can check for this environment variable. We have GitHub actor, which is the username of the GitHub account, and GitHub repository, which is the username / the repository name. We have GitHub event name, which is the event that triggered this workflow to run. In our case, it was push. It could be pull request or repository dispatch. We also have GitHub workspace, and we've actually seen this before. And this is the path that will have your repository files if you use the checkout action. Remember the checkout action that can clone your repository into this directory. And when we run any command in our steps, it runs in this directory, right? We have also our GitHub SHA, which is the commit ID of the commit that triggered that workflow to run. We have the branch that triggered the workflow to run. In this case, we push to master, so it's master. And that's mainly it. I'm going to put you a link to this table where you have all of these environment variables and some explanation, which is basically what we did now, but you can keep that for reference. Alright, so in the next lecture, we will take a look at how to encrypt our environment variables. So let's say this environment variable is an API key or something, or a password or anything that is supposed to be secret. We shouldn't just put it here in our workflow file because anybody can see it. However, we should encrypt it somehow. So let's take a look at how to encrypt our environment variables in the next lecture. Creating encrypted environment variables in GitHub Actions is very simple. All we have to do is go to our GitHub repository and then go to settings and then secrets. And we've actually seen this page before when we wanted to enable debugging, right? We can also use this to add some encrypted secrets. So let's say, as we mentioned, we need this environment variable to be encrypted. We can create a new secret here. We can call it whatever we like. Let's call it wf-env. And let's have some value. And this can be a password, an API key, something like that. And add secret. And then in our workflow, this will be available in an object called secrets. So remember in a previous lecture, we needed to access some object which is called GitHub. And this contains some information like the token, for example. We also have other object which is called secrets. And this will have all the secrets that you created in your GitHub. So let's copy this and let's put it here. And now we have this secret environment variable that is encrypted on GitHub, and it can only be accessed and decrypted on GitHub. So nobody else can see this. We can only use it when we are running a workflow on GitHub Actions. All right. So this is very common. You will probably use this a lot. If you are using GitHub Actions to interact with some third-party API or something, you will probably need an API key, which should be a secret. So this is how it should be done, right? And by the way, at the end of this section, we will talk about the different objects that you can use, like secrets and GitHub and so on. But for the next lecture, let's take a look at a secret that is automatically available on your GitHub workflows. And this is called GitHub_token. So this is a secret that lives in the secrets object, and you can use it directly without setting anything here. And this contains a GitHub token that we can use in order to maybe use GitHub's API, or maybe push something to your repository and stuff like that. So remember when we used Postman to call the repository dispatch event, we needed to generate a token and put it in our request. So the same here, if you wanted to, inside of our workflow, for some reason wanted to call GitHub's API, we need some sort of authentication. We need a token in order to use the API and do something in our repository. So what we can do is we can generate a token the same way we did when we used the repository dispatch, and then put it here as a secret and use it. However, by default, we have this GitHub token that we can use directly, and this can also be very useful. So let's take a look in the next lecture on some stuff that we can do using this token. So see you in the next lecture. One of the common uses of the GitHub token is when you are using a GitHub action, and this GitHub action needs to do something with your repository, and therefore it needs some authentication. So for example, here in this article, which I'll put you a link to, we have an example here which uses a GitHub action called labeler. This action is used to automatically add labels to your pull requests in your repository. So in order to do something like that, this action has to have some permissions, right? And therefore, as an input to this action, we pass it the token which lives in the secrets.github token that we've seen in the last lecture, right? So this way, third-party actions can have access to your repository if these actions are meant to do something with your repository, right? Another use to the GitHub token is calling the GitHub REST API in your workflow. And here we have an example which we are actually going to copy and try in our workflow. And what it does is that it opens an issue using the GitHub API. So it uses curl, which is installed on our virtual machine, and it sends a post request to https://api.github.com/repos, and then it gets your repository username and actual repository name using github.repository, which is actually similar to the environment variable GitHub repository, which we have seen, which was your username / your repository name. So this will be exactly the same, github.repository, and then /issues, and then in the headers, it sends some authorization with a bearer token, and here we send our secrets GitHub token. So this way, this request will be authorized. And then we have some other headers, and then we have our data, which is the title of our issue and the body. The title and body also have some variables in this example. So the title has the commit ID, and the body has the workflow name and also the commit ID. So let's copy this example and try it. But before that, let's take a look. Here we have a table of the permissions that this GitHub token has. So you can take a look at this in case you would like to know what this token can do, right? So as for now, I'm going to copy this entire job. And here I'm going to undo, let's keep this as it was. And let's add our new job here. So it's called create commit, but it actually creates an issue. So let's change this to create issue. And let's push this and see what will happen. So I'm done pushing and I'm going back to our actions tab. And here we have our workflow, and let's wait for our create issue job. And it ran this curl command successfully. So we sent our post request successfully, and here we have our response. But what we need to do is we need to check our issues. And as expected, our issue was created, and we have our commit ID, and in the body we have our workflow name also, and our commit ID as a link. So great, so this can be very useful to call the GitHub API to do all sorts of stuff that you can do with it. And what we can also do with this GitHub token is that we can commit and push stuff to our repository from inside the virtual machine when we run our workflow. So let's create a very simple example in our workflow. Let's say when we run our workflow, we need to create a file that has a random number and push it to our repository. So this file will be created on our virtual machine and pushed into our repository. So we have first to fetch our repository on the virtual machine, and then let's say we need to push this to master, so we have to check out to master and create this random file and then push it. So what we're gonna do now is kind of similar to what the checkout action does. We will pull our repository in our working directory, and then we are going to check out into master. But in addition to that, we will also try to push some file, and pushing some file will need some authentication. Alright, so let's take a look on how we can do this. So first of all, I'm going to show you how to create a file that has a random number. So in a bash terminal, we can echo random, and this will generate a random number. And all we have to do now is create a file and echo this number inside of it. So I'm going to change to my desktop, and I'm going to echo random and then put the output of this in a file called random.txt. Alright, so this file is created in my desktop. You cannot see it, but I'm going to drag it here. And I'm going to open it. And as you can see, it has a random number, alright? If you run this again and reopen our file, a new number will be added to the file, alright? So every time we run this, this file will be changed, and what we need to do is commit it and then push it to our repository. But all of that will happen on our virtual machine, so we need to write this code in our workflow, right? So let's get started. So I'm going to create a new step here in the same job that we created for the API, and I'm going to call it push a random file. And then let's write some steps. Some commands. So run and then a multi-line. So first I'm going to run pwd to see where we are, and you should already know where we are. We should be in our working directory, right? And then I'm going to list ls-a to list all the files that we have in our working directory. And since we are not using the checkout action, we should not have any files here. And what we need to do now is, instead of using the checkout action, we need to do this ourselves. We need to clone our repository in this working directory. So in order to do this, it can be done in multiple ways, but I'm going to, initialize a new empty repository in our working directory using git init. And then I'm going to add a remote, and this remote will be our repository, right? So how it's normally done is that we copy our SSH or HTTPS link and then add it as a remote. This is what you would do if you are doing this locally on your machine, right? So git remote add, and then let's call it origin and add our URL. But when you are doing this on your machine, you probably have your SSH keys configured. So just by adding this URL, you will be able to push and pull into your repository. But on our virtual machine, where this workflow will run, we don't have any SSH keys configured. So when we add this remote like so and try to push or pull, we will get a permission error, right? And this is where we can use the GitHub token in order to do some authorization. And in order to do that, this URL will have to be a little bit different. It will have to have the GitHub token inside of it somehow. So let's remove this, and I'm going to show you how to write the URL if you need to authorize with your GitHub token, right? So HTTPS and then : // and then our GitHub username, which will be your username, but we can actually use environment variables to make this dynamic and not just hard-coded. So we can use, remember, the GitHub actor, which is your GitHub username. We can put it here. And then after that, a colon, and then comes your GitHub token. So $, and then double curly brackets, and then secrets.github token, right? And then then github.com, and then / your username again / your repository name, and then .git, and your username and your repository name lives in the GitHub repository environment variable, so we can use that here, and then add the .git. I hope I don't have any typos here. But anyways, when we add our remote like so, we will be authenticated and we can push and pull into our repository. Great, so what we can do next is we can set get config and -- global, and we can set our user name and email. So this can be your actual GitHub username and email if you need your user to be the one who pushed this random file, but it can also be some random email. So let's put here a bot email, since this is an automatic commit, no actual person created it. So you can just put some email, and for the username, which is user.name, I'm going to put my bot. So now we need to check out into master, right? But in order to do that, we have to fetch our branches first. So let's run git fetch, and then we can git checkout master. And since we are going to push into master, we should also set our upstream to master. So this can be done using git branch and -- set -upstream -2 equals origin master. And now we can pull our repository. We have access to do that now. So let's git pull. And when we run git pull, our working directory should be now filled with our files on our repository. So let's make sure that this is the case by running ls-a again after pulling. And now we can create our random file and commit it, right? So it was echo and random, and put it in random.txt. And since we ran this in our working directory, it will be created in our working directory. And let's also make sure by running ls-a again. So finally now we can git add all, and then git commit, and let's say random file, and we can git push. So I think this should be it. So let's try to push and see what will happen in our workflow. Alright, so I'm done pushing. Let's hope I don't have any typos in this code. So let's go back to our actions tab, and let's wait for this to run. we are interested in create issue. So push random file, it looks like it was successful. So let's take a look here. So first we ran pwd, so this is our working directory. We ran ls and we don't have any files yet. We ran git init. We initialized a new repository in our working directory. We added our remote. So here is the output of that. And then we added our config. And then we ran git fetch. And then we checked out into master. And then we set our upstream in order to push to master. And then we ran git pull. And this should have some output, which should be the files in our repository. And here we have them, right? And then we created this random file and we are checking our files again. Now it should be the same as this one, in addition to random.txt, which we have it here. Alright, so finally we committed and pushed, and this is the output of that. And if we go into our repository files, we should now find our random file, which has a random number. And if we go into our commits, we have this mybot user is the user that pushed this random file, right? So great, so we've had two very useful examples of this GitHub token. First, calling the GitHub API, and also pushing something into our repository. So you might be wondering, why would we need to push something in our workflow? For example, I once needed to, when something is pushed to master, I needed to generate a semantic version for my application automatically. And this version was saved in some file, which was package.json, if you are familiar with NPM. So I needed to generate this version and then put it in package.json, and then I needed to push the package.json file that I modified back into our repository. So that might be a useful application for pushing files into your repository. In real life though, you will probably find some action that will make this a lot easier instead of typing all of this code. However, we needed to take a look at how things can be done in a lower level. But GitHub Actions are great, of course. In a real applications, you should use GitHub Actions if you found an action that can perform what you need to do. Alright? So great, so I think that was an interesting lecture. Let's take a look at another interesting thing in the next lecture. As we saw, secrets can be very useful. However, using GitHub secrets, you have a size limit. A secret can only be 64 kilobytes. So what if we have a very large secret that we need to encrypt and decrypt in our workflow? GitHub provides another way to encrypt and decrypt secrets in your workflow. So how this works is, let's say for example, we have this file secret.json, and I'm going to open it. It's a very small file, but let's assume it's a very large file, larger than 64 kilobytes, and it contains some secret information, some API keys, stuff like that. And for some reason we need to use this file in our workflow. So now we cannot commit this file in our repository and use it, because everybody can see the files in our repository, and these keys will be exposed. We also cannot use the secrets here because, as we assumed, this will be a very large file. Another reason we might need to do this, other than size limit, is that maybe we are using some CLI in our workflow that requires some secrets to be stored in a file. So for instance, I was once automating deploying an Android application to the Play Store, and I was using some CLI that required as an argument a path to a file with some secrets that you can use to authenticate and deploy some application to Play Store. So it was something like Let's say it was called Android deploy, and then some path to a file, a JSON file that contains some secrets. So if we would like to run this on CI, on our workflow, we will have to have access to this file. So one solution is to push it to our repository, but as we mentioned, this is not safe. Your keys will be exposed in your repository. And the other option is to encrypt it and push it to your repository and then decrypt it in your workflow. So these are some uses to encrypting and decrypting files. Let's see how it's done. So first, in order to encrypt files, we need to encrypt them on our local machine, right? We have a secret file in our local machine. We don't need to push it anywhere. We just need to encrypt it on our local machine and push this encrypted version. So in order to encrypt our file, we need a tool that is called a CLI tool that is called GPG, and you can get it from here. You have here links for Windows and Mac OS and other stuff. So once you have this tool, you can run a command called GPG in your machine, and it takes some argument and it takes the path to the file that you need to encrypt. So in order to avoid any typos, I'm just gonna copy this command from the GitHub documentation here. It's a bit long, and of course I'll put you a link to this. So I'm going to paste this and just modify the file name. My file is on desktop and I'm already running this command on desktop. So the path will just be the file name, which is secret.json. And I hit enter and it asks for a passphrase. This is also should be kept as a secret. This key is what will be used to decrypt your file, right? So I'm going to make it 1, 2, 3, 4. Of course, in real life, it should be a bit more secure than that. And re-enter. And a file is now created on my desktop. I'm going to drag it here so that you can see it. And now this is the file that we need to push to our repository. This is encrypted. It is safe to push it. So I'm going to get my folder, my repository folder. I'm going to put this file here. And let's take a look at it on VS Code. It is something encrypted. Nobody can decrypt it except with our passphrase. Very good. So now we need to decrypt this file in one of our jobs, right? So let's actually create a separate job. Let's call it decrypt. And let's also run it on latest Ubuntu. And let's have some steps here. So first step is we need to clone our repository. So let's use the checkout action this time. So it's in actions and checkout. And let's use version 1. So now after this step, we have access to files in our repository, including this encrypted file that we need to decrypt here in our decrypt job. All right. So let's in the next step decrypt it. So let's say decrypt file. And now here we are going to run some command, which is also the GPG command line tool. This is already installed in a GitHub hosted virtual machine, so we can directly use it. But as you might have expected, in order to encrypt our file using this tool, we need to have access to the passphrase that we created while encrypting this file. And since this passphrase is a secret, we shouldn't just put it here in our workflow file. We should add it as a secret in our repository, right? So I'm going to call it passphrase, and the value is 1, 2, 3, 4, and add it. Right, and now in our workflow file, we can decrypt our file using this passphrase. So first, let's make it available as an environment variable for this step. So passphrase will be, inside of secrets.passphrase. Alright, so how do we decrypt using GPG? First, we can pass some arguments like quiet, and this will limit the output of this command line tool in case you don't want to have a lot of noise in your logs. We can also add batch, and this will prevent any interaction to happen by this command line tool. So for instance, when we ran GPG here, we had some interaction. We needed to enter our passphrase. We needed to enter some input. On our workflow, however, we cannot enter input, right? We cannot enter anything in this interface here. We can just see logs. So we need to prevent anything from being interactive using batch. And in case we needed to enter some input, we can assume that the answer is always yes using this yes argument. So when encrypting, GPG can ask some questions, but since we cannot answer them on our workflow, we can assume that the answer is always yes, right? And then we pass decrypt because we need to decrypt. And then we pass our passphrase. Make sure you don't have any typos. And this will be, in quotations, our passphrase environment variable that we just created, which will be the passphrase inside the secrets in our repository, right? And then finally we have our output, which will be what file do we want to decrypt, and also where do we want our decrypted files to be saved. So first is where do we want our file to be saved, our decrypted files. Let's say we will have it in our home directory. Remember the home directory that we've seen here when we were logging our environment variables. Let's say we need to put it here, and let's call this file secret.json. And this will be the decrypted file, right? The output. And the input is the file that lives in our repository, which is secret.json.gpg, right? So secret.json.gpg. And since this file is already in our working directory, where we pulled our repository, we don't need to enter any path here, because we are already running this command in our working directory. Great, so this will decrypt our file using our passphrase and put it in home secret.json. So now we would like to make sure that this worked successfully. So we can add another step. And in this step, we can just print our file contents in order to make sure it was decrypted successfully. So let's run cat. And cat is a bash command that receives a file path, and it will just output what's inside of this file. So which file do we need to output? We need to output home secret.json, which should be created by this step. Alright, of course in real life, you will never have to do something like that, because this way you are exposing your secrets which were decrypted here, and anybody that has access to your repository can see them in the logs when we run this. So this is just for us to test, but never do this in real life. So I'm going to add and commit. So I had an error here when I was pushing, because remember we created a random file and pushed it to our repository. So we need to pull this first and then push. Alright, so I'm done pushing. Let's take a look at our actions tab and our decrypt job, and let's wait for it to finish. So looks like it was successful, Let's take a look at the decrypt file script. And looks like we don't have any errors here. Let's see our printed file. And as you can see, we have our file contents, which were API key, and so on. Great, so what we've done in this lecture is we were able to encrypt a file that has some secrets on our local machine, then push this encrypted file, which is this file, to our repository. And in our workflow, if we need to work with this file, we can decrypt it using a passphrase that we created, and this passphrase can be saved in the GitHub secrets, and then we can use this file and access its contents. Great, so this can be also very useful in many cases. Let's now move on to the next lecture. Throughout the course, we've been using this $ double curly brackets syntax, and inside of it we are using some objects that have some information about our workflow. So let's in this lecture take a deeper look into this syntax and what else we can do with it. So what you write in this syntax is called an expression, and an expression is something that you need to evaluate. So when we are using these objects, we need to evaluate the value of secrets.passphrase and then put it here as a value for our passphrase in our YAML file. But this, however, is not everything we can do in these expressions. In these expressions, we can also have literals, which are maybe numbers, booleans, true or false, could also be just a string, also float numbers and stuff like that. And we can also have operators, so we can have things like comparison, comparing two strings, and this will result in a boolean. We can also compare numbers, for example. And we can also have functions. So in addition to, let's get this back to what it was. In addition to these objects that we can use, GitHub also provides some functions that we can use. And these functions will be evaluated inside this curly brackets syntax, and the result will be passed to some key in your YAML file. So this is basically what expressions are, but let's in this lecture focus on these objects that we can use. We've already seen GitHub and secrets, so let's see what else do we have. So these objects are called contexts, and contexts contain some information about your workflow. So the secrets context, for example, contains your secrets. The GitHub context, as we saw, contains the token, the GitHub IDs, commit ID, stuff like that. And in this article that I'll put you a link to, you can find a table with all the available contexts. But if we scroll down a bit, we have this workflow here. And what it does, it logs all the available contexts that we can use so that we can see what's inside of them in our logs, alright? So I'm going to copy this and create a new workflow. Let's call it context.yml. I'm going to paste, and I'm just going to give it a name. And let's see what do we have here. So as I mentioned, in expressions we can have functions, and one of these functions is toJSON. And this workflow uses toJSON in order to convert our contexts into JSON so that we can see them clearly in our logs. So we are doing this for the GitHub contexts, another one called job, steps, runner, strategy, and matrix. We've already worked with GitHub and secrets so far, so let's take a look at the rest of these. So I'm going to push, commit and push, and get back to you. So I'm done pushing. Let's go to our actions tab and see the result of this new workflow. So here it is, context. And and it only has one job. So first let's take a look at the GitHub context here in this step. And we have our token, which we used before. We have our branch in ref here. We have our commit ID. We have our repository name, repository URL, GitHub username. We have our workflow name. We have our event name, which is push in our case. And we also have some other information which you can take a look at. And this can be very useful, as we've already seen. Let's take a look at the job context. And it will just contain some information about your current job. And in our case, this is just the status of our job, which is success. We have our steps context. And for now, this is an empty object, but we've actually used this before. Remember in, I think in our actions. Yes, when we needed to log the output of our action, we can reference a step using this steps context. And then if we have a step that has an ID, it will be available here and we can access it and then access its outputs. So using the steps context, you can access steps from other steps, right? You also have the runner context, which contains some information about your runner, your virtual environment, your operating system, the workspace, and so on. We also have strategy and matrix, but we'll take a look at these probably in the next section in more detail. Alright, so this was a quick overview on what you can get using these contexts. Let's in the next lecture take a look at other functions that we can use in our expressions. So here we've used toJSON in order to see our contexts in a JSON format like that. Let's see what other functions can we use in our workflows in the next lecture. So we have some functions other than toJSON that we can use in our expressions, in our YAML workflows. And you will find these also in the link that I will leave you. However, let's take a look at some of them. And this is by creating a new job and also logging the output of these functions as we did here. So I'm going to copy this new job just to save some time, and let's walk through it. So here I just created a job called functions, and it has a step, and in this step I'm echoing the output of some functions. So we have contains, and contains will check if the string in the second argument is contained in the string in the first argument, and it will return a boolean. So ll exists in hello, so this should return true. We also have starts with, which will check if a string starts with another string, and these will be the arguments, and it also returns a boolean. And similarly ends with, and we also have format, which will have some placeholders, so 0, 1, and 2, and these placeholders will be replaced with the argument. So 0 will be replaced with this argument, and 1 with this, and 2 with this. So I'm going to run this workflow again real quick here, just to check the outputs of these functions. So I'm going to commit and push and get back to you. So I'm done pushing. Let's go back to our actions tab and our context workflow. And now we have this functions job, which has a dump step. And as expected, we have true, 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 and our string. Great. So we also have other functions as well, like hash files, which we'll actually use when we talk about caching in our workflows. So just for now, know that these functions exist if you ever needed to use them. And let's finally talk about another type of functions which we can use, which are called job status functions. So let's take a look at what job status functions are in the next lecture. In the last lecture, we've seen some of the functions that we can use inside of our expressions. And we've also mentioned that we have other kinds of functions that are called job status functions. And as the name implies, job status functions returns information about the status of your jobs. So before getting into that, let's take a quick look on a key called if that we can have in our jobs or in our steps. Let's add it here in our step. Can have some condition, and if this condition is true, this job will run, otherwise this job will not run. So if we receive an expression, and we don't have to put it in curly brackets because GitHub will already treat anything inside of if as an expression, so we don't have to put our curly brackets. So what can we check for example, let's say our workflow runs on push and also on pull request. So in this case, we might need this job to run only on push, for example. So how do we check for that? Remember when we logged our contexts, we had our GitHub context, and inside of it we had event name, which is push. So what we can do is we can simply check for github.event name and then use our equals operator and check if it's push. And this way, this job will only run on push and it will not run on pull request. Great, so using if, we can only use our job status functions. So as I mentioned, if can also be used in steps, not only in jobs. So let's say our first step here will fail because, for example, we are mistyping echo, so this does not exist. So as you know, when a step fails, any subsequent steps will not run. However, if we added if here in our second step, we can make this step run even if the previous step has failed. And this is by using a job status function, which is called failure. So this function will only return true if the previous step has failed. And when this returns true, this step, the second step, will run even if our first step failed, which normally should avoid the next step from running, right? We also have a success function, which will return true if the previous step was successful. We also have cancelled, which will return true if the workflow was cancelled. And we have always, which will always return true. So let's try always. Let's say one of the steps, let's say the runner context step. We need this step to always run even if anything has failed in the previous steps. So we can use if and always. So by having this step will always run no matter what happens in our workflow. If anything fails, this step will always run, right? So let's try this, and what should we expect? We should expect that our first step will fail because we mistyped echo here, and normally this will stop our the rest of our steps. But since we have if failure here, then the second step should run, and also since we have always here, the runner context step should run. So I'm going to push and get back to you. So I'm done pushing. Let's go back here and context and wait for our we called it 1, this job 1. So great, as you can see, the one with echo mistyped has failed. However, the next one ran because it has if failure, and also our runner context ran because it has if always. Great, so far we've been building up knowledge, and very soon we will be able to create a full workflow that actually does something useful. But we still have to learn more about our jobs. We've done a lot of things in our jobs so far, but there are still a lot of things that we can do in our jobs, like matrices, for example, and running Docker containers and stuff like that. So let's in the next lecture learn more about stuff that we can do with our jobs. And then next, I think we will be ready to create a real life workflow that does something really useful. So see you in the next section. We've learned a lot so far about GitHub Actions and our jobs and steps and so on. However, there are still a couple of things that we need to know about, and these are strategy and also using Docker containers. So in this section, we will take a look into these two things. But first in this lecture, let's take a look at a couple of options that we can use in our jobs. And I won't actually try to run these options, but I just need you to know about them. So one of them actually we've seen before. Remember in our simple workflow, we have used needs. And needs can be used if you, for some reason, do not want to run your jobs in parallel. However, you need to run them in a certain sequence. So as we did here, this job, run Windows commands, depends on run shell commands. So when our workflow runs, run shell commands will run first, and then when it finishes, run Windows commands will run. And this is actually an array, so you can depend on multiple jobs as well. And your job can wait for multiple jobs to finish first before running, alright? Another option that could be useful. So here, for example, we have 3 steps, right? And as we know, if a step fails, all other steps will not run and the job will fail. And we've seen in the previous lecture that we can force a certain step to run. So let's say the second step, we can add if and failure. And what this will do, it will run this step even if the previous step has failed. However, this will run only this second step. It will not run any subsequent steps. So what if we want to run all other steps? If one step fails, we can add a key called continue on error. And by default, it's false. But if we set it to true, all other steps will run even if this first step failed. Alright? So that can be useful in some cases. Another option also is timeout minutes. And this can be added either in a step or in the whole job. So let's first add it in a job. So timeout minutes, by default, it's 360, which is 6 hours. And what it means that this is the maximum number of minutes that your job can take. So if your job took more than 360 minutes, GitHub will cancel it. So if in any case you think your job will take more than 6 hours, you can just increase this number. And if you think 360 is too much and you need to cancel your jobs sooner, you can decrease this number. And this also, as mentioned, can be used in steps. So timeout minutes. And you can set a maximum number of minutes before GitHub kills your process. Alright, so these were just a couple of options that you can use. But now let's get into a more, maybe more commonly used option that we can use in our jobs, which is strategy. So see you in the next lecture. In GitHub workflows, we have an option called strategy, which we can specify in a certain job. And this option will allow us to set up an environment matrix. So let's say we would like to run our job in different environments. So maybe we'd like to run it on a Windows virtual machine and then Ubuntu machine. And maybe we would like to also run it using different Node.js versions. So maybe one time using Node 6, Node 7, Node 8, and so on. Using the strategy option makes this very easy. So let's say we have a job that we would like to run using different Node.js versions. As we know, our virtual machine has a certain Node version, and this is what will be used by default. But we can actually change this node version using a GitHub action called setup node. So I'm going to create a new workflow in our workflows folder, and I'm going to call it matrix.yml. And let's call it matrix, and let's run it on push, and let's write a job. So in our jobs key, and I'm going to call this node version. And in this job, we would like to use the setup node action to change the node version that our virtual machine uses. So what I'm gonna do is I'm gonna add some steps. And in the first step, we will log our node version. So let's call it log node version. And I have a space missing here. And in this step, I'm just gonna run node-v. And this will display the current node version on our current virtual machine. But now, as we mentioned, we need to change this version. And this is by using the setup node action. So I'll put you a link to the documentation for the setup node action. But actually it's very simple. You just use the action, and then we have an input, which is the version that we would like to use. So I'm going to copy this step and put it in our workflow like so. And let's say we would like to use version 6. And then I'm going to log our node version again after running this action. And I have an error here. I think I need to specify an operating system. So let's run this on Ubuntu. So now what should happen is we should log our current node version, which comes with our virtual machine. And this should be a new version. And then here we used the setup node action, which will change the node version on our virtual machine to version 6. And then we are logging again, and we should find version 6 when we log it again. So let's push this and view our workflow. So I'm done pushing, and I'm going back to our actions tab. And we have our matrix workflow. Right, so our first step, we are logging our node version, which is 12.13. And then we are running the setup node action, which will download version 6 of node as we specified. And then we are logging node version again, and now it's 6.17. Great, so now we can run our workflow on a different node version. But let's now say that we need to run it on multiple versions, maybe 6 and 7 and more. And this is where we can use the strategy option. So let's take a look at that in the next lecture. Let's now see how to use strategy in order to set up a matrix of environments. So as we mentioned, we need to run this job not only with node version 6, but we need to try it with other versions as well. So we need to run this job multiple times with different node versions. So what we can do is we can duplicate our job and then add a different version here. But of course, this is very repetitive and redundant. So using strategy, this is made a lot more easier. So in our job, we can define a strategy key. So this strategy key is under our job. And then inside this strategy key, we have some other keys, including matrix. Inside of matrix, we can define some arbitrary key names. So let's say node version. And this can be anything, any name you like. And it can be an array of any values that you would like. So let's say 6 and 8 and 10. We also have the fail fast option inside the strategy key. And by default, it's true. So now we are running this job not only once, but we will run it 3 times for each one of these versions. And what fail fast means, it means if one of these job fails, all other jobs that are running in this matrix will stop. If this is set to false, each of our 3 jobs will run independent of the result of other jobs. Alright, so 6 will run, 8 will run, 10 will run, even if one of them failed. So I'm going to remove this for now. You can use it if you like. But we have another option in our strategy, which is maximum parallel. So as I mentioned, now we will have to run this job 3 times for each of these versions. And these 3 jobs will run in parallel. And using this option, we can limit the number of jobs that are running in parallel in this matrix. So by default, GitHub will try to maximize this number, but if you would like to limit them for some reason, you can use this option. I'm not going to use it for now. We just need to try to run our matrix. If we push now and run using this matrix configuration, our job will run 3 times. However, since we are hard coding version 6 here, it will run 3 times and each time with the same version 6. So here we don't need to have 6. We need to reference the current version in each of these matrix runs. And this can be done using a context expression. So remember when we were logging our contexts, we had these strategy and matrix contexts, and we mentioned that we will talk about them later. So using the matrix context, we can reference the values that we put in this matrix object. So here if we put matrix.node_version, this value will be different according to which job is running. So for the first job, it will be 6, and then it will be 8, and then it will be 10, and so on if we have other values as well. Now you might be wondering, this is not actually a matrix, it's just an array or a 1D matrix. But here in our matrix key, we can also add other factors as well. So let's say we need, in addition to running our job for these different node versions, we also need to try it for different operating systems. We can add a different key here. Let's call it OS. And we can choose to run it on maybe macOS latest, Ubuntu latest, and also Windows latest. And now we have a 3 times 3 matrix. So our job will run 9 times. So 1 time for macOS node version 6, macOS node version 8, macOS node version 10, Ubuntu 6, Ubuntu 8, Ubuntu 10, and so on. But remember that we also have our Ubuntu here hard-coded. And in order to reference the current operating system in our current job, we can just use matrix.os, where OS is the name that we chose here, which could be anything. Right? So I'm going to push now and get back to you in our actions tab to see our workflow running. I am done pushing and I'm going to refresh our actions tab and open up our matrix workflow. And as you can see, we have 9 jobs here. And looks like the macOS jobs did not run. I probably have a typo or something. Yes, I have a typo here, I forgot the T. But anyways, you got the idea. Our job will run for macOS 3 times for each node version, and for Ubuntu 3 times for node 6 and node 8 and node 10, and same for Windows. Great, so this can be a very powerful feature. And of course, it's not only for nodes, it can be used for anything. You can have any arbitrary arrays here and create your own matrices and reference your current values using the matrix context. Alright, so in the next lecture, we will take a look at one more thing that we need to know about matrix, which is include and exclude. So see you in the next lecture. In some cases, you might have this large matrix 3 by 3, which will run 9 times. However, you might not need to actually run it for all the different combinations. The 9 combinations, you might need to run it for most of them but exclude some of them. So let's say, for example, we need to run all our 9 jobs, but exclude the job when the OS is Ubuntu latest and the node version is, let's say, 6. So what we can do is we can add an exclude key, and this will be an array of objects, and each object will have the keys and the values of the job that we need to exclude. So need to exclude for OS, let's say Ubuntu, when the node version is 6. So by having this, our job will run only 8 times, not 9. So let's try to exclude another one, maybe macOS latest, when node version is 8. So now our job will run 7 times. We also have include, which can be a bit confusing. You might think that we can include other configurations to our matrix. So for example, we don't have version 4 node here, so maybe we can add, for operating system Ubuntu, we can add node version 4. And you might think this will add an extra item to your array or your matrix. However, this is not actually the case. What include does is it includes extra variables for a certain configuration that already exists in the matrix. So let's say for Ubuntu and node version 8, for example, which exists in this matrix, Ubuntu and 8, we need to add an extra variable. Let's say is Ubuntu and 8, and set it to true. And this has to be a string, so let's make it a string. So now what will happen is, inside of our matrix context, we will have a new variable, which is Ubuntu 8, and this will exist only when the job is running for Ubuntu latest and node version 8. And in order to confirm, let's add an environment variable, and let's call it is Ubuntu 8, and the value for it will be inside an expression inside our matrix context, and is, let's copy it to avoid any typos, is Ubuntu 8. So this environment variable will be set to true only when we are running our job for Ubuntu and node version 8. Otherwise it will be a null or an empty string. So let's confirm by adding this, let's, instead of logging our node version, let's also log this environment variable, right? So echo, and I'm also going to copy it to avoid any typos. Alright, so I'm going to push and see this in our GitHub workflow. But before that, let's recap what we've done. We have excluded 2 configurations that will happen in our matrix. So we have macOS, which will run for 6, 8, and 10, and Ubuntu will also run for 6, 8, and 10. And let's say we don't need our job to run for Ubuntu and 6. We can exclude it in this array, and also Mac and node version 8. So now instead of 9 jobs, we should see 7 jobs in our workflow. And we also used include, and what include does, it can just add extra configuration in our matrix context for certain matrix configurations. So when our job is running for OS Ubuntu and node version 8, we need to add an extra variable to our context, matrix context. And we are confirming that this is working by adding an environment variable which holds the value inside is Ubuntu 8 in our matrix context, and then we are echoing this environment variable. I'm going to push now and we will see our workflow. So I'm done pushing. Let's go back here and open up our matrix. And as you can see, we have only 2 jobs for macOS, and we have 2 jobs for Ubuntu, and we have 3 for Windows. So a total of 7 jobs as expected. And what we need to check also is this environment variable. So it should be true only when Ubuntu and Node 8. So let's open Ubuntu and 8. And as you can see, true. And if you open any other job in our matrix, it should be an empty string. So include and exclude can also be very useful. But that's all what we need to do about strategy and matrix. Let's now move on. And what we are going to do next is we are going to see how to use Docker containers in our jobs and also in our steps. So see you in the next lecture. For the rest of this section, we will be talking about Docker. So if you don't have any Docker knowledge, I think you will have to go learn about Docker first if you are interested in using Docker with GitHub Actions. And if you are not interested, you can skip the rest of this section. But if you have some basic Docker knowledge, you will be fine. So I'm going to start by creating a new workflow. I'm going to change our matrix workflow to pull request so that it won't run every time we push. And I'm going to create a new folder or file in our workflows folder. And I'm going to call it container.yml. And let's give it a name on push. And let's write our first job, which I will call node docker. So as we know so far, we can run our workflows on virtual machines using some operating systems that GitHub Actions provides us. But what we can do is we can actually use a Docker container that will be installed on this virtual machine, and that our step will run on instead of running directly on our virtual machine. So here we can have a container, and this can be an image from Docker Hub. So here I have Docker Hub opened, and let's say we need to run a node Docker image. And let's choose one of these images. Let's say 13.5 with a Linux Alpine version 3.10. So I'm going to copy this. And how you should put it here is you put your Docker Hub username, which in this case is node, and then colon, and then your image. And here it says we have an error, but don't worry, this is just also probably a bug within the YAML VS Code extension that we are using, but this is completely fine. It's showing an error because it's expecting this to be an object, not a string, because we can also pass it as an object. We can have a container as an object, and it will have an image, and it can have other things as well. So we can have environment variables that will be available in our container. We can have an array of ports that we can expose in our container. We can also have volume mappings in volumes to map a volume in our Docker container to a volume in our virtual machine. We can also have options, and this can be options that you can use when running Docker create, like CPUs, like host name and stuff like that. So if you know about Docker, you can use these options. However, I'm not going to go deep in Docker. I'm just going to use the image. All right. So by having our container defined in our job, any step that we will run inside of this container and not directly in our host, which is our virtual machine. So let's create a step, and let's, as usual, log our node's version, and this time it should be 13.5 which is the version of the container, and not the version that comes with our GitHub virtual machine, right? So I'm going to run a couple of things, our node version, and I'm also going to log some information about our operating system, just to confirm that we are running on Linux Alpine version 3.10. And to do that, we can use cat and then view a file in etc and os release, right? I have a typo here, name should be in lowercase, and now I'm going to push and get back to you. So I'm done pushing, and let's go back here and open up our container workflow. And as you can see, we have a new step here, initialize containers, which will take some time. So by using a container here, instead of just running your steps in the virtual machine, your job can take a little bit more time. However, let's see our logging, and we have our node v, which is version 13.5 as expected, and our operating system info, which is Alpine Linux and version 3.10. So now we can confirm that any step that we will write in our steps will run inside of this container instead of running directly in the virtual machine. And later we will learn that we can also use a specific container for a specific step. And in this case, we can have multiple containers running on our virtual machine, and each step can run on a different container. But since we don't have a container specified in our step, it will run on the container specified in our job, right? In addition to specifying a container to run in our job, we can also specify multiple containers to run as services. So imagine you have an application that needs multiple containers in order to run. So for example, we might have an API that needs a DB running, and it needs a server running in order to send requests. In this case, we might need multiple images to run in our virtual machine. So normally we can use Docker Compose in order to do something like that. But in GitHub Actions, we have a similar way to run multiple containers for our application. And that's what we will take a look at in the next lecture. So here I have a very simple Node.js application, which is a very simple API. And if you would like to follow along, I'll put you a link to this repository, to this application, so you can clone it and try. But you also have to have Node.js and Docker installed on your machine. So if you would like to install them and follow along, you can do that. However, it's not necessary. I think you can just watch this lecture. I will just explain what this application does, and then we will try to run it using Docker on GitHub Actions. All right. So this application, as I mentioned, is a Node.js API using Express. And if you don't know Express or Node.js, you don't have to. It's just an API, all right? And it runs a server and it listens on port, which is 3000. And this API can store some data, so it needs to connect to a MongoDB database. So if I need to run this application, and I can run node app.js. However, my application needs to connect to a database, so I also need to have a database server running, which is in this case a MongoDB. So I have an application called MongoDB Compass, which is just a UI for MongoDB. I'm going to connect. And then I have a table called users here, or a DB called users, and this is the DB that I'm going to connect to in my application, all right? And I also have Postman opened, and I'm going to try to run this API locally. So I'm going to run a GET request to localhost port 3000 and /API/users. And this will just return an array of users which are stored in my DB. I can also send a post request to API/user with a body of username and address, and I can add a new user. So very simple, but the point of this is that we need to run this application using Docker. So I'm going to stop my server, and I'm also going to disconnect my database. And using Docker, we can have a MongoDB image and an image for our application, and we can run our DB and our application using Docker, right? So here I have my Docker file, and what it does, it just uses a node image and it copies package.json, runs npm install, exposes port 3000, which is the port used in my application, and then it runs node as a command. It runs node app.js. So if I run Docker for this folder, node app.js will run, and this will start my server, my API. However, there will be no database started, so this API will not work. So using Docker Compose, we can have multiple Docker containers run together, right? So here I have my app, and for my app, I'm not using an image. I'm using just my current folder, which is dot, which will run this Docker file. And I'm also mapping port 3000 to port 3001. And this could be anything, by the way. It could also be 3000. However, I'm just changing it to avoid any confusion. So port 3000 will be the port in our container. 3001 will be the port that we can access our container with from outside the container. And then we have our MongoDB image, which will pull the Mongo image from Docker Hub. And it will run on this port, and I'm mapping this port on the Docker container to this port on our host, which in this case, my machine. All right. So remember, I don't have any server running locally or database. All of these are stopped, and we need to run this application using Docker Compose. So we can run Docker Compose build, and this will build our images. And then we can run Docker Compose start to start our application. So as you can see, our app and our Mongo containers ran successfully. And now we can, inside my local machine, we can access our application using port 3001. So remember, we need to access port 3000 inside my app container. And to access it from outside the container, we mapped it to port 3001. So I'm going to send a request to 3001 instead of 3000. And it has one user that I created before. And let's create another one. So same post request to API/user. And let's say hello to, and send. And successful. And if we get our users again, we have 2 users now, right? So this is just a very simple application that can run through Docker, but it needs multiple services in order to run our main application and our MongoDB image. Let's now say we need to run this API, this application, on GitHub Actions. We've learned how to specify a certain container that our job can run on. However, now we have multiple containers that depend on each other. We have our application and our database. GitHub Actions allows us to run multiple containers. So in our case, we need to run our application and a MongoDB container. And so I published this simple application on Docker Hub under this username. And we already have a Docker Hub Mongo. We already have a Mongo container or image on Docker Hub. So let's try to use both of these to run our application on GitHub Actions and try to send and receive requests from our API in the next lecture. In the last lecture, we've seen this very simple Node.js application that I created, and we saw how to run it without Docker and also using Docker Compose. Using Docker Compose, we can run our application, our node server, and we can also run a MongoDB server that we use in our API. And as I mentioned, I have published this simple application on Docker Hub so that we can use on GitHub Actions. And we also have already a MongoDB, official MongoDB image. And now we need to run these two images on GitHub Actions. So let's go back to our workflow. And instead of having a container here, we can have services, right? And inside this services key, we will have a very similar structure to how we do it in a Docker Compose file. So I think we can actually copy it and put it here and just fix our indentation. But now in our app, our main app, we won't build the current folder like here. We will use our image that I published on Docker Hub. So I'm going to copy the username and image name and put it here. And instead of build, I'm going to use image. So this will run two containers in our virtual machine, one for the app and one for MongoDB. And in order to communicate between these two containers, we can use the service name as a host name. So here, when we connected to our MongoDB, we used localhost. However, in Docker, in order to communicate with another container, we will have to use our service name, which is in this case, Mongo. All right. So when I published this application to Docker Hub, I used Mongo instead of localhost, and this way the app container can communicate with the Mongo container. Right? Great, so that's it, but just to confirm that these are working, I'm going to have some steps that will send a post request and get request to test our API. So let's remove the old step that we have here, and let's call this post a user. And we will run a curl command to send a post request. I'm going to copy this because it's too long. You can also copy it from the repository that I will provide you. But all it does is just sends a post request to localhost 3001. Remember, we are now running this step, not in a container, however, directly in our virtual machine. And if we need to access our container from outside the container, which in this case our virtual machine, our host, we use the port that we specified here, which is 3001. Right? So this command will run in our virtual machine and not inside the container. Right, so I hope that's clear. Now we send some headers and we send our body, which has the username and the address. So now we posted the user. We need to get all users to confirm that the user was created. So get users, and then run curl and then localhost. Let's actually copy it from here. It will be the same, but it will be a get request instead of a post request. Alright, so I'm going to push this and get back to you. So after pushing, I realized that I have a typo here. It should be users instead of user, right? So sorry for that, and I'm going to push again and get back to you. So I fixed the typo and pushed again. Let's go back to our Actions tab and open this one up and wait for it to run. And as you can see, initializing our containers can take a while. Alright, so now let's take a look at post a user, and looks like it was successful. User created successfully. And let's open our get users. And now we have an array which contains the user that we created. Alright. Great, so that was an example to how to run multiple Docker services on your workflows using GitHub Actions. Let's now see how to run Docker containers in your steps. So see you in the next lecture. In the previous lectures, we've seen how to define a Docker container in our job. And by having a Docker container defined in our job, any step that we will run inside of this Docker container. And we've also seen how to define multiple services for our job. But Docker containers can also be used inside of individual steps. So let's take a look at that in this lecture. But before starting, let's take a quick look on a Docker concept that you probably already know about. However, let's make sure that you understand it, because we will use it when we run Docker containers in our steps, right? So when you are writing a Docker file, so imagine this is a Docker file, you have some instructions like run, copy and stuff like that. And you can also have an entry point. And an entry point is a command that will run when your Docker container starts. So it could be something like echo some string or something like that. And this is called the shell form of the entry point. Entry points, however, can have a different form, which is called the executable form. And how this looks like, it looks like an array where the first item in the array is a path to an executable file. And then the next items in the array are the arguments that you would like to pass to this executable file. So for example, if we need to run echo using this form, we can find the path to the echo command, which we can get using type -a and then the command, which is echo. And it says echo is bin/echo. So we can copy that and put it here, and then type our string here, and this would be equivalent to echo and then our string. Alright? So this is the form that is used by GitHub Actions. So keep that in mind. And in our Docker file, we can also have a command. And if this command is passed as an array, we can have additional arguments to our entry points. So if you have, let's say, world, when this container runs, it will echo hello world, because the items in the command array will act as additional items or additional arguments in your entry point. Alright, so you probably already know about this. But anyways, this will be important when we write our steps as Docker containers. So back here in my workflow, I'm going to create a new job, and I'm going to call it Docker steps. And let's say we need to run this job in a container, so we can run it on Ubuntu. Because, by the way, containers can only run on Ubuntu. They cannot run on Mac or Windows. And then we can specify a container with some image. And I have here my node image open in Docker Hub. So let's choose some version. Let's say this one, 10.18. So here we can have node and then colon and then our version. So nothing new so far, we've seen this before, and we already know that if we write any steps here, they will run inside of this container. So let's write a quick step log node version, and we will run node-v. So this should output 10.18, right? So nothing new so far. What we can do, however, is we can write a step that uses its own container. So let's create a new step, and let's call it step with Docker. And using the uses key, which we've already seen before, we can use a GitHub action, like maybe actions/checkout, which we've used before. But in addition to GitHub Actions, we can also use a Docker container in the uses key. So by having Docker and then colon and // and then a Docker image, so let's say also node and then a version. Let's get another version from here. Let's say 12.14. We can run this container when this step executes. And if this Docker image has an entry point, this entry point will execute. However, we can also override the entry point for our Docker image using the with key. So we've used the with key before when we used GitHub Actions to provide inputs to our action. However, in case of a Docker container, we can provide an entry point. And you might think that an entry point will take an array like how we do it in the Docker file. However, this is not the case. In GitHub Actions, an entry point is just a path to an executable. So what we can do is we can pass it the echo, for example, and we can pass arguments to echo using args, and args will act like the command here, where we can pass arguments to our entry points. So you might also think we can pass an array of arguments. However, currently we cannot. We can only pass one argument as a string. So let's say hello world. So now when this step runs, this Docker container will run and its entry point will execute, and we can override this entry point. So in our case, we are going to run echo and this string as an argument. So let's try to duplicate this step and run another entry point. So let's say we need to log our node version that is used inside of this Docker image, which is 12.14.1. So what we need to do is we need to run node-v as an entry point to this Docker container. And to do that, we, as we mentioned, we cannot use node directly. We have to use the path to the node executable file. And to get that, we can use type -a and then node. And here is our path. I think this could be different for Windows, but anyways, we are using Ubuntu here, so it should work. So our node, and then as an argument, we need to pass -v. And by the way, we are using YAML, so we can omit these strings or quotations, sorry. Great, so let's try and run this step. But before running it, let's just recap what should we expect. We are having a job, Docker steps, which uses a container that has a node version of 10.18. And then we are writing a step without any container specified, and it just runs node-v. So node-v in this case should run inside of this container. So it should be 10.18. And then we are using another step that uses a Docker container with a node image of 12.14. And as an entry point for this container, we are running echo and some string. But then we are having using the same image again, but running node-v. And in this case, node-v will not run inside of this container. However, it will use its own container, which is based on this image, node 12.4. So we should have 12.4 outputted from this step, right? So I'm going to push and get back to you. All right, so I'm done pushing. Let's go back to our repository and our actions tab and open up our container workflow and wait for our Docker steps job to finish. As you can see, it's pulling our images and initializing our containers. All right, so it took a while, 28 seconds. Let's now take a look at our first log node step, which should log 10.18. And here it is, 10.18. And then our second one, which uses this node image, 12.14. But we're actually just echoing here. So let's take a look at that. And here we have our string. So our entry point ran successfully. And then we tried another entry point using the node executable this time. And here it is, and it's 12.14. Great, so this is how we can use Docker containers in our steps. But in addition to using some existing command in our system as an entry point, we can also write our own script, our own entry point, and run it in our step. So let's take a look at how to do that in the next lecture. So far we've used echo and node as entry point executable files to our steps that uses Docker containers. However, we can also use our own script. So in my repository, I'm going to create a new file, and I'm going to call it script.sh. So this is a bash script, and at the top of the file, we should specify which shell we would like to use. So I'm going to use sh. You can also use bash. It could also be Python or anything. However, we'll just echo some stuff, so I'm going to use sh. And this can be a complicated script. You can have if conditions, loops, stuff like that. However, I'm just gonna echo a string, just as a simple example. And then I'm going to create a new step. Let's actually duplicate this one and just modify it. So I'm going to call it run a script, and let's keep this Docker image. However, for our entry point, let's now use our own script that we just written. So this will be relative to your root folder. So in our root folder, and it's called script.sh. And we can also pass it arguments. So let's say some string as an argument. And how to access this argument is by using $1. So let's echo that as well. But remember that now we will have to use a file in our repository. So we need to have access to this file. So we need to use the checkout action. So I'm going to, before this step, I'm going to add another step that uses actions and checkout, and let's say version 1. And finally, in order to make this script executable, we have to run some commands. So let's clear this. And what we have to do is we have to run chmod +x and then the path to our file, which in this case script.sh, right? So make sure to run this command before committing your file. So that should be it. Now I'm going to add my files and commit and get back to you. I'm done pushing, and I'm going to go back to our actions and our container workflow, and let's wait for Docker steps to finish. So it took a while, and now it's done. So let's take a look at run a script step, and it echoed our two strings, sum and hello world. I think we had it was some string, but it only echoed sum. I think it interpreted this as a first argument and this as a second argument, but here we are echoing only the first argument. So we can do this, and this will be the second argument. However, I will try it and confirm and get back to you. Alright, so I tried it using $1 and $2, and it worked. So I personally didn't expect this to happen. I expected this to be treated as one argument. However, this was treated as an argument, and this is the second argument. But anyways, that's not a problem. Let's now see a final example of using Docker containers in your steps, which could be a little bit more useful than what we've done so far. So now that we know how to run a Docker container in our steps, let's do something that could be a little bit more useful than we've done so far. So here I have a Docker image that I will put you a link to. And it's also a very simple Docker image. And what it does is when you run a container from this image, the container will run a script that will send a Slack message. So when we use this, we don't have to specify an entry point or any script to run. This image will already do something, which is sending a Slack message. So let's use it, and to use it, it's very simple. All you have to do is you have to have a Slack webhook environment variable and a Slack message, which will be the message that you will send. You can also have other stuff as well, which you can take a look at. However, we're only interested in these two because it won't work without them. So I'm going to copy the username and the image name from here, and I'm going to create a new step, and let's call it send a Slack message, and this will use a Docker image, so Docker :// and then paste our Docker image. All right, and now we can add the environment variables required, which are Slack webhook and our Slack message. So let's add a message, and let's now go and generate our webhook. Right, so I'm currently logged in to my Slack account. I did some testing already, so we have some messages here. But in order to generate a webhook that will authorize us to send a message to Slack, we need to create a Slack application. So while logged in to Slack, go to api.slack.com/apps and then create a new app. I'm going to zoom in a bit so that you can see. So create a new app and just give it any name and choose a workspace and create. And then choose incoming webhooks, which will allow us to post messages from external sources, which is exactly what we need to do. And then turn it on, and then add a new webhook to workspace. And let's choose a channel to post to. Let's choose general and allow. And now we have our webhook, which is this URL that we can copy. Alright, so now we can put it here, but this will not work. This should be a secret, this webhook, because it actually gives people access to send messages to your Slack account. And if you put it like so, hard-coded, and push it, Slack will actually detect that your webhook is exposed, and it will send you an email with that, and your message will not arrive. The webhook will not work this way. So of course, you know what we should do. We should put it in a secret. So secrets, and let's create a secret called also Slack webhook. So I'm going to copy just to avoid any typos and go and create this secrets in our settings in our repository, and secrets, add new and our name, and then I'm going to copy my webhook. Alright, so great, that should be it. Hopefully I didn't forget anything. Anyways, let's try and push and watch our workflow running, and then we should see a notification in our Slack. So I'm going to push and get back to you. So I'm done pushing, and let's go back to our actions tab and container. And this will take a while since we already have a lot of steps here with different containers. And I'm not sure if you heard this, but I just got a Slack notification. And let's open our Slack, and our application, which we called bot, sends us a message in the general channel, as we expected. Alright, so that could be very useful, and as you can imagine, Docker Hub has a lot of images that could be useful. So by being able to run these images in our step, our possibilities are endless. Great, so I think now we know everything that we need to know about using Docker with our jobs and our steps. And I think now it's time to create a real-world workflow using all the knowledge that we've learned so far. So see you in the next section. In this section, we will create a CI/CD workflow. CI/CD stands for continuous integration and continuous deployment. So continuous integration is a practice where one or more collaborators frequently commit code to a shared repository. And by committing code more frequently, it will be easier for us to detect the source of an error. So what we need to do in the workflow that we will create in this section is whenever someone commits some code on our repository, we need to make sure that this code will not break any tests or introduce any errors. So we need to run some tests and make sure they ran successfully. And we can check for other stuff as well. Like for example, making sure the code is formatted properly in case we are following a certain formatting style. And we can do other stuff as well, as we will see. But at the end, after all our checks passed, we need to deploy our code into some server. Alright? So in order to try out these things, we need to have an application that we need to test and deploy and so on. So what I'm going to do is I'm going to use a boilerplate React application. You might be familiar with Create React App, but what it does is that it creates a very simple boilerplate React application. And this is what we will use to test and deploy and so on. And you don't have to know React. We'll just use this boilerplate as it is. We won't actually write any React code. So if you are not familiar with React or JavaScript, or even if you are familiar and you don't want to follow along with me, you just want to watch the lectures and see the concepts, I think that's completely fine. All the concepts that we will discuss in this workflow that we will create can be done in other languages as well, maybe with different tools, but as a concept, it will still be the same. If you choose, however, to follow along, make sure you have Node.js and npm installed on your machine. And let's create our boilerplate. So I'm going to copy this line here, which uses npx to run create react app CLI. And it takes a name for our application. And I'm going to use npm. By default, it will use yarn. I'm going to use npm just because I'm more used to it. No other reason. So I'm going to copy this, and in my terminal, I'm going to change to my desktop. I need to put this application on my desktop, so I'm going to run this command on my desktop, so paste. And I'm just going to change the name to maybe React app. And this will create a folder on our desktop and install all our needed dependencies using npm. So it might take a while. It took a little while and now it is done. And if you take a look at your desktop, you should find a folder called React app. And I'm going to change to React app and then open it in my code editor. Alright, so in the next lecture, let's take a quick look on how can we run this project and how can we run some tests and how can we deploy it so that when we write our workflow, we will know what we will have to do. So see you in the next lecture. Let's in this lecture see how to run this project and how to build it and how to test it in order to have an idea on what commands we will have to run when we write our workflow. So when you create a React project using create React app, you get some scripts that you can run, start, test, and build, and also eject. For our workflow, we are only interested in build and test. However, let's also try start, which will start a development server. So in my terminal, I'm going to run npm run start. And this should open up our browser on localhost port 3000. So for me, it opened Google Chrome on localhost port 3000. You can see it, however, so I'm going to open it here. And this is our application. It's very simple. And if we change something, let's say in app.js, let's remove React and save. And as you can see, the browser will refresh and we will not have React in this link. So this is great for development, but we're actually not interested in development at the moment. We are only interested in testing and building and deploying this app. So npm start, this will only be used in development and we will not use it anywhere in our workflow, alright? What we will use, however, is npm run test. So I'm going to clear and I'm going to run npm run test. Oh, sorry. And this will run some tests, and it actually failed. And it will watch for file changes. So the only test that we have in this boilerplate is app.test.js. And what it tests for, it makes sure we have in our app.js a link that has a text learn React. So when we removed React here, our test failed. And if we get it back, and let's open our terminal and save, our test will run again, and this time it will pass. So npm run test is also great for development because it runs this interactive testing thing that will listen for changes when we change something in our file. However, when we also run our workflow, we just need to run our tests once and see if they pass or fail, but we don't want to listen for changes, right? This is only useful in development. So in order to do that, we can set an environment variable called CI, set it to true, and then run, run npm run test while this environment variable is true. So let's see what will happen when we do that. As you can see, our tests will run only once and we will get our test results, and we are not listening for any file changes or anything like that. So by having CI true environment variable, our tests will run in CI mode, which will not listen for changes. It will just run our tests, right? So if you, for example, remove React again and run npm run tests with CI true, this command should fail, and thus when we run this in our workflow will fail. All right? So I'm going to undo. So great, so just keep in mind when we run npm run test on our workflow, we need to have an environment variable called CI, which should be set to true in order not to have any interactive terminal in our workflow, right? What we can also do, what we can also do when we run our tests. So I'm going to run the same thing again, CI equals true and npm run test. We can generate a coverage report. If you're not familiar with testing, a coverage report is a report that lets you know how much of your code is tested, and you can see which files are tested and which files are not, and so on. So in this React boilerplate, we can do that by passing an option, and this can be done by typing -- and then -- coverage. As you can see, we have some statistics here about your code coverage. However, it doesn't look that good. But what we will also get is a file in our React app folder called coverage. And if we open this folder and then index.html, we will get some information about our tests and our code coverage and which files are tested and which files are not, right? So this is also important to know. When we create our workflow, we will generate this coverage report and upload it somewhere, which we will see later, alright? And the other command that is important to us is npm run build. So when we like to deploy this application, our React app application, we will actually not deploy this folder directly. This folder is suitable for development, however it is not optimized for production. It has the node modules folder, which we will not need in production, and it also has our source code, which in production will be compiled into a single bundle. So when we run this command, npm run build, it will generate an optimized folder for production. So let's take a look. So after it is done, we can take a look at our folder again, and you'll find a new folder called build. And it has our bundles, our JavaScript bundles and so on, which are minified and optimized for production. And it also has an index.html, which will be the entry point for our application. So when we need to deploy this application, we will have to deploy this build folder, which is optimized for production, and we will not have to deploy this whole folder, right? Just the optimized one. Great, so now we know about all the commands that we can use, and we know that in our workflow, we will only have to use npm run build to build this folder, which we are going to deploy to some server, and npm run test, which will run our tests and also generate a coverage report, which we are also going to upload somewhere in our workflow. So let's in the next lecture try to deploy this folder into some server. And since it's a simple static website, it only has HTML, CSS and JavaScript, we will use a very simple service called Surge, which is used to deploy static websites. So let's see how to use Surge in the next lecture. So now that we know how to test and build our application, let's also see how to deploy it using a service called Surge. So as I mentioned, Surge is used for deploying static websites. And in our case, we have a static website, so Surge will be perfect for our case. And it's also very simple to use. To install it, you have to run npm install -g and then Surge. And then all you have to do is run the command Surge in your project directory. So I already have Surge installed on my machine. So in my project directory, I'm going to run Surge. If you are using Surge for the first time, you will have to create an account. It will ask you for email and password and so on. But in my case, I'm already logged in, so I don't have to register. And now it's asking me for the project that I would like to deploy. And since I ran Surge in our development folder, our React app folder, Surge will think that this is the folder that you would like to deploy, and it will put it here for you in the project. However, make sure you add build here, because we want to deploy our build folder, not our the whole folder, alright? And then it will create a random domain for you. Of course, you can change this to your own domain. However, we are not interested in that at the moment, so I'm going to use this domain. And as you saw, it just takes about a couple of seconds and it is done. So let's copy the domain that it gave to us and open it in our browser. And as you can see, we have our application deployed to this domain. So if you are following along, keep this domain somewhere because we will have to use it when we write our workflow. So if we need to deploy again to the same domain, we'll have to provide this domain when we run search. So let's say we changed something, maybe removed learn, and we need to deploy again. So we run search again and build, and here it will generate a new domain. However, we want to deploy to the same domain that we've used before. So we can remove this and put our domain and run. And now if you go back to our browser and refresh, and I actually forgot to build, so nothing changes here because we'll have to run build again and then deploy the build folder. So sorry for that. Let's run build quickly here. So now we created a new build folder with our change, which is removing React from this link. And I'm going to run search again and deploy the build folder. Don't forget that. And then use our same domain. Let's copy it from here and run. And if we now refresh, we will have React removed. So what I'm trying to say is that this domain is important, because when we deploy multiple times, we will have to provide this domain to search command line in order to deploy to the same domain, right? This will be important when we deploy in our workflow. Great, so that's it for search. So now we know how to test locally and build locally and deploy locally. However, it doesn't make sense to run all these things locally. We need to automate them and create a workflow to do that. But before doing that, let's do one more thing that we will run in our workflow. Let's say you would like to follow some coding format style, and we need everyone in the team that is working on the project to follow the same formatting stylings. So what we can do is we can use a tool called Prettier, and Prettier can check if the code in our folder follows certain formatting rules, and it will return an error if the code is not formatted properly. So what we will need to do eventually is in our workflow, when someone pushes some code, we need to check if their code is formatted according to our guidelines. So let's see how we can set up Prettier locally first, and then when we write our workflow, we will run Prettier in our workflow as well. So see you in the next lecture. Let's in this lecture use Prettier in order to check that our code follows some code formatting guidelines that we choose. So here I'm having Prettier.io open, and I'm going to open get started in a new tab and also try it out in this tab. So let's first install it, and I'm going to use npm, and I'm going to install it in our project, not globally. So I'm copying this, not this, alright? And here I can just paste and install it. And while it finishes, let's take a look at this playground. And here we have some options that you can choose. And these will be your formatting rules that you would like to enforce. So let's say we need the tab width to be 4. We'll have here in the preview, when we change, it will change. And you can choose other stuff as well as you like, and it will be displayed here in this panel. And then after you finish, you can click on copy config JSON, and this will copy some JSON that you can put in your project so that Prettier can know what formatting rules you prefer. So I already have some preferred rules that I generated using this tool, and I'm going to put them in our project. So to do that, we can create a new file called .prettier.rc and then paste our JSON. Alright. Another important thing we need to do before trying out Prettier is we need to create a .prettier ignore folder. And this is similar to gitignore, it will let Prettier know that you would like to ignore some files when you format your code. So in our case, for example, we don't need to format our build folder because this is automatically generated. So we can put it here. Of course, we don't need to format our coverage. This is also automatically generated. Of course, node modules. This is very large and we don't need to format it. And also package-log.json. This is an automatically generated file and we don't need to change anything in that. So I'm going to add it in our ignore, right? Great, so now we have our configuration and our ignore, and now we can run Prettier. So how to run it? We already installed it in our project. I'm going to clear. And now let's say we need to check that our code in our folder is following the guidelines that we defined here in the Prettier RC file. So we can run Prettier, or we did not install Prettier globally, so we cannot use Prettier directly. We have to use npx Prettier, and then using the check flag, so -- check, we can check that certain files are formatted properly or not. And this can be a path or a pattern. So let's say we need to check for all JavaScript files in our projects. We can give it a pattern, any file in any folder that has a JavaScript extension. And if some files are not formatted properly, it will list these files here. And it's saying that code style issues were found in the above files, right? And also npx Prettier -- check will return a non-zero exit code if we have files that are not formatted. A non-zero exit code, as you might know, means an error. So if we run npx Prettier -- check and give it a pattern on our workflow, and there are files that are not formatted, it will return a non-zero exit code, which means an error, and our workflow will fail. And that's exactly what we need. Great, so Prettier does not only check for code formatting, it can also enforce these code formatting standards. Right, so let's open app.test. And let's say we need to fix it to format it properly. We can of course do it manually, however, we can also run the same command again, but instead of the check flag, we can use the write flag. And we will fix any JavaScript files that are not formatted properly. So let's run it. And as you can see, it changed something in this file. And it also returned the list of files that it has fixed. So now let's clear, and if we run with a check flag again, we should not get any error. We should get all match files use Prettier code style. Alright, so this is how we can use Prettier to check and also fix our code. But in order to make this command easier, that's a lot of stuff to type, we can create an npm script. So let's open our package.json and let's add a script here. And let's call this one format check. And this one will check for our code formatting. It will not write. And we can run Prettier. And here in our scripts, we don't have to put the npx. Alright, we can directly write Prettier and it will use Prettier that is installed in our project. And -- check and put our path in double quotes. But we will, however, have to escape them because this is JSON and we are already using double quotes in our script. So we'll have to escape these double quotes. And inside of them, we can have our path, which is, let's say this time we will need to check for other files as well, not only JavaScript. So we can use curly brackets and put any format that we would like, comma separated. So let's say JS, JSX, YML, YAML, maybe JSON, CSS, SCSS, and MD, and I'm sorry, these are commas, not dots. And of course you can put any file types that Prettier supports you like, right? And to use this, if you're not familiar with npm, we can run npm run format : check, and this will run this command instead of typing this whole thing every time we need to run it. So as you can see, it returned an error because we have a couple of files, a JSON file and a CSS file, that are not formatted properly. So let's have another script here, the same one. So I'm going to duplicate and remove this comma and just call it format this time and use the right flag. Now here, let's clear and run npm run format, and this should fix our non-formatted files. So as you can see, these are all the files that were checked, and the ones that are highlighted in white are the ones that were fixed. So settings.json and index.css. And so if you run format check again, we should not get any error, right? Great, so now we have a command that we can run in our workflow to check if our formatting matches the rules that we defined in our prettier.rc or not. And if not, we will stop our workflow and we will not deploy the code that has some formatting errors. Great, so now we have 3 things that we need to do on our workflow. We need to run our tests, make sure everything passes. We will also need to check our formatting, which we have a command for that now. And if our tests pass and our code is formatted properly, we need to deploy our website using search, as we saw locally, however this time in our workflow. But before creating our workflow, let's first plan what exactly are we going to do in our workflow, which branches are we going to use, and how are we going to manage our flow and our pull requests and so on. And then we can start writing our workflow. So let's take a look at our workflow plan in the next lecture. Let's say in this React project that we have multiple team members working on this project. And now we need to manage how team members can push code into our repository. What branches should they work on, and when they should open pull requests and stuff like that. So I came up with a certain flow that our team members should follow. But before taking a look at this, I just want to remind you of some terms that we have learned before. So remember artifacts. In our workflow run, we can click here and download some logs, right? And we mentioned before that these files that you can download in your workflow run are called artifacts. So if your workflow generates any file and you would like this file to be available for download, you can upload it as an artifact and it will be available here. So I just wanted to remind you what artifacts are, because we will use it in our workflow. Alright, so let's take a look now at the GitHub flow that I decided that we are going to use when we write our workflows. So we will have our master branch and another branch called develop. Both of these branches will be protected, which means nobody can directly push code into them. If anybody would like to push code into develop or master, they will have to open a pull request first, and then this pull request will have to be approved and merged into one of these branches, right? So the master branch will contain deployable code, which means code that can be deployed to production. So we will never push anything into the master branch except if we want to deploy it to production. Our develop branch on the other side will contain the latest development code that we would not like to deploy yet. So now let's say one of our team members would like to work on a certain feature. He or she will open a new branch or create a new branch, and let's say it's called feature 1. And when they are done, they will open a new pull request. When they open a new pull request, we will run a workflow, and this workflow will check that their code will not break any tests, and we can also check for code formatting and stuff like that. Alright? And once we are sure that tests pass and code formatting is formatted properly, somebody in your team will review their code and approve it, and it will be merged into develop. So when someone is working on a feature, he will request to merge it into develop and not master. Alright? And once we merge some code into develop, we would also like to run some workflow. This workflow will also run our checks again, just to make sure, run our tests, check our code formatting, and in addition to that, it will also deploy the code to some staging server. So we will have to search URLs, one for staging and one for production. When some code is pushed into develop, we will deploy into the staging server, not production, right? And we'll actually see these workflows in detail in a moment. So now let's say we have enough features in the develop branch and we would like to deploy to production. We will open a pull request to merge into master. And when we do so, we will run a workflow. This workflow is of course going to double check that our tests are passing, our code is formatted properly, and when someone reviews this pull request and approves it, it will be merged into master. Once it's merged into master, we will run another workflow, which will of course run our checks again to double check the tests and code formatting, and then deploy our code to production. Alright, so let's now take a look at these workflows in more detail. So let's break down the previous chart into two parts. The first part where someone is working on a feature and he would like to merge his feature into develop. So as we mentioned, he or she will open a pull request and then a workflow will run, and then when it's approved, it will be merged into develop. And then when we merge into develop, another workflow will run, right? So let's take a look now at the details of these workflows. So the first one, when someone opens a pull request to merge a feature branch into develop, we will of course install our dependencies. As you might know, in JavaScript projects or probably any other language, you do not push your dependencies into your repository. So in the case of NPM, we do not push the node modules folder into our repository. So if you would like to run our project, we will have to install our dependencies, and in our case, it will be using NPM. If it's a PHP project, it will be Composer or a Python, pip, and so on, right? Next, we are going to check our code formatting, and we already created a command to do that in the previous lecture. We will run our tests. We already know how to do that, and this will also generate our coverage reports. And so we will upload our coverage reports as an artifact. So anybody who can view our workflow run in the GitHub interface, he can download the coverage folder as an artifact. And then finally, we will cache our dependencies. So as you know, when we install dependencies, especially if we have a lot of dependencies, it can take some time. And if we cache our dependencies, next time we run our workflow and install our dependencies, it should take significantly less time, right? Now let's go to the workflow that will run when our pull request is approved and it's merged into develop. We will of course do the same thing just to double check, check our coding format, run our tests, upload our coverage. But in addition to that, we are also going to build the project, and this will generate a build folder as we saw in the first lectures. So we're going to upload this build folder also as an artifact. And then we are going to deploy the build folder to a staging server using search. And finally, we are also going to cache our dependencies. So that's it for the develop side. Now, let's say we have enough features in develop and we would like to deploy our codes. We will open a pull request to merge develop into master, right? When we open a pull request, we would like to run our checks again, just to double check. So same thing, install dependencies, check code formatting, run tests, upload artifacts, and cache dependencies. Once our pull request is approved and merged into master, we will need to deploy our code to production, to our production server. So of course, before doing that, we will have to double check that our code formatting is proper, our tests are passing, and same thing again. And then we will build our project, upload it as an artifact, and then create a release, and we'll talk about this in a moment, and then deploy to production. And then we will use a service called CodeCov to upload our coverage reports. So as we've seen, when we generate a coverage report, we have this folder that we can download and open locally and view our coverage report. CodeCov, however, is an online service where you can upload your coverage report and view it online so that multiple people can view it easily without having to download the coverage folder and so on. So I think it's useful to include this in our workflow, and we will only do it when we push something to production, to master, so that we can have our code coverage in the latest code on master, right? And finally, of course, we will cache our dependencies as well. So in this workflow, we mentioned create a release. We'll talk about this in a moment, but first let's take a look at some other stuff that we will do in our workflow. If our workflow fails, we will have to automatically open a GitHub issue, alright? This is something that we will do in our workflow. And when an issue is created, let's say we need to send a Slack message to our team to notify them that a new issue was created. And also when we create a new release, let's say we would also like to notify our team on Slack, right? So that's all what we are going to do in our workflow. I know that's a lot of talking, but we needed to plan things before starting to write our actual workflow. Before ending this lecture, let's take a look at the creating release step that we've seen in the previous slide. If you open any library on GitHub, like for example, I'm opening the checkout action that we've used before, you will find here a releases tab. You might be already familiar with this, but if you're not, just open this and here you will find a list of releases. Each release will have a certain version, and it can also have a changelog where you have a list of things that changed in this version. And it can also have some stuff to download, similar to artifacts. So what we need to do when we push our code to production, we need to create a release. And of course, this will happen automatically. We will generate a version number automatically, and we will also generate release notes automatically. And of course, when we come to this, we will see how to do that in detail. But this is mainly what we are going to do in our workflow. So let's get started in the next lecture. So now that we have our plan and we know exactly what are we going to do, let's finally implement our plan. So first we will need to create a new repository to push our code into. But first let's create our .github folder, which will contain our workflows. So inside of it, we can create workflows. And also inside of the GitHub folder, we can have a file called code owners. So you might be familiar with code owners, but if not, it's very simple. In this file, you simply define who owns certain files in your repository. So for instance, you can have patterns like star, and this means any file. So let's say I own any file. However, you can also be more specific. So JavaScript files, I also own them. And I think I have a typo here in my username. But let's say, for example, .yml files, which will basically be our workflows, are owned by another user, which is also me, but a different account that I created for testing. Alright. In addition to specific files, we can also have certain folders. So maybe let's say this public folder is owned by someone, so we can have here public and the owner username. I'll put you a link to read more about code owners if you would like. Code owners will be very useful since our flow depends heavily on pull requests. So what will happen now when someone opens a pull request that modifies, let's say, JavaScript files? My user, which is this one, will be required to review this pull request since I own files that were modified by this pull request, right? So I hope that's clear. I will also put you a link if you'd like to read more about code owners in GitHub. So now let's go and create a new repository. I'm going to call it React app, and I'll keep it as public and I won't change anything here, and create. And let's now push our code into this repository. So I'm going to open my terminal and let's clear and git init, and then git add all and commit. And then we'll have to set our remote. I'm going to clear so that you can see, which we can copy from here. And then we can push to master, right? Great, so now we should have our code in this repository. And let's now create our develop branch. So as we mentioned, we will have master and develop. So let's create a new branch. Let's call it develop. And here we have it. And now what we will have to do is to make our develop and also master branches protected, right? So in order to do that, we can go to settings and then branches. And then here in branch protection rules, we can add a new rule and type our branch name. This can also be a pattern. And then we can choose some options here. So we need to require pull request reviews before merging. So before merging any branch into our protected branches, we need someone to review the code first. And you can choose the number of required reviews here. I'm just going to keep it 1 because I'm only one person. And you can also dismiss stale pull request approvals when new commits are pushed. So this means that if somebody approved a pull request and then the person who opened the pull request updated this pull request with new commits, this approval will be dismissed and the reviewer will have to review again, right? And of course, we will check require review from code owners, which are defined in the file that we created in our repository. Also, we can check require status checks to pass before merging, and also require branches to be up to date. So this option means that some jobs in our workflow must be successful first before we are able to approve this pull request. But since we haven't created any workflow yet, we don't have any jobs, we cannot use this option right now. However, when we create our workflow, we will come back here and see a list of jobs that we can check in this list, right? If you would like, you can also include admins in these rules. So admins also will require the same rules as anybody else in your collaborators. So they will not be able to push directly to a branch. They will have to open pull request and so on, right? And I think that's it. So let's create our rule, and it will require your password. And let's do the same thing again for our develop branch. So add rule, develop, and alright. So now if we try to push something here, so let's just add any dummy new lines here to push. So git add all and commit and push, and we should get an error because this branch is protected, and we will have to open a pull request if we need to merge something into our master or develop branches. And let's also, since we created a develop branch remotely, we will have to fetch it locally. So let's run git fetch, and this should fetch our develop branch that we created in our remote repository, right? Great, so now we have everything set up. It's time now to create our workflow. But as you can see, now we cannot push anything directly to our master or develop branches. So what we will have to do is we will have to create a new branch and write our workflow in this new branch, and then send a pull request to our repository to merge our branch into the develop branch as we agreed in our plan here, right? So I'm going to create a new branch. So git checkout -b, let's call it workflow. And now we can work on this branch and write our workflow. So let's do it in the next lecture. Let's finally start writing our workflow. Let's first start with this workflow, which is when someone opens a pull request to merge into develop. What we will have to do is we will have to install dependencies, check code formatting, run tests, and upload code coverage as an artifact, and then cache our dependencies. So let's do the first 4, and then caching dependencies, we'll do it in another lecture, right? So in our code editor, remember now we are in the workflow branch, we are not in develop or master. And in our workflows folder, I'm going to create a new workflow. Let's call it ci.yml, and let's give it a name, ci, and we need to run this on pull request when someone opens a pull request to develop, right? So on pull request and branches, develop, and let's create our job. So in our jobs, and let's call this job build. You can call it whatever you like, and let's run it on Ubuntu, and it's runs on, and let's have our steps. So first we need to install our dependencies, but of course before that we need to check out first into our repository to pull our code, right? So let's use our checkout action, and let's use version. I think currently we are in version 2, so let's use version 2, and this is uses and not use. And make sure you don't have any typos. I actually have a typo here. It's actions and checkouts, right? Next, this is optional, but if you don't like to use the node version that is available in the virtual machine, we can use a specific node version. So let's create a new step. Let's call it use node.js. And remember we have an action called actions setup node. And using this action we can specify a certain node version to use in our steps, right? And if you're using Python, for example, you will probably find an action called setup Python, and probably other languages as well, right? So let's say we need to use version 12 in our workflow. Great, so now we are using a certain node version. We will have now to install our dependencies. So we can just run npm install. However, in npm we have another option called npm ci, and this is similar to npm install, but it's more suitable for CI environments. If you are interested in knowing why and what is the difference between npm install and npm ci, I'll put you a link where you can read about that in the lecture links, right? So next we have to check our code formatting, and we already have a script that we created, which is npm run and format :check. And next we will have to run our tests. Remember how to run our tests? We can use npm test, and then we also need to generate code coverage. But remember, in order not to get this interactive terminal, we will need to have an environment variable called ci set to true, right? And next we will have to upload our code coverage, which we will generate in this step as an artifact. However, I'm going also to delay this to another separate lecture together with cache dependencies. So let's stop right now and try to push this workflow into our workflow branch that we created. So git add all, commit, and git push, and we'll have to push to we'll have to set upstream to our workflow branch that we created. All right, great. So we can now test our workflow by going to our repository and creating a new pull request. So what we will have to do is create new pull request, and let's try to merge our workflow branch, which we have written our workflow in, into the develop branch, right? So this should trigger a workflow to run. So let's open our actions tab and open our CI workflow. And our workflow is running, and you can actually see in the pull request that there is some workflow running in progress. And looks like it has failed. So, oh, okay, looks like our tests has failed because we removed React from the link. It should be learn React. So it's actually good that we have done this mistake to make sure that our workflow is working properly and it's failing when our tests are failing. So let's fix it. Or let's actually, I'm going to fix it later. Let's actually go now to our settings again, and we need to go back to our branches and our rules for the master and develop. And now that we have a workflow running, we should see now our job here, and we can require this job to be successful in order to be able to merge a pull request into a certain branch. So right now it's the master. So let's save, and let's also do it for develop, right? So before merging any pull request into master or develop, we need to make sure that the build job was successful, right? So as you can see here in our pull request, we cannot merge this pull request because we are actually requiring at least one review here, and also our checks are failing. So here in a new incognito window, I'm logged in with my other GitHub account, and I'm going to add myself as a collaborator in this repository, and I'm going to copy the invite link, and so now as a team member I can go and review this pull request This is the other account. And as you can see, since if we go back here in our code and code owners, the code owner for YML files is my second account. So here, when I'm logged in into my second account, it says code owner review required, which is me. So I can add my review and approve it. However, I will also not be able to merge before our build job has failed. Alright. So it's good that actually our job has failed to make sure that our protection rules are working fine and that we cannot merge a pull request when our job has failed. Great, so let's in the next lecture, let's fix our failing tests, and let's also work on the other workflow, which is merging a pull request into the develop branch. Right, so see you in the next lecture. So now we are done with this workflow, except for the artifacts and cache dependencies, which we will do later. Let's now do the second workflow, which will run when our pull request is approved and merged into develop. So the only difference here is that we will build our project, upload our build folder as an artifact, and then deploy our build folder to a staging server. And of course, we'll also cache dependencies in a later lecture, right? So the only different thing here is building the project and then deploying it to a server using Surge as we agreed, right? Good, so let's go back to our code and our CI workflow. And now we can have two different ways to do this. You can create another workflow, another file, which will be very similar to this one, except that here it will be on push instead of pull request. And in your steps, you will run the same steps again, but you will add a couple of more steps for building and deploying. So you can do this if you like. However, I find it a bit repetitive because we will have to repeat these steps in two workflows. And for me, this is not very ideal. If you have to modify something in one of these steps, you will have to modify it in two files and so on. But using the second approach, which is writing both workflows in the same file and using if conditions to run steps conditionally depending on the GitHub event. So let's do it and things will become more clear. So now we are running this on pull request, but we also want to run the same file when we merge our pull request into develop. So when we merge a pull request into a branch, this will trigger a push event. So let's add push here. And in branches, we will also have our develop branch, right? And now we can have steps that will only run if the event is a push event and not a pull request event. And we've already seen how to do that in the previous lecture using an if condition. So let's build our project. So I'm going to add a step and I'm going to call it build project. And all you will have to do is, as we've seen before, npm run build, and this will create our build folder that we will need to deploy. However, we only would like to run this step if it's a push event and not a pull request event. If it's a pull request, we do not want to deploy because, of course, it is not approved yet. However, if it's a push, it means that a pull request was approved and we need to deploy our new code in develop, right? So how to do that is by accessing the GitHub context and event name and making sure it's push, right? After building, we need to deploy to Surge, right? So let's create a step. Let's call it deploy to staging. And this will also have to run only on push. So let's copy this if condition, put it here, and run Surge. So we can use npx to install Surge and run it at the same time. What we also could have done is add another step here to install Surge globally. So npm install -g Surge, and then use Surge directly here without npx. But using npx, we can install and use Surge in one line. So let's do that. Alright, so when we used Surge locally, we got this, so let's try it actually. Surge. We got this interactive thing where we can put our projects and then our domain and so on. But of course on CI, on our workflow, we do not want to enter these interactively. We need to provide them to the Surge CLI. So I'm going to close this, and in order to provide the project and the domain, we can use an option called project, and our project will be the build folder inside our current folder. So current folder and then build, and then our domain, and I'm going to paste the domain that we generated when we ran Surge locally. If you forgot it, you can run Surge list on your machine locally, and you will have the list of domains that you generated using Surge. Great, so now when we run Surge, we won't get any interactive terminal. We already provided Surge with the project and the domain that it needs. But now you might wonder, how are we going to authenticate, right? When we run Surge here, we are logged in locally. However, in our virtual machine, we are not logged in. So in order for Surge to authenticate you, you can add a couple of environment variables in your step. First, Surge_login, which will be the username or email of your Surge account, and then Surge token, which is a token that we will generate now. So we won't hard code these here because they are sensitive information. So we'll put them in secrets. So in a moment, we will create a secret called Surge login and a secret called Surge token. Alright, so in order to generate a token using Surge, we can run Surge token, and you'll get a token here. Right? So let's now go and create these secrets. And also, if you forgot your email, your Surge email, you can run Surge who am I, and you'll get your the email that you are logged in with. So I'm going back to my repository and settings and secrets, and let's create. I'm going to copy these keys just in order to avoid any typos. And also copy my email. And same for our token. Alright. And I think this should be in one line. Okay, so let's now try to push. But let's first fix our failing tests in order to be able to merge. So in my app.js, I'm going to add React here so our test can pass. Alright, so I'm going to push to my workflow branch and get back to you. So I pushed to my workflow branch, and since we have a pull request open that needs to merge workflow with develop, our pull request event will trigger again, and now it should pass because we have fixed our test. Great, so our pull request workflow was successful, and as you can see here, we have built projects and deployed to staging, but they did not run because we had a condition to run these only on push events, right? So if you open our pull request now, we will find that our checks are successful, and all we have to do now is just approve the code and then merge. So I cannot approve the code using this account. I will have to go to my other account and refresh. and add my review, approve, and now I can merge. And what will happen when I merge? Our workflow will trigger again, but this time using the push event. So our build and deploy steps should run. So I'm going to merge. And let's go to our workflows and see what will happen. And now our workflow is done and everything went as expected. Our build project ran, and then our deploy to staging ran. And now we have our code deployed to this URL thanks to search. Alright, so what you can do now is you can try to change something in your code. Maybe change some text here or add something, and then open a pull request and then approve the pull request. And then after approving, our code should be deployed. So you can check this link again and make sure your changes will appear here. Right, great. So let's finish up this chart here by adding our caching and also uploading our artifacts. Let's now recap what we've done so far. So far, when we open a pull request, we are running a workflow which will install dependencies, and it will also check for code formatting, and it will run some tests. And we've set up our develop and master branches so that nobody can merge a pull request into them except if these pull requests had their code formatting checked and also their tests are passing. And if a pull request is merged, we do the same thing. We check for code formatting and tests. In addition to that, we also build our project and upload it or deploy it using search, right? And what we have left now in these workflows are caching our dependencies and also uploading our artifacts. So in order to cache dependencies, we use an official GitHub action in the same repository actions, the same repository like the checkout action and also setup node action. And this one is called cache. So let's, in our workflow, use this action. And we need to add it before running npm CI so that we can restore our cache before installing our dependencies. So what does that mean? Let's use the action and we will figure this out. So let's create a new step. Let's call it cache node modules. And in this step, we will use actions and cache. And let's use version 1, which is the current version as I'm recording this lecture. And this action takes some inputs. So with, and what it receives is the path that we would like to cache. So this will be different depending on the operating system and of course the package manager that you are using. So for npm on Linux, the cache is stored in the home and then .npm. This will be different for Windows, and of course it will be different for other package managers. So here in this repository, if you scroll down, you will see multiple implementations for different languages and different package managers. So in our case, we are using Node, but if you are using any different package manager, you will probably find it here, alright? So it also receives a key, and this key will be used to retrieve your cache. So let's say we have a key called my key for now. And when this workflow runs, this action will run and it will search for cache that is saved under my key in our caches. And if that cache is found, it will be retrieved and used in your workflow. And if not, a new cache key will be created so that when you run your workflow again, you can use it. Right? So this key can be static like that, but it can also be dynamic. It can have some expression, some variables or context or stuff like that. And that can be very useful if you want to generate a new cache depending on something. So in our case, when do we want to generate a new cache? It's when our npm dependencies change, right? So how do we know if our npm dependencies has changed? Our npm dependencies are saved in package -log file. So if anything in this file changes, it means that some dependency has changed and we will need to generate a new cache. Right, so how can we generate a new cache if our package -log file has changed? We can hash it using the hash files function, and this function can receive a file path or a pattern. So here we can put the path to our package -log.json. However, if we provide a path, a pattern like so, this will match any package -log.json file in our repository, so that if we have multiple package -log files in our repository, this hash will be unique if any of these files has changed, right? So let's call this key a more descriptive, let's call it node, for example. And in addition to generating a new cache whenever our dependencies change, we also need to generate a new cache if our operating system has changed. So the cache folders can be different for different operating systems. So we need to make sure that the cache is unique to the operating system. So we can also add somewhere here our operating system inside an expression, which is stored inside runner.os. Alright. In addition to that, we can also have restore keys. So what are restore keys? Restore keys are extra keys that GitHub can search for caches at if GitHub did not find any caches using this main key. So for instance, we can have multiple restore keys. So we can do it using a multi-line, using this pipe character. So for example, what if we changed something in our dependencies? So this key will change, right? Because package-log will change. So the first time we run this workflow after changing our dependencies, GitHub will not find any caches saved under this key. However, we might have older caches that are saved under a similar key, however, a little bit different. And the different part will be this hash files function. So we can instruct GitHub to search for older caches that starts with something. And this something in our case can be this part. Right? So by adding this, if GitHub did not find any cache under this key, it will search for older caches that starts with this key, and it could be any other older hash, right? And after your workflow is done, GitHub will add this new cache key and cache your new npm path so that you can use it next time. Right? So I hope that is clear, and I will also put you a link to the cache documentation so that if you need to read more about it, right? But for now, this will serve our purpose, and let's try it by pushing. So I'm going to push to our workflow branch and get back to you. Right, so I'm done pushing. Let's go back to our repository, and to try this, we will have to open a new pull request. So I'm going to open a new pull request, merging our workflow into develop and create. And let's go to our actions tab and wait for our workflow to run. So here we have it. Let's open it, and Now we have this new step, cache node modules, and let's take a look at it. And as you can see, this is the first time we're on our workflow since we added the caching. So it says cache node found for input keys, and this is our key after these expressions are evaluated. So Linux, and then this is our hash for our package-doc. And if you scroll down after the workflow is done, you'll find a post cache node module step, and this will save your cache under this key. So next time we run this workflow, we will then have a cache under this key, and it will be retrieved, and therefore npm CI should run significantly faster. So let's actually try this by going back to our pull request and close it, and then reopen it to trigger our workflow again. So I'm going to close it and reopen it and go back to our actions, and it should be triggered again. And as you can see, here we have we found some cache restored from our key, and its size also is 32 megabytes. So what if we changed something in our dependencies now and ran this workflow again? Of course, we will have a new cache key with a new hash, because package-lock.json will change. However, since we have this restore key, GitHub will be able to find and retrieve this older cache that we already created, and it will restore it, and then it will create a new key using the new package-lock.json so that we can use it next time. Alright, so that's all what we have to do for caching our node modules. I'll put you a link, as I mentioned, to the caching documentation if you would like to know more about caching. But let's now take care of our last thing in these workflows, which is uploading artifacts. So see you in the next lecture. Let's now take care of the final thing that is missing in these workflows, which is uploading artifacts in our workflows. So as you should know now, artifacts are files that are generated by our workflow and that we need to make available for download in this interface here. So similar to caching, this will also be very simple. We will just use a GitHub action that is provided by GitHub, and that will be all. So we need to upload code coverage when we run our tests, and we also need to upload our build folder when we build our project. So let's go back to our code, and after running our tests, which is here, this step, let's create another step, and let's call it upload test coverage. And this will use a GitHub actions in the actions repository, and this one is called upload artifact, and currently it's at version 1, and it takes some inputs, and of course these inputs are the path of the folder that we need to upload. So in our case, we run this step after running our tests, and if our tests run successfully, we are pretty sure that we have a folder in our project folder that is called coverage, right? Which will be similar to this one here that we generated locally. We can also give a file name to the file that will be available for download. So we can call it something like code coverage. And then we need to do the exact same thing with the build folder. So let's copy this step and put it here after we build our project, and let's call it upload build folder, and let's call it build, and the path will be also the build folder here, right? So also when we run build. If build is successful, we are pretty sure that we have a build folder in our folder, right? So that will be it. But before running this, I just want to let you know that we also have an action called in the actions repository, and it's called download artifacts. And it can take, of course, the name of the artifact that you would like to download, and it will be downloaded in your workspace. Alright, so we won't have to use download artifact in our case. However, I just wanted to let you know that it exists. I'm now going to push and get back to you. I'm done pushing, and now in order to test, we will have to create a pull request like we did before. So we actually have one open, so we don't have to create a new one. Our workflow will still run if we have a pull request open. So our job is done, and it failed. This was triggered by the pull request event, right? And we are trying to upload a build folder. However, we don't run npm run build on pull request, right? So we forgot to add the condition. So we only want to upload our build folder if the event name is push, because otherwise we won't actually have a build folder. Right, so sorry for that. However, our upload test coverage succeeded, and we can see here our artifacts. So we have our code coverage that we can download. Alright, so if you now push this fix, the if condition, and approve your pull request, you should, in addition to uploading your code coverage, upload your build folder as well. So I'm not gonna try it, just not to waste your time. It will work exactly the same as the code coverage. So you can try it if you want, and let me know if you have any problems. So that's it for artifacts, and that will also be it for our develop workflows. And now we will need to move on to our other workflows, which are opening a pull request to merge into master. And this is actually very similar, or actually it's the same as opening a pull request to develop. We will just install dependencies, check code formatting, and run our tests, and so on. What is different, however, is merging something to master. We have some different things here. We will create a release, as we discussed. We will also deploy to production instead of staging. And we will use this service CodeCove to upload our coverage reports. So let's take care of this in the next lecture. Let's now take care of the workflows that will run when we open a pull request to merge into master, and also when we actually merge a pull request into master. So as we mentioned, when we open a pull request to merge from develop to master, nothing new will happen. It will be exactly like opening a pull request to develop, which we've already done, right? However, when we merge into master, we have some different things here, which is creating a release and deploying to production, and also uploading code coverage to a service called CodeCove, right? So let's in this lecture see how are we going to create a release. As we mentioned, a release is what you see here. So here is the checkout action, GitHub repository, and we have some releases, and each release has a version and release notes and some assets to download, right? And as we discussed before, we need to automatically generate the version number and also the release notes, and maybe add some stuff to download here. So in this lecture, let's discuss how are we going to do that, and then we will start implementing what we will discuss in the lecture after, right? So the versioning scheme that we are going to use is called semantic versioning. You are probably familiar with this scheme. It's used in almost every npm package or any CLI that you see on GitHub. But let's quickly discuss what this versioning scheme consists of, so that we can know how are we going to generate it automatically in our project. So semantic versioning consists of 3 parts. The first part is the major version. When do we increment the major version? We increment it when we have some breaking changes in our API in our project. So let's say we have some open source library that other people are using. And let's say we updated something in our library that can break the code of the people using our library. What do we do in this case? We increment the major version. So if it's 2, it would be 3, and so on. So in our case, we are not deploying a library that other people are going to use. It's just a React application. It's not some API that other people are going to consume. So semantic versioning might not be applicable in our case. However, remember that this React application is just an example and it's irrelevant. Let's imagine that instead of this React application, we are building some library and we need to implement semantic versioning in our workflow, right? So anyways, the second part in this scheme is the minor version. The minor version is incremented when you have some new features that doesn't cause any breaking changes, right? The third part is the patch version. And this is incremented when you just deployed some bug fixes in your code that of course are not breaking and they are also not considered new features. Alright? So in our project, when we create a new release, how are we going to know which part of our semantic versioning we need to update? We will know from our commit messages. So in our commit messages, when we commit something, we will use a certain convention called conventional commits. And using this convention, we can know whether our commits fixed some bug or added a new feature or had a breaking change. And by following this convention in our commit messages, we are going to be able to know how to update our semantic version, right? So conventional commits are formatted like so. First, we have the type of our commit. So this can be a fix, a feature. We also have other things like docs, if we updated something in our docs, and other stuff as well, which we'll take a look at in a moment. And then we have a scope, which is optional. And this will be the scope of our feature or fix or so on. So let's say we committed a bug fix in the cart page in our project, for example, then the scope can be cart, right? And then of course the description, which can be anything you like. And we can have, like any commit message, we can have our body, which is optional, and also our footer, which is optional. So let's now see some examples of conventional commit messages. So here we have a commit message that is a fix, and it has a scope of cart, and it has some description, and it also has a body and a footer. In the body, we have a breaking change. So if we have this commit message in our commits, then we know that we have a breaking change and we will have to update the major part in our semantic version. So if it's 1 point something, then it will be 2, and so on. Another example can be feat, which stands for feature. And so let's say we have this one, which is a feature without any body or any footer. So we don't have any breaking changes. And since we have a feature, we will update our minor version, the one in the middle. We can also have docs if we updated something in our docs. And this will not affect our version because we haven't actually changed anything in the code. We can also have CI if we committed something related to our workflow. We can also have style if we updated some styles in our code, and so on. I'll put you a link to the full specification for semantic versioning if you would like to read more about it, and also for conventional commits if you would like to see all the possible values for our type, and also what we can have in our body and in our footer, and so on. Alright, so let's see a quick example. Let's say we need to generate a release and we have a couple of commit messages. We have a feature and we also have a fix. and our current version is 2.1.3, and we need to update it based on these two commit messages. So we have a fix, so that would increment the 3, the patch version to 4. However, we also have a feature which will increment the minor version from 1 to 2. So since we don't only have fixes, we also have features, so we will ignore the patch version and we will increment the minor version, so our new version will be 2.2.0. Alright? So great. Let's in the next lecture see how are we going to implement this in our workflow, which will be using a library called semantic release. So let's take a look at this in the next lecture. Here we have a package called semantic release, and this package provides a CLI that we can run on our CI in our workflow, and it can take care of analyzing our commit messages and generating a new release with a version based on our commit messages as we discussed in the last lecture. So let's install and use this library. So here in our installation guide, we have two ways to install it, either locally in our project or globally on our machine. I prefer the local one, so I'm going to copy the npm install line and I'm going to install it in our projects. And while it's done, we can create a configuration file for this library. So I'm going to create a new file in our project, and it has to be called release.config.js. It can be in other formats as well, however I'm going to use the JS format. And we'll have to export an object which will contain our configuration. So let's see what we can have in our configuration by going to this configuration page in the semantic release library. And of course we can have a lot of things, but what we need to specify is our branches. So let's have branches, and this can be an array of branches. You can do a lot of things using semantic release. You can have beta and alpha releases, so you can have multiple branches for multiple types of releases. However, in our case, we are going to keep it simple and only have one release when we push something to master, right? If you'd like to read more about other types of releases, you can check out the documentation. And the other thing that we need is the repository URL, right? So let's copy this, and here I'm going to add my repository URL, which in our case is our React app repository. So I'm going to copy this and put it here. And finally, we need to specify some plugins. So if you scroll down here, we will find an option, plugins. So if we specify an empty array of plugins here, semantic release, when we run semantic release, it will actually do absolutely nothing. Plugins are the things that actually do all the work in semantic release. So by default, we have these plugins. So let's copy these and put them here. So these are the default plugins that come with semantic release. We don't have to install them or anything. But let's take a look at each one of these and what it is supposed to do, right? So we have our commit analyzer. And as the name implies, this plugin will analyze our commit messages and it will decide what our next version will be based on these commit messages. Right? And then we have release notes generator, and this will generate release notes for our release, also based on our commit messages. So remember, for each commit message, we have the type, which is fix or feature and so on. And we also have a description. So what release notes generator will do, it will create release notes based on your commit messages descriptions, right? And then by default, we have this npm plugin. And this can be useful if you are releasing an npm package. However, in our case, we will not have to use it. So I'm going to remove it. And then finally we have our GitHub plugin, and this one will be responsible for creating a GitHub release, the one that you can see in the releases page, like so, right? So why don't we commit these changes? So I'm going to git add all, and I'm going to commit, but this time I'm going to use our new format, conventional commits. So let's say this is a fix, and we can have our description, right? And I'm going to push this. So now how can we use our semantic release library that we installed? We can run npx semantic release, and this will give us an idea on what will happen when we run semantic release on CI. When we run it locally, it won't actually do anything. It will just give you an idea on what will happen when you run this on CI. But it will only actually work when you run it on CI, right? So let's in the next lecture add a step in our workflow to run npx semantic release in our workflow and see what will happen. So now that we have our semantic release library configured, we need to run it on CI. So I'm going to my ci.yml file, and let's say before deploying, we need to create a release. So I'm going to create a new step here. I'm going to call it create a release. And all we'll have to do is run npx and semantic release. So when we run semantic release, it will create a new release in your GitHub because we are using the GitHub plugin here. And in order to be authenticated to do that, we need to provide it with an environment variable that is called GitHub_token. So we can generate a token and provide it. However, we already by default have a token in our secrets. So secrets.GitHub token. And this will be the token that is already generated for us by GitHub Actions. All right. We also need to run this step only when it's a push, not a pull request. And also when it's a push to master and not to any other branch, right? So first we need, in addition to having develop in the pull request and push, we also need to have master, right? So on pull request, we need to do everything we do for develop, also for master. And in push, we also need to do something in master, which will be very similar to develop, except that we will have some differences, right? So these differences including creating a release. So let's add a condition here. Let's actually copy this one. So this is when the event name is push and not pull request, but we also need to check that we are pushing into the master. And this can be found in github.ref. And this will be your full ref path, which is refs, and then heads, and then your branch name, which in our case is master, right? So this way we make sure we only create a release when it's a push to master, right? So now I'm going to add, and I'm going to commit, and let's use a feat commit message this time with some description. And then push. So remember, I'm pushing to the workflow branch, not to master or develop, because they are protected. So in order to test this, we will have to create a pull request and then approve it and then merge it and so on. But instead of doing all that, just for testing, I'm going to go to my settings and branches, and then remove these protection rules just for the sake of testing, so that we can easily push to master to test. But in real life, if you would like to follow this pull request flow, you should not do that, right? So I removed the protection rules from master, so now I will be able to, that's clear. I'm going to check out the master. And I'm going to merge workflow. And I'm going to push. So now I push to master, so this should trigger our workflow. Let's take a look. So my workflow is done. So let's take a look, and everything was successful. We also uploaded our coverage and build artifacts. And then we created a release. So let's take a look at this. And if you scroll down here, you will find that Semantic Release found out that we do not have any previous release. So it decided to create a new release, which is 1.0.0. And then we deployed to staging. We will have to deploy to production when we push the master, but we will take care of this later. So now let's take a look at our releases. And we have one release, and we have our release notes. So remember our commit messages. We had a fix, which had this description in our commit message. And also we had a feat, which had some feature description. So Semantic Release divided our fixes and our features into section and created this release notes. And here we have some assets which are generated automatically. This is your whole repository. However, let's say we need to upload something specific here. Let's say we need to also upload our code coverage and our build folder in our releases. Let's see how to do it in the next lecture. So now that we've used Semantic Release in order to automatically generate a release for our project, let's see how can we upload some assets in our release. And before that, I would like to also mention something that I forgot to mention in the last lecture. If you had pull requests that are included in your release, Semantic Release will add a comment which will say that this PR was included and then the version number. And it will also add a tag released to the pull request, which is pretty cool, right? So anyways, let's go back to our assets. And in our code, in our release.config file, some plugins can be provided with some options, right? And in order to do that, instead of providing our plugin as a string, we can provide it as an array. And as a second item in this array, we can have an object which can have some options. So our GitHub plugin, which is responsible for creating the GitHub release, can receive an option called assets, which can be an array of assets that will be available for downloads here, right? So this array can have objects, and each object can have a path to the file that we need to download. And this needs to be a file, not a folder. So here when we generate our code coverage and our build, they are folders and not files. So we will have to compress them first before uploading them as assets. So we will see how can we do that in our workflow. However, let's assume that we did it and we have a build.zip file in our folder, and we can also give it a label. So let's say build, and let's add another one for coverage, and let's give it a coverage label, right? So now when we run npx semantic release, it will try to find these files in our folder and upload them as assets. But since we currently don't have these files in our folder, semantic release will probably throw an error. So before running semantic release, we need to zip our coverage and our build folders, right? And since we are running our workflow on Ubuntu, we can use a CLI tool called zip. So I'm going to create a new step and call it zip assets, and we also need to run this only when we run semantic release, right? So let's give it the same condition, and we will run a couple of commands. So let's run and use the pipe, and we will zip our build folder, and we will do this recursively, so -r, and the output should be build.zip, and the input will be our build folder in our current directory, right? And then we will do the same for our coverage. So alright, so let's test this by pushing. Since I removed the protection from master, I'm going to push directly into master just for testing, but make sure you don't do that in real life. And in my commit message, let's say this is a fix, right? So this, when we push this, semantic release should bump our version from 1.0.0 to 1.0.1, right? Since we only have a fix. So I'm going to push, and let's go back to our workflows, and let's wait and see what will happen in our CI workflow. It took a while, and now it's done. And if we take a look, here we have our zip assets step, which ran successfully. And then in our create a release, let's take a look. And as we expected, it decided that the next version should be 1.0.1. And also here it published our coverage and our build files. So let's take a look at our releases. And here we have our build and our coverage folders or files, right? So let's go back to our workflow, and let's fix this part. We are now deploying to staging, even though we are pushing to master. When we push to master, we should deploy to production. So let's fix it in the next lecture. Let's now, instead of deploying to staging when we push to master, let's deploy to production. Right, so let's go back to our code, and here where we have our deployment step, let's add a condition here to only run deploy to staging when we push to develop, right? So github.ref, and then if that's refs/heads/develop. So only when we are pushing to develop, we need to deploy to this surge URL, otherwise we need to deploy to another URL. So in your local machine, generate another surge URL, the same way we did before by running surge locally and generating a new URL. And let's assume this URL that you generated will be used for production. So all we have to do now is just duplicate this step. And instead of staging, let's deploy to production. And in this condition here, we will only run it on pushing to master, right? So I generated a new surge URL, and I'm going to paste it here instead of this one. And this will be it. But as you can see here, we have some duplication, which is okay. However, we can improve it maybe by making these environment variables in the job scope and not in the step scope, right? So let's remove this from here and also from here. And let's make these environment variables available in our whole job. So we can add it here. And this way we defined these variables once, and they will be accessible in any step. So both of these steps will have access to our search tokens, right? So that would be it. But before testing this, why don't we finish our last thing we need to do in our master workflow, which is uploading our code coverage reports to CodeCov. So let's in the next lecture do that and test both of these features together, right? So see you in the next lecture. So as we mentioned before, CodeCov is a feature where you can upload your test coverage reports so that you can have all your coverage reports uploaded in one place, and you can also get some other features like grouping, merging, archiving, comparing, and so on. You can read more about it here. However, for now, let's say we need to integrate this in our workflow. So I'm going to create an account. I already have an account created using GitHub. And in your account settings, from here, make sure you link your CodeCov account to your GitHub account, right? So I've already done that, and I'm going to go to codecov.io and then /gh and then / my username and then / our repository name, which is React app. And when you visit this, you should have a token that will authorize you to upload to CodeCov. And when we need to upload to CodeCov in our CI, we need to have an environment variable called CodeCov token. So let's go to our repository and let's add a new secret here. And copy our token and add secret. And now let's run CodeCov in our steps. So here after deployment, let's add a new step and let's say upload coverage reports. And as we agreed, let's also run this only when we push to master. So let's copy this condition, the same one as deploying to production, and put it here. And all we'll have to do is run CodeCov, which is an npm package. So we can install it globally and run it, or we can use npx and run CodeCov. And of course, we will have to have our environment variable, which was called CodeCov token, and we stored it in our secrets. So secrets CodeCov token. All right. So I don't know how this happened, but this should be CodeCov and not code coverage, right? All right. So this should work. Let's now push and test both our deployment and our CodeCov integration. So I'm going to add and push to master and get back to you. I'm done pushing now, so if we go back to our repository and our actions, our workflow should run. So let's wait for it to finish and see what will happen. And it took a while, and now it's done. And let's take a look here. So now deploying to staging did not run. Deploying to production ran, and it was successful. And also upload code coverage reports ran successfully, and let's take a look. And looks like CodeCov ran successfully. So now if we go back to our dashboard and refresh, we should see something here. All right. So that was how to integrate CodeCov in your workflow. Let's in the next lecture do something that is not really necessary. However, I think it's nice to have. So remember, we are now using semantic release, and we have to have our commit messages formatted in a certain way, right? But currently when we commit something, there is currently nothing stopping us from writing a normal commit message without the conventional commit format. So what we're going to do in the next lecture is we are going to install some packages that will help us enforce this commit messages format so that everybody can commit using the same format. So this is not necessary for our workflow. However, if you would like to know how this can be done, make sure you take a look at the next lecture. So in order to check if our commit messages follows conventional commits convention or not, we can use a package called commit-lint, right? So here I have this package open and I'm going to scroll down to see how can we use it. Here, so this package uses Husky, and if you don't know what Husky is another package that can allow us to use Git hooks to run something before we commit or before we push or before we do anything that is related to Git. So here it uses a Husky hook, which is called commit message, and this will run before creating a commit. So before creating a commit, we need to run commit-lint to make sure that our commit message does not violate conventional commit formatting, right? So let's install this package and also install Husky. So I'm going to copy this. So we'll have to install commit-lint CLI and also commit-lint config conventional. And this is a configuration for conventional commits. So back here, I'm going to paste, and I'm going to also add Husky in the things that we are going to install. Right, so while this finishes, let's go to our package.json and let's add our Husky hook. So I'm going to copy this or this and put it here. And by having this, this command will run before we create our commit, and it will check that it was formatted properly, right? Right, so now that we have our packages installed, all we have to do now is create a configuration file for commit-lint, which can be created using this command. So let's copy this, and I'm going to clear and run this command, and when we run this command, we should find a new file called commit-lint.config.js, which uses the config conventional package that we installed, alright? And now if we try to add all and commit and use a commit message that is not formatted properly according to conventional commits, we should get an error, right? We can also use another library that can help us create our commit message. So here I have a library called commitizen, and let's quickly go through it and install it. And what will it do is when we type git commit, we will get an interactive thing where we can choose whether our commit is a feature or a fix and so on, and whether we have any breaking changes. And this package will create our commit message according to our answers. Alright, so I'm going to go to this section, making your repo commitizen friendly, and I'm going to install commitizen globally. So let's do it. And then we will have to initialize commitizen in our repository by running this line. And of course you should run this after installing commitizen globally. So mine is done, so I'm going to run this line. And this will install some dependencies, and it will also add something to your package.json. So now you should have this config key in your package.json, which has some stuff related to commitizen, right? And finally, we can run another Husky hook in order to run commitizen when we commit. So let's go down here and to the Husky section, and let's copy this hook and add it to our hooks. Right? So now let's try to add and commit again. And I'm going to commit without any message because we will not have to type a message. Commitizen will help us create our message. So as you can see, we can choose, let's say fix. We can choose our scope. We can choose our description. We can have a longer description that will be in our body. We can mention if we have any breaking changes or not. We can also mention if our commit will affect any open issues. And this will be our message and our body, and we can escape or quit this editor by typing escape:q. And our commit message will be created and we can push it. Alright? So that was it for this lecture. Let's now carry on and complete our workflow. Let's finally finalize our workflow and do the last thing that we planned to do. So as we mentioned, we need when our job fails, we need to create a GitHub issue. And also we need to send a Slack message when a release is created and also when an issue is created. So let's actually start by the last one, which is sending a Slack message when a release is created. Alright. So when we create a new release in GitHub, an event called release will be triggered. So what we can do is we can, in our code, create a new workflow, and this workflow will run on release. So in my workflows folder, I'm going to create a new file. I'm going to call it release.yml. And I'm going to give it a name. So let's say notify on release, and this will run when we create a release. So we have an event called release, and a release can be created or deleted or published and so on. So let's say we need to run this workflow when our release is published. So in types, we can add published, and then we can create a job. So let's add a jobs key, and let's call our job Slack message, and let's run it on Ubuntu. And let's add some steps. It will actually be just one step. So we've actually seen how to send a Slack message in a previous lecture using Docker. But if you haven't seen this lecture, let's quickly see what we'll have to do in order to send a Slack message. So here I'm logged in to my Slack account, and I've done some testing already, so you can see some messages here. But while you are logged in to Slack, go to api.slack.com/apps and create a new app, and let's call it my Slack bot, and choose a workspace and create. And then here you can add features. So add incoming webhooks, which will allow you to post messages from external sources into Slack, which is exactly what we need, right? So turn it on, and we now can create a new webhook. And this webhook is a secret URL that will allow you to send a request to post a message to Slack. So let's say we need to post to general and allow. And now we can send a post request to this webhook, and in the body we can send our message, right? So as I mentioned, we've seen before how to send a Slack message using a Docker image. However, it's actually very simple. We can just run this curl command in our workflow directly. So let's copy this, and here let's create a new step and give it a name, and then let's run our curl command. But in order for this to work properly, we should format it using the pipe character. Alright. We've also mentioned before that this webhook is a secret and it shouldn't be hard-coded like that. So let's copy this and put it as a secret in our repository. Secrets, and then let's call it Slack webhook and paste. And I'm going to copy this secret name and just put it here using an expression, and then secrets.slack webhook, right? And let's say we also need to customize this message. We need it to be, I've actually tried it before, so let's take a look here. We need it to be new release, and then the release number is out, and then a link that will take you to the release page, alright? So here in our releases, when we create a release, it generates a new tag, which is the version number. So we need to get this in our workflow and put it in our message. And also we need to add a URL that will take us to the release page, right? So let's remove this message and say new release. So how can we get our tag? It would be stored in the GitHub context. So let's add an expression, and then inside the GitHub context and inside our event. And since this workflow will only run on release, so we are pretty sure that we will have a release event in our event. And inside of this release event, we will have tag underscore name, which will be our version number, alright? And then after this expression is out, and then comma, and then we need to add a URL. So how to add a URL in a Slack message? We use this angle bracket. I'm going to scroll, and then a closing angle bracket, and then inside of it, so we can have our URL, and then pipe, and then our text. So our text should be as we mentioned here. Check it out now. So let's type it. Check it out now. And the URL, which is before the pipe, is also stored in the GitHub context. So let's add an expression, github.event.release, and then inside of the release we have HTML URL. All right, this will be the URL to this specific release. So that should be it. So what we can do now in order to test it, we can push to master. And when we push to master, let's open our old workflow. When we push to master, create release will run, and it should create a release using the npx semantic release command, right? However, if you try this, it will not work. If we take a look at our releases here, as you can see, the user that creates the releases is called GitHub Actions. And this is because here we are using the GitHub token that GitHub Actions provides as a token for semantic release. So when you use this token, the user that will appear here is GitHub Actions, which is an application. And when you use this token that is generated by GitHub in order to do something on GitHub, which in our case is creating a release, when you create this release in your workflow, it will not trigger the release event, and therefore this release workflow will not run. Alright, so you cannot trigger a workflow from inside another workflow using this token that GitHub generates. So in order to work around this, what we can do is we can go to our settings and create a new token from our account. So you can go to this page from your profile, and then settings, and then developer settings, and then personal access tokens. So let's generate a new token, and let's type a note here, semantic release workflow, and choose the repo scope, right? And then generate, and then copy this token, which of course should be a secret, and then go to your repository settings and add a new secret. And let's call it custom token. And let's paste it, and now we can use this token when we create a release instead of this default token that GitHub generates. Alright, so let's try and push to master, and what should happen is we will create a release as normal, but now our my account will be the user that created this release, since we are using a token generated from my account. And when this release is created, our release workflow will run as expected, and we should get a Slack message. So I'm going to push and get back to you. So I'm done pushing. Now we should go to our actions, and our CI should run and it should create a release. So let's wait for it to finish and get back. So as you can hear, after a create release step was done, I got a Slack message from my Slack bot application that we created, and we have our message as expected. And if you click on this link, it should take us to the release page. And as you can see now, my user is the one who created this release and not GitHub Actions. So if you don't want this to happen, if it doesn't make sense to have your user here to be the one who created the release, when in fact the release was created automatically, maybe you can create a dedicated account, GitHub account. You can call it bot or something, and generate a token from this account and use it in your semantic release step, so that you can know that this release was created by a bot and not by an actual user. Alright, so that's it for sending a Slack message on release. Let's now create an issue when our job fails, and also when our issue is created, send a Slack message. This will be very similar to the one that we just created. So see you in the next lecture. Let's now create an automated issue whenever our job fails. So in my workflow, I'm going to add a new step. This will be in my CI workflow. So how can we run a step when our job fails? We can add a step at the very end of our job. Let's give it a name, open issue. And here, if we add a condition, if failure, as we've seen before in a previous lecture, this step will only run if any of the previous steps failed, right? And that's exactly what we need to do. We can also add other conditions as well. So let's say we need to run it only on push. So let's say just on push, right? So how can we open an issue? We've actually seen this before in a previous lecture. What we can do is we can send a curl, we can run a curl command to send a post request to the GitHub API to open an issue, right? So I'm going to paste it because we've done it before actually, and it's very long. Here it is. So we're sending a post request to this endpoint issues, which will open a new issue. And we're also adding authorization using a bearer token, and we are providing the GitHub token in our secrets, right? And then in our data, we are having a title for our issue and also a body. And what we can also have is assignees, which is an array of people you would like to assign to this issue. So let's say we'd like to assign the person who opened a pull request and caused the workflow to fail, right? And I actually made a mistake here. Let's assume we need to run this on pull request and not push. So if someone opened a pull request, of course, this will cause our workflow to run. And if this workflow fails, what we will have to do is open an issue and assign this person to this issue, right? So in the assignees array, we can get the user who opened the pull request using an expression, and the username will live inside github.event.pullRequest.user.login. This will be the username of the user who opened the pull request, right? So you can copy this from the repository I will provide you if you are following along. But let's now try this. I'm going to do something that will break our tests, which is removing React from here, right? And then I'm going to add and commit. So let's say this is a fix and stop some random stuff here. And then I'm going to push. So now we are pushing to master. And now we need to test this new thing that we've done in our workflow. So this will only run on pull request. So I'm going to check out back to our workflow branch, remember? And I'm going to merge master. And then let's push. And after pushing, I realized we have a typo here. So failure, I mistyped failure, right? So sorry for that, and I'm going to commit and push again and get back to you. Alright, so I'm done pushing, and in order to test, we now can open a pull request to merge from workflow into develop. But since I already have a pull request open, my workflow will run. If you don't have, just create a new pull request. So in my actions, I should now have a new run on pull request. So let's open it and let's wait for it to run. Alright, so my run is done, and as expected, our npm test failed. However, since we have this new step open issue, which will run on failure, this step ran and it created an issue. So let's take a look here in our issues. We have a new issue that is assigned to me, since it was me who opened this pull request, right? And as you can see here also, we have this user GitHub actions is the user that created this issue. And the reason is we have used our GitHub token, the one that is automatically generated by GitHub when we were authorizing our API request, right? So this can be fine, except if you are going to run a workflow when an issue is created. And this is actually what we'll do now. So as we mentioned, similar to the release, we need to send a Slack message when an issue is created. So this would be very similar. So let's copy this. Let's create a new file in our workflows. Let's call it issue.yml. And let's paste, and what we'll have to change the name, maybe notify an issue. And also our Slack message, right? So I'm going to remove everything except for the link. And let's say new issue created and a link to the issue. So instead of the link to the release, let's change check it out now to the title of the issue, which will be in our GitHub context and event. But now it's issue, the issue event, since we are running this on issue. Oh, we actually forgot to run it on issue. So let's do it in a moment, but for now the title will be in issue.title, and the URL for the issue will be similar to the release, except that it will be event.issue instead of event.release. So here we need to run this on issue, and when an issue is opened, or actually it's called issues, right? So now if you need to trigger this workflow when an automated issue is created in your other workflow, you will also have to use your custom token here. So what did we call it? We called it custom token. Let's copy it from here and use it instead of the GitHub token when we create an issue, right? So I pushed our new stuff to master, and then I opened a pull request to merge workflow into develop as usual to test, and my issue was created, and now it's under my username as we expected, since we are using my token. And this triggered the other workflow, which sends a Slack message on issue. So let's take a look at our actions. So notifying issue ran successfully, and it sent a Slack message. Here, new issue is created, and then the title of the issue and a link to the issue, right? So one of the reasons I included this in our workflow is to prepare for our next section. In the next section, we will learn how to create our own GitHub actions. So as you can see here, when we wanted to open an issue, we wrote a lot of codes that looks very ugly, and you can easily mistype something here. And also in our Slack messages, it's kind of long and we've used it a couple of times. So it will definitely be more efficient if we converted these curl commands into GitHub Actions, which will take some inputs. And these inputs, in case of Slack, for example, will be the message. And in case of an issue, it will be the title and the body. And by having these as GitHub Actions, we can, instead of typing all of this, we can just have one line uses and then an action and then give it some inputs, as we've seen before when we used GitHub Actions. So this is what we will be doing in the next section. However, let's just have one quick final lecture in this section. Let's finally do one final thing in this section. So you probably have seen this before, these badges that you can find in popular libraries. These badges simply display the status of some workflows in your repository. So normally when you are running some tests or something like that in a workflow, normally you would display if your tests are passing using a badge like this. So let's quickly see how can we add a badge like this in our repository, right? So here in our README, we actually have some stuff that was added by Create React App. So let's go to our code and add something to this README file, right? So at the very top, I'm going to add this line, which will simply add an image, an SVG image, which will display a badge like this. So the URL for the image is github.com and then your username, your repository name, and then workflows, and then the name of the workflow that you would like to display its status. So in my case, I'm displaying the status of our CI workflow, right? And then /badge.svg, and then you can also filter by branch and by event. So here I'm, for example, filtering by branch, develop, and event, push. So the status shouldn't change when someone opens a pull request and fails, for example. This will only be the status for push. So I'm going to push this to master. And let's see how this will appear in our repository. So I'm done pushing, and let's go back now here and refresh. And here we have our badge, which has our the name of our workflow, CI, and the status of the latest run, which is passing. You can maybe try to make it fail, and this should change, alright? So that's it for this section. Let's learn how to create our own GitHub Actions in the next section. In the previous section, we needed to perform a couple of tasks, which were sending a Slack message and also opening a GitHub issue. And to do these tasks, we sent a post request using the curl command. And as we've seen, this can be very long. So in case of opening an issue, it's very long. And it's kind of not very practical and also not very reusable. And then we mentioned that using GitHub Actions, we can convert these post requests into actions, which will make these tasks reusable, and also we will have to write a lot less code in our workflow. So let's in this section learn how to create GitHub Actions, and then we will create a couple of actions for our sending a Slack message and also opening a GitHub issue. So actions, as you should know now, can perform a certain task. And this task can be contacting some third-party API, maybe sending a Slack message, as we will do, sending an SMS, maybe doing something with the GitHub API, like opening an issue, which we will also do. And we can also have actions that deploy code to some server and stuff like that. So here I have the folder that we created in the first section. Remember when we were trying the checkout action for the first time? So here we've used the checkout action, which is a public action. A public action means that the action lives in a public repository, and we can reference it using the GitHub username and then the repository name. We also have private actions, and private actions do not live in a separate repository. However, you can write them somewhere in your project in a folder and then reference your action by having the path to your folder here. And in this section, we will see both kinds of actions. And in the first section, we also have used this action, which lives in the actions GitHub username, and it was called Hello World, a JavaScript action. And if you remember, we mentioned that we can write actions using JavaScript, and we can also write them in another way, which we'll take a look at in a moment. So this was a JavaScript action, and all it does is that it takes an input, who to greet, and then it logs hello and then the who to greet input. So in this case, hello John, right? And then it also generates an output, which we can reference using steps dot the step ID, which is greet, and then outputs, and then the name of the output. And the output in this case was the time this string was logged, right? So JavaScript actions are fast. They run directly on your virtual machine. However, you can only, of course, write them using JavaScript. If you would like to use any other language, you will have to use the second option, which you can write actions with, which is using Docker containers. So in addition to JavaScript actions, we can also have Docker actions. They only run on Linux, so we have to use Ubuntu here when we use Docker actions. However, they are more consistent because using Docker containers, we can have a consistent operating system, dependencies, tools, and so on. However, of course, they are a bit slower because there is the overhead of pulling the Docker images and so on. And in this section, we will also create a JavaScript action and also create a Docker action. Let's finally mention one final thing in this lecture that we've seen before actually, but just a reminder. Actions can be referenced using a branch name. So here we can have master, and we've mentioned in the first section that this way is not preferred because if a breaking change was introduced to master, it might break your workflow. So the other option is by referencing a specific commit. So imagine this is a commit ID. So this way we are pretty sure that the code for the action will not change because we are referencing a specific commit. And the final way, which is the preferred way, is by referencing a tag, which is a version. So when you publish a GitHub action, it's actually required that you have a certain version. And you'll actually see when we publish GitHub actions that it's a requirement. And by having that, you can allow people who are using your action to reference certain versions of your action so that it won't break your code if you have some breaking updates. So if the author of this action decided to add some breaking changes, he should change the version from version 1 to version 2 so that your code won't break while you are still using version 1. Alright? Great, so let's now start creating our own GitHub actions, and let's start by actually recreating this JavaScript action. So we will create an action that has one input, who to greet, and we will just simply log hello and then our input. And we'll also have our time output. So let's start doing that in the next lecture. So here I'm back to my React app project that we've been working on. And inside of this project, we are going to create our first action. And our first action will be, as we mentioned in the last lecture, just logging a simple greeting, and it will be a JavaScript action, and it will also be a private action. So as we mentioned, private actions are actions that do not have their own repository, however, they live inside your project. So in my .github folder, I'm going to create a new folder called actions. And inside of this actions folder, I'm going to create another folder called, let's call it hello, and this will be our action, right? Inside of our action folder, we should have a file called action.yml. And in this file, we will have to define some stuff in our action. So we should have a name. Let's call it hello world. We can also have an author. We can have a description. And then we can have our inputs and outputs. So let's start with inputs. And this should be an object where you have your input names. So let's call our input who to greet. And this is also an object where it has some description. And you can also mark it as required. And it can also have a default value. So let's give it a default value, right? And then we can have our outputs. So as we mentioned, we will have one output, which is time. And outputs can also have some description, right? And finally, we should have a key called runs. And this will specify whether our action is a Docker action or a JavaScript action. So as we agreed, our action will be a JavaScript action. So we can add using and then node 12. And we should also have a main. And this will be the path to the main file that we will run when this action runs. So in a moment, we will create a file called index.js. Right? So let's in hello, let's create index.js. And this will be the file that will run when our action runs, because we specified it here in our main. And now in index.js, all we have to do is just log our greeting. So to log something in JavaScript, we use console.log. So, and then hello, and then we need to somehow get the input that the user will provide, right? So how do we get this input? GitHub provides some npm packages that we can use that will help us do some stuff in our JavaScript workflows, or JavaScript actions, sorry. So inside of this toolkit repository in the actions username, we have a list of packages that we can use. We have our core, and this will help us get our inputs and set our outputs and other stuff as well that we will see. And we have other packages that you can take a look at. However, what we will use is the core, of course, and the GitHub package. So I'm going to install these two packages here in our project. So the GitHub and also the core, right? And now that we have these two packages installed, we can use them. So as you might know, if you are familiar with JavaScript, to import packages from node modules, we can use require and then the name of our package. So actions core, and another one for actions GitHub. And now we can use our core package to get our input. So let's define a new constant. Let's call it name and then core.get input to get an input, and then the name of the input, which we called who to greet, right? And now we can simply log our name here. And now we need to set our output. So in addition to get input, we have a function called set output. So let's get our current time, which in JavaScript you can get by calling new date. And then we can call core.setOutput. And our output was called time. And then the second argument is the time. But it has to be a string, and time in this case would be an object. So to convert it to a string, we can call a function called toTimeString. Right? So this is actually it. We are logging our inputs and we are setting our output. And in this action, we won't have to use our GitHub package. However, I just wanted to show you what you can find inside of it. So let's log its contents, and it will be a JSON. So in order to log it in a formatted way, we can use json.stringify and then our GitHub object, and then as a third argument, we can pass a tab so that our JSON will be indented using a tab, right? And finally, we will have to take in consideration that we might have some error that could be thrown by any of the code that we typed here. So let's simulate an error. Let's say in some of our codes, an error was thrown. So let's throw a new error with some error message. And what will happen now is our code will stop here because an error was thrown, and nothing will be logged and no output will be set, and so on. However, when we view our workflow on GitHub, it will appear as if it was successful. And this is because we have to explicitly mention in our code that our action has failed. And to do that, we can call a function in core called setFailed. And it can take an error message. And when we call this function, our action will fail, and therefore our workflow will fail as well. But if we did not call this function, GitHub will not know that our action has failed. And therefore, even if any error occurred in our code, our workflow will not fail because our action will not fail, right? So how can we tell if we had an error in our code? We can wrap it in a try catch block. So try this and then catch, and we will have an error object. And if we have an error, we should call this function. And we can pass it our message, which will live in error.message. So let's remove this for now. But when we run our workflow, we will need to test the error, so we will get it back. But for now, let's comment it out, and our action should now be done. And in order to test it, let's create a workflow just to test this action. So instead of running all of that, I'm going to prevent this from running by just changing these branches here. And I'm going to create a workflow, a new workflow in our workflows. Let's call it actions.yml. And let's run it on push. And it will just have one job. Let's call it testing action. And let's run it on Ubuntu. And let's have a step that will use our action that we just created. So how to use it? As we mentioned, we can reference the action folder in our project folder. So inside of .github, and then actions, and then hello. However, as you can see, we need to have access to our folders, right? Because we will need to run an action in our folder. So we will first need to check out. So that's before running our action. Let's use actions and check out. And here, of course, we will have to pass our who to greet input. And let's also give it an ID in order to reference this step in the next step. So in the next step, we will have to log our output. So we can run, and then we can echo our time. So time, and then inside of an expression, we can reference the previous step in steps dot hello, which is our ID, and then dot outputs out time. Right. So now we are ready to push our code, and when we push, this workflow should run, and our hello action should run, which should run this index.js file. And in this file, we log our input and then we set our output. And here we are testing to see if our output was set correctly. However, when we run this index.js file in our virtual machine, it will need to require the actions core and the actions GitHub packages, right? But remember that usually in our JavaScript projects, our node modules folder is put in our git ignore, right? So when this file runs on our virtual machine, it will try to find the actions core and actions GitHub in the node modules folder, but they will not be found because we did not push our node modules folder. So in order to work around this, we can push our node modules folder, which I don't think is a good idea. So let's take a look at another solution in the next lecture. In the last lecture, we mentioned that when our action runs on our virtual machine, our code requires some packages from the node modules folder. And as we know, we do not push our node modules folder in our repository, so this can cause a problem. So one solution is to push our node modules folder, which is not ideal. And the other solution is to actually compile our file so that we can include our packages and our code in one file instead of requiring it. So to do this, we can use this package, ncc, which can help us compile a Node.js project into a single file, which is exactly what we need. So I'm going to install this library in our project. So npm install and -d because it's a dev dependency, and then our package name. And after it's done, we can use it. So we can run in our project npx ncc and then give it a path to the file that we would like to compile. So in our case, it's .github actions and hello and then index. And we can also specify where we would like to put it. So by using -o, we can specify path. So let's say GitHub and actions hello, and let's put it in a folder called dist, right? And let's run this. And I'm sorry, I forgot something. After ncc, we should have build, right? And now, after running this, we should have a dist folder in our hello folder. And as you can see, this folder contains our libraries that we include here in addition to our code in one single file. And this way we can run this file instead of this file, and we will not have a problem. But notice now that in our actions.yml, we need to run dist index.js and not index.js, right? Great, so now we can push our code and test our action, and let's see what will happen. So I'm going to commit and push and get back to you. I'm done pushing, so if we go back to our actions tab in our repository, we should find our new workflow running. So let's wait and see what will happen. So it looks like our action ran successfully. We have our hello world string as expected. And remember, we also logged this GitHub package that we imported. And as you can see, it has some information about our workflow, some context. So we have our commits, we have our pusher, our ref, our repository, some information that you might need to use in your action. We have our SHA, we have our event name, our workflow, and so on. This package also has something that is very useful that we will use in our next action. But for now, let's take a look at our output, and it looks like it did not work. So here we are setting our output to the time of when we logged this string. However, it did not work because I just noticed I have a typo here. So hello.outputs. So sorry for that, I'm just going to push it and confirm that it's working and get back to you. So I fixed my typo and pushed again, and as you can see, our time is now working and we are getting our string and our time as expected. Let's finally test one final thing in this lecture. So remember, we are calling set failed if we have an error in our code in the try block. So let's say we have an error, so let's simulate that by throwing an error, just to confirm that our action will fail and our workflow will fail, and we will get our error message. So just make sure before pushing this, make sure you recompile your files by running ncc build and the input and output paths again, right? So I'm going to run this and I'm going to add and commit and push and get back to you. I'm done pushing, and now in our workflow, we should expect our workflow to fail, right? So let's wait and see what will happen. And it failed as expected. And by the way, you get some annotations here where you can find your errors and warnings. So we have some error message, which is the error that we threw here. And of course, it will appear also in our logs, right? Great, so before moving on and creating a more useful action, this core package also have some other features that we can use in our JavaScript actions. So let's in the next lecture take a quick look on these features, and then we can create a more useful action. So see you in the next lecture. So until now we've used our core package in order to to get inputs and also set outputs. And we've also set our failed status for our action, right? But actually the core package can do some other stuff as well. So I'm going to remove this error and let's take a look at some of the other stuff that the core package can do. Remember in the first section when we talked about enabling debugging mode in your logging? So we had this secret that we can set to true. And if that's set to true, in our logs, we will have a lot of more information about what's going on, right? So let's go back to our settings and secrets and let's set it to true. And now if we run our workflow again, we should have in our logs some more information about what's going on in our actions and in our steps and so on. But now let's say as action authors, we need to provide these logs to people who are using our action. So if somebody using our action is enabling the debug mode, we need to provide some debugging information for them. We can do that in JavaScript actions using the core package. And then we have a function called debug, where we can provide some debug message. So unlike console.log statements, this debug message will only appear if debugging is enabled. We can also have a warning message, which will be in yellow in the logs. And we can also have an error message, which will be in red. So this will just log a message in red. It will not make your action fail, unlike the set failed. Alright. And before testing these, let's also take a look at some other stuff so that we can test everything at once. We can also set secrets. So if you call a function called set secret and have some string here, what will happen is whenever we log the string that we passed here, it will be masked. It will be logged as something like that, and it will not appear in the logs. So here, for instance, we are logging our name. So let's say this name is a secret and we do not want it to appear in our logs. So we can set it as a secret and it should not appear, as we will see. We can also have some logs that can be expanded in our logs here. So as you can see here, we can expand and minimize some logs. We can also achieve that using the core package. So here, for example, we are logging our GitHub object, which is very long. So let's say we need to make it expandable. And what we can do is we can call start group, and we can give it a title. So let's say logging GitHub object. And then of course we will have to end the group. So we can call end group without any arguments. And finally, we can also set environment variables that we can use in any subsequent steps. So by calling export variable, we can set a variable. Let's say it's called hello. Let's set it to hello. And in our workflow, we can use this environment variable in any other step. So let's try here and echo hello in this step, which runs after running our action, and we should see our environment variable. Alright, so let's push and test these, and I'll put you a link to the core package where you can read more about other stuff that it can do as well. So I'm going to push and get back to you. So I'm really sorry, I actually forgot to recompile the code before pushing, so this is an easy step to forget. So if you are following along with me, don't forget to run ncc again to recompile your code before pushing. So I'm going to push again and get back to you. And after pushing again, the workflow was successful. And here in this annotations section, you will get the warning message and the error message that we logged here using the bug and using warning and error. And also inside of our job, we can open our action, and as you can see, we now have these debug messages because we enabled debugging, including our own debug messages and warning and errors. And then we had a secret here. So as you can see now, it's not logging the name because it's a secret. And then we added our group. So let's take a look at this. As you can see, we now have some logs that can be expanded. And finally, we exported our hello environment variable, and we are logging it in the next step. So let's take a look at this. And here we have it. All right. So that's it for the core package. Make sure to check the documentation. I'll put you a link if you need to read more about it. But let's in the next lecture move on and create a more useful action, and this action will open a new issue on GitHub. Let's now create an action that will open a GitHub issue. So remember in our workflow, when we needed to open an issue, we called this post request and passed some parameters here. So let's take a look at this again, just in order to see what inputs will we need in our action. So here we needed a token for authentication. So this is our first input. We also needed a title for the issue, a body, and assignees. So these would be our 4 inputs for our action. So let's now go and create this new action, which will also be a private action. So inside of our actions folder in .github, let's create a new folder called issue. And here we will put the code for our new action. So as we learned, we should have an action.yml file, and here is where we are going to define our inputs and outputs. And sorry, it's called action and not actions, right? So in order to save you some time, I'm going to paste the inputs and outputs and go through them. And if you are following along, you can copy them from the repository that I will provide you. So here we just have a name and author, description, and then we have our inputs, a token, which will be required, of course, our title. An issue must have a title, so it's also required. The body and assignees, however, are not required, right? And then we will have one output, which will be the issue object. So when we call the GitHub API to create an issue, it will return an issue object as a response. So we will set this as an output so that it can be used in any subsequent steps, right? And of course, it will be a JavaScript action, so node 12, and we are also going to compile it in this index.js. Great, so let's create our index.js in our issue action. So new file, index.js, and let's get our core and also our GitHub packages. And then let's add a try catch block. So try catch, and then if we have any errors, we need to call set failed and then pass it our error message. Right, and then here inside of the try, we can write our action. Great, so let's first get our inputs. So let's get our token, core.getInput, and then our input name, which we called token in our action.yml file. And then I'm going to duplicate this for our other three inputs, which are title. So get title, and then also our body and our assignees. So now we need to send this API request to create an issue. So what we can do is we can use fetch, the JavaScript function that can send an AJAX request. However, there is an easier way to do it. What we did not mention in the last lecture, that in addition to the context that this GitHub package has, it also have a GitHub API JavaScript client. And this client is called OctoKit. You may have used it before, but here is the documentation for it. And what it will do, it will send API requests, but it will just make it easier in your JavaScript code. So here in our documentation, let's go to the issues part, and let's see how to create an issue. So let's go to create an issue, and we will need to call octokit.issues to create and pass it these stuff. So how do we get our OctoKit instance? As I mentioned, the OctoKit client lives in the GitHub package. So let's initialize a new instance of the OctoKit client. So new, and then in GitHub, it's called GitHub with a capital G and H. And then we will have to pass a token in order to authenticate our requests. So we will pass it the token that we will get from our inputs. And it's actually called octo with a C. And then we can just call this function. So let's copy this. And also let's save our response in a constant. So these are required, the owner and the repository. So of course we cannot hard code these like so, because this action will be used by different users in different repositories. So these cannot be hard coded. We have to get them from our GitHub context. So the owner and the repository will live inside of GitHub context.repo.owner, and the repo name will also be the same, but instead of owner, it will be repo.repo. And if you're familiar with JavaScript ES6 syntax, we can just spread our GitHub context.repo object like so, and this will be equivalent to this, right? And then we can pass it our title and body and description from our inputs. But also, if you are familiar with JavaScript ES6, if our key name is the same as the variable name, we can just pass it as title. And so similarly, we can pass our body and our assignees. However, for our assignees, this is expected to be an array of GitHub users. However, in our inputs, we cannot pass an array. We can only pass a string. Right, so let's say in our actions workflow, where we test our actions, let's say we need to test our new action. So let's add a new step here, and let's copy this, and instead of using our hello, let's use our issue. And this takes some inputs. So our token, let's pass our GitHub token. So secrets GitHub token, and let's have some title, some body, and some assignees. So assignees, and here you might think you can just pass an array of GitHub users like so. However, inputs only accepts strings, and this is a problem. Here when we call our API, this should be an array and not a string. So what we can do is we can, instead of passing it here as an array, we can pass it maybe as a comma separated string with our users, and then here we can check if we have assignees, and if we do, we can split on our comma, and so this will create an array of our users from our string, from our comma separated string. And otherwise, we can just pass it undefined to ignore it. Another solution is to pass it as a formatted string using the pipe, and then in each line we can pass a new user. So this maybe looks much cleaner. So but now we will have, instead of splitting the comma, we will have to split the new line. This will be an array of users, right? Great, so let's finally, we need to set our output, right? So set output, and remember we called our output issue, and this will be the issue that we will get in our response. So our response, which we will get from the OctoKit, it will contain some information about the status code and stuff like that. However, the issue itself will live in response.data. But also, when we set an output, it must be a string. It cannot be an object. So we can pass this as a string by stringifying our JSON, like so. Alright. So I think we are ready to test it. However, let's just also test our output by giving an ID to our step. Let's call it issue. And then in the next step, let's log our output to make sure it's working properly. So let's run. And let's echo our steps dot issue dot outputs, and then our output is called issue, right? Great, so I think this should work fine. We finally, don't forget this, we have to compile our code. So let's open our console and let's run npx and then ncc and then, ncc and then build, and then the path to our input. So .github actions issue and then index and then our output, so -o. We will need it to be in GitHub actions issue and in a folder called dist. Right, so make sure you have the dist folder created in your issue, and I think we can now push and test. So I'm going to push and get back to you. I'm done pushing. Let's take a look at our workflow, and let's hope I don't have any typos. Unfortunately, I had a typo, of course. But let's take a look at our issue action. It ran successfully actually. However, the problem was that the output was not set. So if you take a look at the next step, we're not echoing the issue. So let's take a look at the issues. And our issue was created. It's our title and our body and our assignees. However, we just have a problem with our output. So let's fix it. And the problem is this octokit.issues.create function is an async function. So when you call an async function, you will have to add the await keyword in order to wait for the response to be put in this variable before running the next line, right? So what we've done is that we have successfully called the create issue and the issue was created. However, our response constant was still undefined and we are trying to access it here. So in order to wait for the response first, we will have to await. And so the set output line will not run until we get our response here. Right, so sorry for that, but also in order to use the await keyword, our code must be inside of an async function. So I know if you're not familiar with JavaScript, this might sound a bit weird, but this is how it's done. So we should put our code in an async function. Let's call it run and wrap everything inside of it like so. And just invoke it. So run. Right? So I'm going to push this fix and make sure our output is displayed correctly. I recompiled my JavaScript and pushed my code. Don't forget to recompile if you are following along with me. And then in my outputs, we have our output, which is the GitHub issue that was returned by the GitHub API, right? So that's it for JavaScript actions. Make sure to check out the other toolkit packages that you can find here. These might be helpful in your case. But let's now move on and see how can we create Docker container actions. So see you in the next lecture. Let's now see how can we create Docker actions. Unlike JavaScript actions, Docker actions will not run directly on our virtual machine. However, it will run in a Docker container. So this might make your action a little bit slower. However, it can be very useful if you would like to use certain tools, certain operating system, and so on. So what we're going to do in this lecture, we are going to recreate our very simple action that we created, which is logging a greeting. However, this time we'll do it using a Docker action and not a JavaScript action, right? So what we can do is we can actually copy our action.yml file from our JavaScript action. And then in my actions folder, I'm going to create a new folder. And let's call it hello Docker. And inside of it, let's create our action.yml file and paste. And all we will have to do now is just change this runs object, right? So now we are not going to use JavaScript. So this will be Docker. And then instead of main, we can have an image. And this can be an image from Docker Hub. So you can have Docker and then colon and then your Docker Hub image name and also tag name. But it can also be a Docker file in your action folder. So in our case, we're going to use a Docker file. So here we can pass Docker file. In this runs object, we can also pass environment variables that will be available in our container. So we can have key value pairs like so. However, we are not going to need that in our action. We can also have an entry point and we can have args. And we will take a look at these in a moment. So let's now create our Docker file. So inside my action folder, I'm going to create a new file, Docker file. And we can have a base image. And here you can put any base image. If you're going to write your action in a certain language, you can put the image of this certain language, which we will do later actually. However, for this action, we are going to do it using a shell script. So in this case, we don't actually need any specific language. We can just use a Linux version. So I'm going to use Alpine 3.11. And then in our action folder, we are going to have a shell script, which is going to be called entryPoint.sh. And when our action runs, when our Docker image is installed, we need to run this entry point. So here we can have entry point and the path to our file. So entryPoint.sh. But first we need to copy our entry point from our folder. So we would like to copy entry point in our folder to our Docker container in any path that we like. So let's say we will put it in this path, which is actually the path that we are using here, right? So if we decide to put it in a different path, you should have the same path here, right? Great, so since we have an entry point in our Docker file, we won't have to use this entry point in our action.yml file. You can have an entry point here that will be used in place of your entry point in your Docker file. However, in our case, we will not have to use that. And for the args, as you know, in our Docker file, we can pass a command and we can have a list of arguments, and these arguments will be passed to our entry point, right? But in our case, what would we like to pass to our entry point file? We would like to pass the input that the person using the action would choose, which is who to greet. So in our entry point, it will look something like, let's first add our interpreter. So we would like to interpret this script using sh. And our script will be something like echo and then hello, and then our argument. And we need this argument to be our input, right? So we can do that using the command, because this will be a dynamic input and not some hard-coded string. So what we can do is we can use the args value here. So this args is an array, and anything you will pass in this array will be passed to the Docker file as if it's a command. So if you have this, for example, it would be as if we have a command like this, right? But the difference is here we can pass our inputs, which will be a dynamic value instead of just a static string, right? So how can we do that? We can use an expression and then inputs and then our who to greet input. Let's copy it so avoid any typos. So in this case, our input will be evaluated dynamically and then passed as an argument to our entry point so that we can use it here to echo it. Alright? So whenever you are using a Docker action, you will not only have to define your inputs in this inputs key, you will also have to pass your inputs in the arguments array so that they can be passed as arguments to whatever file you are running in your entry point. Right, I hope that's clear. Let's now carry on and continue writing our entry point file. So why don't we open our JavaScript action in index.js and let's see what we will have to do. So let's say we would like to duplicate this JavaScript action, but now using a shell script. So here we had some debug and warning and error messages. And we did those by using the core package that is provided by GitHub, right? So how can we achieve the same thing using a shell script? In order to communicate with your GitHub runner machine and tell it to log a debug message or a warning message or set a secret and so on, you can simply just log something into your output. And this something must have a specific format, and when your GitHub runner machine sees that you are logging something in a specific format, it will know that it will have to do something. So for instance, if we would like to log a debug message, we can just echo a string in a specific format, which is : and debug, and then : and then our message. So say debug message. And when you print this message in this format, your virtual machine will know that it will have to log a debug message. Alright? And this can be applied to any language. We are using echo here because it's a shell script. But if you're using Python, for example, you can use print and so on. And actually we are going to write our next action in PHP, so we are going to see how can we do it using PHP as well. Alright, so let's see what else do we have here. We have a warning and an error. And this can be done in a similar way, but this one would be warning and error. Right, and then we had a set secret, which will mask some string. And to do that using echoing a string, we can echo and then : and then add mask, and then : and then our string, which in this case is our argument, if you would like to do it the same way we did it here, right? And next we need to set our output. So first let's see how can we get the time using a shell script. And to do that we can echo $, and then parentheses, and then date, and this will return the current time. So let's define a variable here, time, and let's set it to current time, and let's set our output, which can be done using : and then set dash output, and then the name of our output, so name, and our output is called time, and then : and then our value, which is the variable time. Alright, next what we did here is that we added this expandable log here, right? So we used start group and end group to do it, and this can also be done by echoing : group, and then : and our title. So let's say some expandable logs, and then here we can echo some stuff, and anything that we will echo here will be inside of this group. And to end it we can echo : and then end group. And finally we have we are exporting an environment variable here, and this can also be done using : set env, and then name, and the name of your environment variable, and then : and the value. So let's type any value here. And finally we have our error, but we'll take a look at this in a moment. Let's just first try what we've done so far. So in order to try it, we can go to our action workflow in our workflows, and then actions.yml. And let's, instead of running our hello action, let's run our hello docker action. And I think everything else would be the same. We are passing our input, and then we are in the next step echoing our output and our environment variable that we are exporting. So I'm going to push this and get back to you to see our workflow. So I'm done pushing, and I'm going to go back to our actions tab, and let's see what will happen. As you can see, our action is taking more time now because it's pulling our Docker images and so on. And after it's done, we have an error, and I'm really sorry for that, but I forgot a step, a very important step actually. So in our entry point, we have this entry point.sh file. And in order to run this as an executable file, we have to make it an executable file using our terminal. So I'm going to open our terminal, and then I'm going to type chmod and then +x and then the path to our file. So GitHub and then actions and then hello Docker and then our entry points. And by running this, we will make our entry point file executable. So sorry for that. I'm going to commit and push again and get back to you. So after pushing this fix, our workflow ran again and it was successful. So let's see our hello Docker action. And here we have our debug messages, warning messages, and so on. And we have our mask, our input is masked. And you also have our expandable logs. And let's take a look at our output and our environment variable. And as you can see, our output is logged and also our environment variable. So great, everything is working as expected. And I know this is a long lecture, however, let's just try our final thing, which is setting an error or making our workflow fail in our action. So in JavaScript we called set failed. However, in other languages it would be different. So in an SH script, we can call exit and then use a non-zero exit code. So let's say, for example, we have some condition, and this is just an example. So let's say we have a condition that is true, and we need to set our job to be failed if this condition is true. So what we can do, we can echo some error message and then call exit and any non-zero exit code. So non-zero exit code means an error, and so our job will fail. So I'm going to push this and test it, and this will be our final thing in this lecture. So I'm done pushing. Let's go back to our actions tab, and our workflow should be running and it should fail in a moment. So as you can see here, our hello Docker action has failed. And here we have our error message. All right. So that was how to create a Docker action. And this was actually a very simple one. Now remember, we have in our main workflow, our CI workflow, or actually in our issue and release, we were adding this code to send a Slack message. So now let's turn this into a GitHub action. But this time we are going to use Docker and we are going to write our code using PHP. And you don't have to know PHP, you can just watch. I just wanted to give you an example of how to write Docker actions using different programming languages. So see you in the next lecture. As we mentioned, using Docker actions, we can write our actions in any language we like. So let's write our Slack action using PHP. It's also going to be a very simple action. We'll just have to send this post request. However, let's do it using PHP this time, just as an example of using a different language, right? So let's first, before writing our action, let's write a PHP script that will send a Slack message, and then we can turn this script into a GitHub action. So outside of our current project, let's create a new folder and let's create our PHP script. So I'm going to change to my desktop, and then I'm going to create a new folder. I'm going to call it Slack PHP, and then I'm going to change to this folder, and I'm going to open it in my code editor. Right. And in this folder, let's create a new PHP file I'm going to call it script.php. And inside of this script, we would like to send a post request using PHP to our Slack webhook in order to send a Slack message. So there are multiple ways that we can use in order to send a post request in PHP. However, I'm going to use a package, this one called requests, which makes sending HTTP requests easier. So to use this package, I'm going to use Composer, which is a package manager for PHP. So if you're not familiar with PHP, Composer is like the NPM of PHP. So if you're following along with me, you will have to have Composer installed on your machine. But this process can be different for different operating systems, so make sure you Google how to install Composer on your operating system. Alright, and after installing it, you can come back here and continue. So to install this package using Composer, we can use run this line here. So I'm going to run it inside of our folder in order to install our package. It took a while and now it's installed, and now you should have in your folder a vendor folder and also composer.json and composer.log, right? So let's now use our package, and in order to load it, we can require once and vendor and then autoload.php. And this is how we load our Composer packages. And then we will also have to initialize our requests package by having this line at the top of our file, right? And now we can use our requests package to send any request, right? So what do we need to send? We need to send a post request to our Slack webhook, right? So remember the webhook that we created in our Slack application. Let's copy the URL for that webhook, and let's create a new variable, response, and let's call requests, and then post, and then our webhook URL. So let's paste it. And then as a second argument, we can have an array of headers. So remember in our workflow using curl, we sent a header content type application JSON. So let's copy that from here and put it here and just modify it to be a PHP array. So, right. And then as a third argument, we can pass our data, which remember, it was a JSON with text and then our message. So let's have an array here. And in this array, we will have our text and then let's say some message. Oh, sorry, this is PHP. So, right, but this will have to be JSON. So we can just JSON encode this array. All right. So let's log our response and let's try to run this file. So I'm going to var dump my response, right? And then we need to run this file. So in our terminal, we can call PHP and then the path to our file. So you will have to also make sure that you have PHP installed on your machine. So PHP and then our current folder, script.php. And it did nothing, so we probably have some error here. So yeah, this is JSON encode and not JSON array. So let's run our script again, so PHP and then our file. And now I got a Slack message. I think maybe you can hear it. And if I open my Slack, here I get my some message. And here in our terminal, we have our response. Right, so what do we need from this response? We need to check if we have an error or not. And to check for that, we have a key called success, and it's a boolean, and it will be false if we have any error, right? So let's here check if we have any error, and if we have any error, we can log something. So if not response success, let's echo error, And then let's try this by maybe adding something to our webhook URL so that we can get an error. So I'm going to call my PHP script.php again. And here we have our error. And actually our error message will live inside response.body. So if we echo response body, we can get our actual response error. Right, so we have here invalid token. Great, so now we have a PHP script and we would like to run this using Docker in our GitHub action. But first, let's add one more feature here in our script. I'm going to remove the random things that we added here. And when you send a Slack message using a webhook, you can not only send just some text, however, you can also make your message have some formatting, have some buttons, and it can also be interactive and so on. So here in this Slack message builder, I'll put you a link to this. Here we have a drag and drop thing that we can build our message template with, and then it will generate some code, and this is JSON that we can send in our request, and our message will be formatted the way we designed it, right? So I'm going to select a template here, and I'm going to choose this first one. So here we have a message, and then we have some like a table here, and it has some information. And in our case, why don't we use this table to put information about our workflow? So when we run our action and send a Slack message, we would like to put here information about the event name, the branch, and so on. And here we also have some buttons, but I'm going to remove that. A Slack message can also be interactive and have some buttons that can call some APIs and stuff like that. However, let's keep it simple for now and just have this template, right? And now we have this JSON that we can use. However, here we are using PHP, so we are using a PHP array and not JSON. We are encoding it to JSON, but we are using a PHP array. So we cannot just copy this and put it here. So what I did is that I converted this into a PHP array, and I'm going to paste it here, and you can copy it from the repository if you would like, right? So I'm going to keep JSON encode. I'm just going to remove our array that has our text and then put our new array, right? So here we have our blocks, like so, an array of blocks. And the first one here is of type section, and it has some text, which is this block. So our first item in the array, type section, and it has a text block. And then a second section, which has some fields, and each field is one of these items in this table, right? So here we have our second section and fields, and an array of fields that we will change when we create our action to have some dynamic data, right? But let's for now just try this and make sure it's working. So I'm going to run my script, PHP script.php, and then in my Slack, now we have a message, and also we have this information here that will be dynamic when we create our action. So great, let's now turn this into a GitHub action in the next lecture. So now that we have this PHP script, let's now turn it into a GitHub action. So first, let's figure out what inputs will we need for our action. So here we have our webhook, so this will be the first input. And we also have our message, so the second input. But then these fields will be dynamic. They will have information about our workflow, but they will not be inputs, right? So only two inputs. So let's go back here in our React app folder, and I'm going to create a new private action. So inside of this actions folder, let's create a new folder. Let's call it Slack, and our, of course, action.yml file. And instead of typing this boring file, I have it here ready. And let's go through it. So we have a name, an author description. And then in our inputs, we have our Slack webhook required and our message also required. And then of course we are going to use Docker using a Docker file. And as we learned a couple of lectures back, we have to pass our inputs as arguments to our entry point in our Docker file, which we will create, right? So if you need to copy this, you can find it in the repository. And let's also get the other boring stuff out of the way. So in our workflows, in our actions workflow, which we use to test our action, let's add a step that will test our Slack action. So here I have ready this step that I pasted, which will just send a Slack message. So it will use our action in actions and then Slack. And we will give it a webhook and a message, and the webhook, we already have it in our secrets in Slack webhook. Remember, we had a secret called Slack webhook in our repository. Great, so now when we push our code, this step should run and we can test our action. So let's now actually write our action. And to do that, let's copy the code that we've written in our PHP script. So what we need to copy is our script, our composer.log, and our composer.json. We won't have to copy vendor. Vendor is actually like node modules. It can be generated if you run composer install, and usually you don't have to push this folder in your repository. So using Docker, we will run composer install, which will install the packages that we have in our composer.json file. So let's only copy these 3 files and put them in our action folder, our Slack folder, right? And now it's time to create our Docker file, right? So a new file in our Slack folder, Docker file. So what do we need to do here? We need to have a base PHP image. Of course, we are running a PHP script, so we need to have a PHP image. So I'm going to use PHP version 7.4.2. And then eventually we will have to run our script file. So we will have to run PHP and then run a file. But before that, we will need to run composer install to have our vendor folder, because in our script we use our vendor folder. And then we also need to copy our script file from our folder to our Docker container, right? And we'll actually also need to copy our composer.log and composer.json files from our folder to our Docker container, so that when we run composer install, composer will know which packages we need to install, right? So first of all, this PHP image does not have composer installed. So if we try here to run composer install, this will not work. And so what we can do is we can use this composer image from Docker Hub as a base image instead of the PHP image. However, this is not recommended. It is recommended that you use a base PHP image, and if you need to use composer, you can add a line in your Docker file, this one. So I'm going to copy it and put it here, and by having this line you can use composer in your container, right? Great, so now we are running composer, but we don't have any files in our container. We need to copy our files first from our Slack folder to our container, right? So let's first have a working directory, and let's set it to, conventionally it's user /source/app. So this will be the path that we are going to copy our files into. So we're going to copy our current folder, everything in our current folder. We will copy it into our working directory, which would also be our current folder, so dot and dot. And now we can run composer install, and it will run in our app directory, which has our composer log and composer.json, because we copied everything in this directory. However, to run composer install, you have to have zip installed on your machine. And using our PHP image, we don't have zip installed in this image. So what we can do is we can install it manually by running apt-get update and apt-get-y install zip. Alright. So these are some composer details. If you're not using composer or not using PHP, things will be different here. However, in our case, we will have to do that. And now finally, we need to run our PHP file, our script.php, and this is going to be in our working directory and then /script.php, right? So let's copy this and then /script.php. So this is great. We now have everything ready to run our script when we run our action. However, in our script, we are hard coding some stuff here. And we need to get some stuff from our inputs and also some stuff, information about our workflow, which in JavaScript actions, we used the GitHub package to get. However, we're now using PHP, so we cannot use this npm GitHub package, right? So I'm going for now to remove this request. So let's comment out everything here. And now we need to know how can we get our inputs and how can we set outputs and how also can we get context information about our workflow now that we are using PHP and not JavaScript. So for our inputs, as we have defined here in our action.yml file, we are passing some arguments to our Dockerfile entry point. So how can we get arguments that are passed to the PHP command? In PHP, we can use a variable called argv. So let's var dump our $argv file. And let's also var dump our environment variables. So $_env. And now I'm going to push our action, which will run because we have it here in our actions workflow. And let's see what do we have here in these two variables so that we can know how can we populate our request with our inputs and our context information. So I'm going to push this and take a look at it in the next lecture. So see you in the next lecture. In the previous lecture, we pushed this action where we are running a PHP file and logging our argv and our environment variables. So when I pushed, our action ran successfully. So let's take a look at send a Slack message step. And if you take a look at these logs, you will find that composer install ran successfully and it installed our requests package. And then we also successfully ran our PHP script file and we have our logs, which are our argv and our environment variables. So inside of argv, we have an array of all the arguments that we passed to the PHP command. So we already have a first argument, which is the path to our script. So here it is. And then we also have the other arguments that we passed in our action.yml file, which will be the Slack webhook and our message. So here we have our webhook and our message, which are our inputs. So this is one way to get our inputs in a non-JavaScript action. However, it can be a bit confusing because we are getting our inputs using an index here. So if you, for example, get your message using index number 2 here in our script, like so, it can be a bit confusing when you are reading this code to know what will exist in this index in the argv array, right? But it will work. However, the second way to get it is using environment variables. So here we are logging our environment variables, and GitHub will actually turn your inputs into environment variables that you can use. So your inputs will be prefixed with input, and then underscore, and then your input name. However, your input name will be converted into uppercase. So here we have our input message, and we should also find our input Slack webhook here. And now we can use these in our request. So I'm going to copy the Slack webhook environment variable. I'm going to get this back. And now I'm going to replace our hard-coded webhook with env and then our environment variable. And same for our message, which we add here in this text key in the first section. We will also get it from env, and then our input, which was called input underscore message. Right? Great. So now what about our context information, which we need to populate here? So we have a couple of fields. So let's say we need to add our repository name. So repository, and let's also add our event name. And let's have a couple more. So I'm going to duplicate these, and we will have our ref, and we will have our SHA. All right. So where can we find these information? It will also live in your environment variables. So these will be prefixed with GitHub. So let's find our repository, which is here, GitHub underscore repository. And now we can replace this dummy text with our env and then our environment variable name. Right. So let's copy this and put them here and here. And now we just have to replace this name with our event, which is GitHub underscore event underscore name. And our ref will be in GitHub underscore ref. And finally, our SHA will be in GitHub underscore SHA. Right. So now we can get rid of these. We don't need to log them. And what we have left now is, remember in our first Docker action, hello Docker, in our sh file, we can log the bug messages and set outputs and so on by echoing some strings in some format, right? So now how can we do that in PHP? We can do exactly the same. So let's say we need to echo, to log a debug message. We can just echo : debug, and then : and our message. So let's say sending a request to Slack. But notice here that in PHP, if you, for instance, echoed something here that is not related to this debug message, this string here will be concatenated with this string and will be logged as a part of this debug message. So in order to tell the GitHub runner that we need to stop our debug message here, we can just echo a new line like so. Alright, and this will apply for any instruction string that we need to echo. And we can actually do one more here. When we are dumping our response, why don't we put this in a group like we did here, because the response will be a bit long. So why don't we make it expandable? So I'm going to actually copy this from here and put it here, but now we have to add a new line. And this let's call this group Slack response. And similar to here, we will also have to end our group. Now our semicolon, of course, and our new line. And finally, if our request failed for any reason, we need to set our step as failed, right? We already know how to do that in JavaScript actions. And here we did it by calling exit1. And in any language, you will find something similar to this. So in PHP, it's also called exit. And we can pass it an exit code. So 1. Alright, so we've done a lot, and now it's time to test. So I'm going to push and get back to you. So after pushing, I of course realized that I have a typo. So these should be double quotes and not single quotes in order for the new line to work, right? But anyways, I fixed it and pushed again, and our step also failed for a reason, and the reason is when we pushed, remember before replacing our webhook with the environment variable, we pushed our webhook directly to GitHub. And this webhook should be a secret, so when Slack detects that your webhook is pushed into a public repository, it will disable your webhook. And that's why our step failed, which is actually good in order to test our error here. So here we got a... First of all, let's take a look at our debug message. So we have it sending a Slack request, this one. And also we have our group. So here we have a Slack response group that can be expanded, and we can see our Slack response. And we also have our error, no service, which is returned from Slack because our webhook was invalid, and we also exited with an exit code of 1, which we've done here. So it's actually good that we had this error to test our workflow, but now let's generate another webhook to test sending a message. So I'm going to, in my Slack app, I'm going to add a new webhook. And general allow, and just going to copy it and put it back in our secrets. And replace it with our old Slack webhook. Right? So what we can do now is, remember when we have a failed workflow, we should have a button here to rerun it. And now when we rerun it, we should have our Slack webhook and it should work. So let's wait and see. So as you can see, I just got a Slack message. Let's take a look. And we have our message, we have our information repository, event, and SHA, and our ref. Great. So that was it, creating a GitHub action to send a Slack message using PHP, which was, I think, a really good example to using Docker actions. However, now let's move on to our final thing in this section. So as you noticed, up until now we have only created private actions. So let's see how can we create a public action and publish it on the actions marketplace so that other people can use it. So see you in the next lecture. Up until now we've only created private actions. So let's finally see how can we make one of these actions a public action and publish it on the GitHub Actions marketplace so that other people can use it. So let's say we would like to turn this issue action into a public action. All we have to do is just put this folder in a separate repository, public repository, and just modify some minor stuff as well. So remember, this was a JavaScript action. So what I'm going to do is I'm going to use a boilerplate which is provided by GitHub in the actions username in a repository called javascript-action. There is also a boilerplate for TypeScript, and it's called TypeScript-action. However, let's keep it simple and use the JavaScript action. So this boilerplate has some packages installed that can help you do some JavaScript testing and also linting and stuff like that. And in order to use it, you can just clone it and then push it to a repository on your GitHub account. However, we have a button here that can make this process easier, which is use this template. And when you click on it, it will clone this template into a new template on your account. So I'm going to call our new repository open issue. And of course, it has to be public. So create. And it's going to take a while to clone the boilerplate. And now we can just clone it locally in our machine. So I'm going to clone it to my desktop. So git clone. And then I'm going to change to open issue and open it in my code editor. Alright, and now we can install our npm dependencies by running npm install. And after npm install is done, let's take a look at our package.json and take a look at the scripts that we have here. So we have a lint script which will run ESLint. And in case you don't know, ESLint is a plugin that will help you detect JavaScript errors. So we can run this script to see if we have any errors. And we also have a script called package which will run ncc to compile our index.js into a folder called dist. And this is what we've been doing when we were creating JavaScript actions. And we also have a test which will run ESLint in addition to jest. And jest also, if you don't know, is a JavaScript testing library where you can write some unit tests if you would like to test some JavaScript functions that you've written. So here, for example, we have index.test.js and we have an example of some tests here. However, we don't have to worry about that. That's a different topic. We just focus on publishing our action. So here in index.js, we also have an example of an action. However, we need to copy the action that we had in our React app repository, which was in GitHub issue index. So let's copy that here. And notice that we are using the actions core and actions GitHub packages. However, here we only have the actions core installed. So let's install actions GitHub as well. So npm I and then actions GitHub, and this will install it. And also we need to copy our action.yml. So here we also have an example. However, we need our action.yml. Let's put it here. And now let's try our scripts. So let's try npm test. And it will run the example tests that was included. And for some reason it's failing. But let's actually remove this test file. We don't have to worry about that for now. So I removed index.test.js. And if you run npm test again, it will also fail because by default jest will fail if it didn't find any tests. So in order to avoid that, we can pass jest a flag, pass with no test, right? If you run npm test again, everything is passing. So remember, npm test is running ESLint and jest. So let's try to have some JavaScript error here. Let's define a constant and never use it. And now if we run npm test, we will get an ESLint error. Alright, so let's remove this. So what's the point of npm test script? Here in the GitHub folder, we have a workflow called test.yml. So whenever we push our action into GitHub, this workflow will run and it will run our tests. And in addition to that, it will also run our actual action to make sure it doesn't have any errors. Alright, so this is what we get from this boilerplate, some scripts to run some tests, and also a workflow to run our tests when we push to GitHub, so that we can be notified if we have any JavaScript errors or some tests are failing and so on. But let's also not focus on this for now, and now we need to publish our action, right? So remember, we have to compile our JavaScript code, and we already have a script to do that, which you've seen, which was called npm package. Or sorry, this will have to be npm run package. So this will run ncc and it will compile our files into our dist folder. And what we will finally have to do is, in our action.yml file, we will have to add some branding. So if you take a look at the GitHub Actions marketplace, you will find that every action will have an icon and a color. So let's go to Actions. And as you can see, we have a color and an icon for each action that we have on the marketplace. So we need to set an icon and a color for our action, and this can be done here in actions or action.yml in branding, and then icon and color. So the icon can be one of these icons. I'll put a link to this. So since our actions opens an issue, so I'm going to choose one of these alert icons and put it here. And for the color, I will choose purple. Right. And finally, in order for our action to be accepted on the marketplace, we have to have a README file which explains how to use our action, what our inputs are and outputs, and so on. So I'm going to remove what we have here in our README file. And I'm going to paste something that I've already written. And in VS Code, we can preview MD files by clicking on this button. So here I have my file, just a list of inputs and outputs and an example on how to use it. Right? Great, so I'm going to push what we've done so far to our new repository. Alright, so after pushing, if we go back to our new repository, open issue, we should find our new README file. Great, so finally, in order to publish our action into the marketplace, we will have to create a release and give it a version. So here we actually have a button to do that. So let's click on draft a release. And here it will let you know if you have any errors that will prevent you from publishing your action to the marketplace. So in my case, my name must be unique. So let's just add anything here. And I'm going to push this change and go back to create a release. So I pushed this change, and now if we refresh, our error is gone. And we have our information, our icon, our color, and the README exists, and we can choose a category. So let's say reporting and code review, just any random thing for now. And we should now give it a version, which is usually something like v1 point something. It is recommended to use semantic release here. And let's also give it a title, and let's publish. Great, so now our release is created and our action is published, and if we click on this link, we should have a link to our item, our action in the marketplace. with our icon and our color, right? So let's test now and see if it's working or not. So remember, in our React app project, we had a workflow, the actions workflow, when we were testing our private actions. So let's actually change the private issue action into our new action that we just created, our public action. So now we can reference it using my GitHub username, and then our repository name, which we called open issue, and then a version. If we now push this into our React repository, it will not work, because here we are trying to reference a tag called v1. However, in our open issue repository, we do not have a tag called v1. We have v1.0.0. So if we put here 1.0.0, it should work. However, for convenience, what you should usually do is you should create a tag called v1, and it should point to your latest v1 release. So if your latest v1 release is v1.1.1, then v1 should point to this release. Alright? And to do that, we can run a couple of commands, which we can find here. I'll put you a link to this. It's some documentation in the toolkit repository. And we can run these couple of lines, which will create a tag called v1 and point it to our latest commit, which is exactly what we want. So I'm going to run this in our open issue repository, right? Not in our React repository. And then this. And if we take a look at our releases now and tags, we should find our v1 tag, which is pointing to our latest commit, which is the same commit that our v1 1.0.0 is pointing to. So now when we push this to our React app, it should work. So I'm going to push this to my React app and get back to you. I'm done pushing, and now if we go back to our React app repository and actions, we should find our action. So let's wait for this Slack to finish, and it should run afterwards. Alright, so our action has succeeded, and if we take a look at our issues, we will have an issue that was just created, and it has our title and body and assignees as we pass them here. Right? So this was how to make your actions public. And something you can do, as you noticed here, when we create a release for our action, we can use semantic release. And if you remember in the previous section, we have automated this process in our workflow. So maybe it will be a good exercise to automate your semantic release process if you are creating a public action. And maybe you can also, when you create a new release, run a workflow that will check if you have a new version, and if you have a new version, you can create a new tag and point it to your latest version, like what we've done here, but we've done it manually, right? So I think that would be a good exercise. However, I will leave it to you. And this will be all for creating GitHub Actions. And I think now you should know everything that you need to know about GitHub Actions and workflows. So thanks for watching, and I hope you enjoyed the course, and see you in the next one.